And then, of course,
Welcome to GoTo Meeting. Online meetings made easy. You are the first caller and will be placed on hold until the next caller arrives.
Specifications of the people. And then the critical part in terms of the actual interoperability of the information is this idea of information exchange. And so what we've done is looked at what kind of information do we have, what are people interested in, how are we going to deliver these different sorts of information. So there's an information exchange for the metadata, the actual description of the resources. There's temperature data from wells, for describing well headers, for locating well logs, for describing active faults. We've gone through and figured out these various kinds of data types that we're interested in. And for each one of those, we develop a service protocol, which is how do you ask for information on the internet. And for that, we've mostly been able to use existing services that are out there from the Open Geospatial Consortium. We'll talk about that a little later. But the other important part of it is this idea of the content model. So we look at, say, if we want to do borehole temperature data, what kind of information do people actually have that they're going to be interested in? And so we develop a content model, which is just a list of, here's the kinds of information we want to know about borehole temperature measurement. Here's the kinds of information we want to know about an active fault. Here's the kinds of information that we need to know about hot spring description. So there's a content model, and then given that information, we say, well, how are we going to encode that to send it over the internet? And that's the interchange format. And we've been using XML. There's lots of other ways it could be done. XML is a pretty common approach, but we've been using XML to define the interchange formats. And so that's just, when you get down in the weeds of how the information is actually getting sent over the wire, that's what you would see, these XML files. So why is it worth the effort to do this extra work to make the information interoperable? So one of the principal reasons is to make life easier for our customers. They don't have to figure out new data structures. If they get data from Arizona and from New Mexico and from Colorado, they can get it in the same format. And they don't have to spend a bunch of time figuring out, okay, which field in this table matches the field in the other table, and how am I going to put it together, and who's using centigrade, who's using Fahrenheit, and which wells have depths and meters, and all that stuff that we typically have to do now. So the idea was to get beyond that, one thing. The other thing is that by creating this large body of information that's presented through a standard set of interfaces and interchange formats, this creates a market for people to write applications. So it promotes the development of software that allows people to use the information from the network. Our job, and this part from the DOE, has not been really to develop these end-user applications. Rather, we're focused on providing the information. But it creates this market for people to look at developing applications to consume it. The description of the resources is easier because if you're using a standard interchange format, you don't have to write all the detailed description of how that format works. You can just point at a specification document and say, this information is being presented using this content model, and you're pretty much done with that part of the metadata. So it makes describing your resources easier. And it also makes it easier to maintain the data in the long run if you have sort of standardized formats for things that people get used to using and used to maintaining. So those are kind of the motivations for this interoperable approach. So I'll talk a little bit now, a little bit more detail about the technology. As I've said several times, the idea is it's a distributed data system. So we have users, there's a catalog that describes what's there, and then there's what I just call the data space, which is the World Wide Web, is our data store. So the actual information is on the web, and for the most part, we don't need to know, and theoretically you shouldn't have to know where the information is actually coming from. You just have a URL that links to it. And yes, of course, as data providers, that's pretty important for us to keep track of where it actually is. But what binds this all together is this idea of these web services operating over the internet. So that's what makes it a system. The conventions about how these connections are made between the data and the users and the catalog. So we're dealing with three types of information for the most part. Actually, at this point in the program, we're also dealing with the first two. So there's the data, the actual information about the Earth. The metadata, which is the description of these various data sets that are Then as the system evolves, there's this idea of the annotation, the sort of Web 2 kind of things, where the community can start adding additional information about this data set was useful for this purpose, or I tried using information about how things work, ratings and stuff like that, that will be added on as we evolve. But the technology for implementing that is still in its infancy. So how do we approach developing this? We there's a lot of information out there. We all have lots of stuff, and the question was, how do we decide what to focus on? So we set up some domain steering committees that talked with the experts from the geothermal community to figure out what kinds of information are interesting and useful for reducing risk in geothermal exploration. And so from this, we basically got a collection of user stories and content models and ideas about sustainability. But this committee then looked at the priorities for what needed to be done, and they've been reviewing the content models as they get developed, and then providing recommendations to the project management to determine what aspects to focus on. And as the states have developed their statements of work, and these get reviewed by the Science Advisory Board, that looks at the work plans and tries to sort of coordinate the work that's being done and keep the priorities aligned across the different states. So that's been how we've been directing the focus on the data. In terms of the actual data that are being delivered, we have this important idea that we talk about interoperability tiers. And these have to do with the formatting of the data. And the Tier 1 data, which is far and away the most common things that we're seeing, are just unstructured data in files. And it might be something like this, a scan of a log file that some driller made somewhere. But typically this is Word documents, text files, TIFFs, unstructured. It's things that are useful for people. We can look at it and get information from it. But it's not really amenable for machine processing. So it's got important information, but it's not something that we can use automatically. Tier 2 data are things that are structured. So in some kind of database format now, typically in Excel spreadsheets, a lot of access database, there's also DBF files, a variety of different things. These are generally file formats that are designed for use by computer applications, but typically they're spreadsheets, let's say, that the geologists just set up as they were collecting the data, and they made it quick and dirty to get what they needed to done. And if you looked at 6 different spreadsheets from 6 different people that are theoretically about the same kinds of information, let's say, describing a hot spring or a fault, you would have different tables. So you get a little bit of structure. You can do some machine processing, but each one is individually unique. You have to figure it out. And then what we call Tier 3 is using this idea of an information exchange. So the data is structured, but it's also using a standardized format. And so this is where you get to the point where the information is now designed for processing by machines. And you can start to chain software together and let the computer system do more work for you, so you can focus more on figuring out the heart of the geology. So to become part of the system, if you're going to introduce resources in any of these tiers, everything has to be described on metadata. So these are all information resources, and each individually accessible resource that we're interested in needs to be described by a metadata record. And a lot of the file-based things, you can index with Google, and we're doing that a lot. But when you start dealing with data sets of GIS data, shapefiles, things that are in Excel spreadsheets, they don't index with the commercial indexing systems. So in order to make these things discoverable, at some point in the chain, somebody who understands that data set has got to write some kind of description about it. Once you have that written description, then you can start indexing and using some of the smart searching capabilities that are out there. But this is always the starting point. We need some kind of description of what's in the data set. And ideally, for it to be useful in the future, there has to be enough information that the next person who tries to use it can understand how that information was generated, know enough about its provenance to know whether or not they want to trust it. Can I use this? Is this going to be reliable? So for the various other tiers then, if it's Tier 1, you just have to make the file accessible on the web. We all have web servers at this point, and putting files on a web server is pretty straightforward. So you get a metadata record in the catalog, it has a URL that points to the file, wherever it is. It's part of the system. For Tier 2 data, the trick there is because all these data formats are unique, when you create the metadata record, you have to describe, okay, what is the column that has the heading WQRP? What does that mean? What's in that column? If somebody gets a spreadsheet and has a bunch of unintelligible column headings, or they don't know what units were used for the data that are in there, it's not good or useful. So for this structured but not standardized information, the metadata has to include enough information about the data structure that is useful. In Tier 3, the added work means that the data provider has to do the data integration. So at Tier 2, the data consumer does the data integration. They have to figure out what's in there and how to integrate it with what they want to do. For the Tier 3 data, we, the data providers, do that initial data integration, figure out how to map the data we're starting with into this standard format. But it also means we don't have to fool around so much with the metadata description. We'll talk a little bit about the catalog, which is a sort of essential and key component of the system. The foundation of this is a metadata content model. You'll hear people go on. There's all kinds of religious wars about metadata. But in the end, from our experience to this point with what we've been doing, we sort of have come to the point where, what's the minimum amount of metadata you need to know about a data set in order for it to be, that metadata to be useful for somebody to get a clue, is this what they need? So what it kind of is boiled down to, does it have a title that tells you something useful about what it is? Because we're mostly dealing with geologic data, the location is an essential thing to know. Where is it? So you have to have some kind of extent information, and that can take a variety of different forms. And then the third thing is, because it's on the web, or you don't know where it is, there has to be some information in the metadata about how do I get it. So this, in the end, is, if there's not this much metadata information, the metadata record is sort of, that's at that point say, oh, it's not useful. We either need to get more information about it, or it's just not going to work. Above and beyond that, there's a lot of other stuff we'd like to know. So having a text description of what's in the data set. How does it work? Where did it come from? Keywords are important. Common process. Mostly we've been using a sort of tagging approach. People just put in whatever tags they think are important. Who created the data? Who's the originator? When was it created? Is it specific about some specific time period? Is there an identifier for the data set? So those are the sort of next level of importance. And then beyond that, there's additional information. Things like, well, can anybody look at this? Do I need a password? Do I have to pay for it? What language is it in? Is there any information about the quality of the resource? The lineage, the provenance, how was this data set created? Where did it come from? What kind of processing was involved? It's nice to know if there's a citation for it. Is it from a publication? What's the citation for the publication? And then contact information for the distributors. So you might have a URL that tells you it's at that URL. You try to get it, it doesn't show up. You want to know, well, who do I contact to find out why the URL isn't working? So you need to know who the distributor is. So that's distribution information. And then finally, there's some bookkeeping information about the metadata record itself that you want to know. When was the metadata record created? Who's the contact for the metadata? So if you see a metadata record that has something incorrect in it, you misspelled your name, how do you get it corrected? So you need to know who's the contact to talk to about fixing the metadata record itself. What's the specification used? How is the metadata encoded? What conventions are used for the metadata? And does the metadata record have an identifier? So this is the sort of the content model that we've been using for the metadata describing the resources in the system. And so what we have is this idea of a metadata cloud. So we're all creating metadata about the resources that we have available. And what will happen is these metadata records have to be made available to be harvested to introduce into, in our case, we'll have an NGDS, an aggregating catalog. So we want to have, the idea is that there's a single point that users can come to search and find out about resources that are in all these various catalogs, different surveys. So there'll be a portal, the NGDS portal, will be collecting metadata from all the data providers to make it search, so you can go to one point and search and find out about resources in all these locations. So those metadata records will say, oh, here's, this is information from the New Hampshire survey, and here's how you get it. Or it will point to wherever the source is. To create the metadata, there's a variety of different approaches. There's a web-based interface that we use to maintain, and anybody, I think most of the state participants have logins here. This is useful for creating individual metadata records through a form, and then they get introduced in there. That gives you a place you can go and edit the metadata, and then the metadata records that are created there. When you publish that metadata record, it gets pushed to the catalog and becomes publicly visible when you go to the search page. We also have a process for putting the metadata in spreadsheets. So for most of us, we have a bunch of stuff online already. There's some kind of listing. We already have some sort of catalog for what's there. So the approach then is to figure out how to map the existing catalog that you have into this template form that we can process and load into our catalog. The search client is at search.geothermaldata.org. This right now is sort of a prototype. I'll talk a little bit more about the work that's being done on the new aggregator. But right now we have this operating search endpoint. It's using a catalog service interface. It's a web application that talks to the metadata aggregator through a standard service using the metadata interchange format, and allows you to search the aggregated collection of metadata for the catalog. You can go in there when you find something in here, you can click on it, and because of the way the metadata are constructed, the different resources might have a variety of different ways of getting it. So you might have a lot of the data sets are geographic, so you might be able to get it. We have it in an Excel spreadsheet. We also have a shapefile. It's also available through web services. So there's this idea of multiple distributions. And based on the kinds of distributions that are available, there might be various things you can do with it. So in this case, this is a geologic map that's coming through a web service. You can put it in ArcGIS and ArcMap if you want to. We have another application that is actually an extension that works inside of ArcMap. That circle's supposed to be around that button. I haven't got it budged. But anyway, you can go in there and search and see. I'm interested in live data. In this case, I'm looking for a geologic map. So you find, oh, there's an Arizona map, and you can say add it. And this process works entirely through what's in the catalog and what's in the metadata record. The software can get that metadata and say, oh, this is available as a map service. I know how to add that to my ArcMap project. And it brings up the data, connects to the service, and adds it to your project here. So this is the kind of automatic data access that we're trying to implement using these standardized metadata services. So the information exchanges, I want to talk a little bit more about that. So we're moving from a web for people to the web for machines, right? So that more of the software can do more and more of the connection between these various resources to make it easier for us to get at the information we want. And so the content model defines information content, scheme. There's a variety of different encoding formats, mostly XML, but people are moving towards other things like JSON. There's also NetCDF that you may be familiar with. So there's no one format, and this is part of the idea in this distributed system and these information exchanges that we have to be able to evolve as the technology evolves, so that these exchanges will be versioned, and over time, new versions can be we can update things to keep up with the technology. Right now we have like 28 content models or something that we're implemented and using. So this is the list of them that are out there. How does all this work in action? So we have this, the data can be delivered in a variety of different, what we might call delivery platforms. So the simplest thing we already talked about is this idea of a file download. So it's just a URL, You get a file, the person has to figure out what's in it and be able to understand it, and there's not a lot of automation that you can do. For a lot of us are familiar with web map applications of various sorts. So the ArcGIS Flex API promotes, makes it pretty easy to set up these kind of applications. So it's a program that runs in your web browser. Typically you get some kind of map interface, you can do some kind of query and visualization, and it typically gives you some way to download the data. But again, it might come, you don't know exactly what the data structure is going to be. It might be tier 2 kind of data in some arbitrary format, or it might be tier 3 data. But it gives you some way to filter the information before you do the download. So in the end, you get a file, but you have some control over what you get in the file. And then the other kind of platform that we're promoting and moving towards is this idea of a web service, where you can have software send requests to the service to get precisely the information that is needed for some particular operation. So it's designed for machine-to-machine interaction. It lets you do filtering and processing on the server side to make life less processing on the client side. In order to implement these web services, I'll talk at the end in a few minutes about this CCAN node in a box application that's being developed as part of the design and build project. And the idea is to have an application that will let you set up a node that will implement these web services with a minimum of effort. So there's this sort of two-dimensional matrix of the tiers that have to do with the data formatting, and then this idea of these different platforms where you're either downloading or you're presenting the data in a web map application or through a web service. And so the tier 1 data can be, tier 1 data is only amenable to file downloads, but tier 2 and tier 3 data can be delivered through applications or services. So for the data delivery, the web services, what we've been focused on are services from the Open Geospatial Consortium, which is an international standards outfit that's developed a variety of different specifications for different web services for delivering geographic information. So there's the map service. This provides you a map, a symbolized portrayal. It gives you basically a little georeferenced image that will work in almost any kind of geographic information software that's out there now. The feature service is designed to access attribute data. So it's like you can access individual database records. And then there's what's called a coverage service for continuous raster data. So if you wanted to get, let's say, a gravity anomaly map as a grid, that would come through a coverage service. So the nice thing about these is because these are standards that are relatively widely used for standards, they work in a lot of different applications. And so we don't have to build the client software to utilize the data that we deliver to these services. So again, we're trying to get a separation of concern where we as data providers can focus on the data, providing the data, and spend less of our effort building web applications for people to use the data. One of the critical things about this idea of distributing things to these map services is that we have to have a consistent map legend in order to integrate things visually. So this is showing from fairly early on in the project temperature data, borehole temperature data coming from a variety of states. And you can see that one state didn't have the right map legend loaded into their map service, so the data ends up doesn't fit together with the other stuff. So as part of deploying the map services in this system, we have a collection of standard legends that we use for symbolizing things like voltage temperatures and faults. Each kind of data type also has associated with the standard legend for the map service. The feature services, OGC, so it's a standard encoding for the content that's designed to access information at the record level. And so it's like being able to do SQL queries over the web. If you're familiar with database access like that. And here's an example of the data access application we've built demonstrating this. And what we've got here, this is the Four Corners region with Arizona, New Mexico, Colorado, and Utah. And we're looking at borehole temperature data from 4 different states. This is coming from the feature service now, so the colors that are put on here are arbitrary. It's not coming with any kind of portrayal. But the idea here is with this application, you could draw a box and select a bunch of points coming from these 4 different services, download the data, and because it's all using the same interchange format and content model, those data sets can be split, put into one table, combined, converged into one integrated data set with no effort on the part of the data consumer. So this is the sort of goal where we want to get to with this idea of this distributed data system. One of the other important parts of the system is this idea of the identifiers. So each resource has an identifier associated with it, and we're using HTTP URIs that can be referenced on the web, using web browsers. And these allow you to access the information and identify it. And it starts to link data resources. So these are like foreign keys in the database, but they work on the web. Start to link the data together so we can have links from the well to the well logs, from the well to the temperature measurements from the well log back to the well point. And it starts to really develop a system of linked open data for this geothermal system. So one of the important infrastructure components is the repository where these information exchanges are maintained. So we have a schema repository. It's at schemas.usgym.org, and basically within this there's a description of each content model. It has a link to this field list, links to the different versions of the interchange format, has all the documentation for the content model, a link to the XML schema that's used to specify the interchange format. So this repository is really sort of the core for this interoperable system where these information exchanges are defined for each of the different data types. So for deploying the system, right now we're kind of the services are being implemented. I think mostly, well, we're all using ArcGIS Server. GeoServer is another open source application. But what the project is working on is this node in the box, and the idea is to build on this CCAN, which is, I don't know what CCAN is. I don't even know if it's an acronym. It's an open source project from the Open Knowledge Foundation for Data Hub software, and it's being used by data.gov, if you're familiar with that, as basically a data hub system. So what we're doing for the geothermal project is building on that, adding more geospatial capabilities for geographic search. And the deliverable product that we'll have this fall is to be an installable software package that has all the necessary components to deploy a geothermal data system node. So if you don't have something like this running already, the idea is to give you a simple way to get it set up so that you have all the components in place and ready to start loading the metadata and data into. So it provides capabilities to do this resource registration, create a metadata record. When you do that, you can either give it a URL to point to an existing location or upload files into that repository, that node. It also has a search interface and provides the ability to expose the metadata that you put in there to be harvested by the NGDS aggregator. So it provides for the metadata, integration of metadata from your node into the system. And then in addition, if you have tier 3 data, you can set up a data services transparency. The idea is you give it the Excel file and it'll be sort of a push button operation that will set up the GeoServer, WFS, and WMS. And a lot of those pieces are basically being prototyped now. It should work on Windows or Linux server, and also has a configuration for being either an aggregator or a data provider. So the aggregator would be a node that would be harvesting from other nodes. The data provider would be a node that you would be working through to put in metadata in and upload files to expose them to the system. So that's on its way. This is just a couple screenshots of the current prototype. So this would be the landing page, and this would be configurable. This is just currently mostly demo stuff you can see. The search interface would have a map-based interface. Allows you to search. You can add data sets and do some basic data browsing through the map interface that it provides. It also has a library interface that just provides text listing of the resources and also the ability to narrow and constrain your searches based on some facets that we're building into it. And then you can also look at the detailed metadata about specific resources, get the links to have, so that you might have various different distributions that you would have there. So, to wind down here, the idea is that the World Wide Web is the file system of the data repository in this network. And what we're doing is making stuff available on the web through standardized data delivery processes, and then describing them in a catalog so that people can find them in a systematic way. The information exchange specifications that provide these conventions for how we're doing it are really the essence of the system. So it's some discussion points. I mean, basically the US GIN is a community, and one of the things to remember is most of what we're dealing with is the unstructured, is Tier 1 data. If you look in the catalog now, I think there's about 20,000 records in there. 500 of those are Tier 3 data, and the rest of them are Tier 1 unstructured. So, you know, the cost of going to this Tier 3 level, you know, there's some extra effort on our part because you have to go and clean up the data and transform it into the interchange format. And so there's a business decision that has to be made. When is that worth doing? When is it not? But if it's not worth doing, it's still you describe it like God, and you put it out there, and that's mostly what's going on. So the bar to entry is pretty low, and that's intentional because we figure it's more important to get things indexed and accessible in some way than to insist on things being perfect. And so, you know, in the long run, what's the value proposition of these information exchanges as you get to more and more specific kind of data sets? At what point is it worth trying to standardize how you're delivering data where there might only be one existing data set about some specific research project? And so that's a quick run through the system. Any questions or discussion? Go.
So there's 500 Tier 3 data, or about 500 services, but within those services are individual points that I think describe a lot of that Tier 1 data. I mean, they're pointers to well logs and that sort of thing. That Tier 1 data that we're also getting.
That's a good point. So there's 500 of these Tier 3 data sets, but in those data sets probably aggregated have 2 or 3 billion records in them. And each one of those records then is probably referencing back to other resources that might be in the Tier 1 thing. So a lot of the well logs and things like that are just scans. They're Tier 1 documents, but they're certainly useful. That's a good point.
Yeah, I just think it's better than what we. When you look at just the services, it doesn't look like that many, but there's actually a ton of data in those services.
Yeah, so if you count individual records, there's a lot more there than there is. 5 million points. Yes.
On the Tier 1 data, can you do any optical character recognition of those data sets or anything like that to be able to put some search engines in that, create a private library of those things?
Yeah, and so one of the capabilities we're working on in the repository software, that CCAN node in the box, is full text indexing. So in most cases anymore, if you scan a document, you can actually OCR it as well. Most of the software will do that now when you scan something. And so to the degree that the OCRing, the optical character recognition is accurate, you can index that text and it gives you, it's a good 80% solution. It's a relatively
we have a whole bunch of unstructured data like that.
Yeah.
We have to turn that into something potentially manageable.
Right. So and that works.
Capabilities to it. That hasn't really been developed.
Yeah. So and that gets you a long way there if you're dealing with text documents, but you still have this issue if you're dealing with tabular data. That kind of indexing still is not useful until there's some kind of text description that says what it is that you can index. But that's, probably, again, most of what we're dealing with are text. It's text. And there are lots of people working on better ways to mine information out of text, too. So that's interesting. I don't know if you've seen any of the geo deep dive stuff going on at the University of Wisconsin, but they're working, a lot of people working on trying to actually figure out how to take that scanned text, the OCR stuff, and then mine out tabular data and actual individual data items about the ages and some other stuff into that. All right.
So is the hope that each state that participates in this would be the one that takes the lead on taking a Tier 1 data set into ultimately a Tier 3 to vectorize, say, a scanned log into a format that could be brought into as a Tier 3 product, or is that something that is envisioned as a more longer-term?
For the purposes of the current project, we're just what we've done is we have that list of the content models there, and those are the ones where we've said, well, there's as we surveyed when we started the project, we did a survey with all the states about what kind of information do you have, and that was really based on that we decided which ones, which of these kinds of data items do enough different states have that it's worth developing a content model for and trying to standardize that. So that's really where that came from. Beyond that, the focus has been just on, get what you have accessible online, and moving forward, if there's sufficient value, then to do the extra effort to move it from Tier 2 or Tier 1 or Tier 2 to a Tier 3 scheme. And, it's, I guess, either the states can do it, or we're that's the kind of thing where we just have to look for opportunities to make it happen. But I envision that over time, more and more data will get moved up to that Tier 3 level, as this linked data and with open data, the government open data, presidential, whatever it is, what do they call it, directive. There's going to be more and more push towards moving things to that level. And it's a bootstrapping problem, because really, the business case for doing it depends on there being software out there that's going to make use of having that structured data. Right? People don't like the software until the content is there to do it. Right? So it's this bootstrapping process that we're trying to kick off here. So that's why we're focused on a relatively small part of the data universe for this Tier 3 delivery. Well, thanks.
Thank you very much. We're more or less on schedule, and I guess if you have any other questions, we do have a period of time allocated at the just before lunch, I guess, for additional questions if anybody has anything later. So. The next on the agenda, and again, we're 5 minutes ahead, so that's fine. If you'd like to come up, Wendy, and talk about our role in the NGDS and what we've been doing on behalf of some of the other states here as well.
Sorry. If you want to get those, I can get them out. All right. Yeah. All right. Well, thanks to everyone for coming. It's really great that all you guys could be here and help discuss with us the wonderful experience that we've had over the past few years. So I would just like to spend this chunk of time discussing what Virginia's role has been in contributing data to the NGDS, and thus what you guys' role has been in helping us. Of course, this has been a huge project and would not have been possible if we're not for the help and guidance of many individuals. I'm sure not all of which are listed here, but thank you, everyone. And quick outline, I would just like to discuss the exact types of data that we decided to contribute to the National Geothermal Data System based on what was available for all of our states, and what that process of data collection entails. And then discuss the data coverage that we had, kind of delve in detail for each one of our states, what we were able to collect, and discuss a little bit about how we can move forward. So, since the NGDS is a national project, you can imagine across the entire United States there are a variety of different geologic settings, which means that there are a variety of different data types that would be relevant to geothermal, depending upon where you are. So out here in the cold east, our types of data might be a little bit different than what you might expect in Colorado or California, for example. I would say that the foundation of all of our data was well data. Downhole data from different boreholes that we were able to collect. All states have wells, geothermal wells, test wells, research wells, holes, water wells, oil and gas wells. So this was definitely the most prevalent, openly, readily available types of data that we were able to compile for each one of our states. So that means specifically geophysical logs. There are a whole bunch of different types of geophysical logs for wells. Yes.
No, the mic, sorry.
Oh, close to the mic.
Snowball.
Snowball. So a variety of different types of geophysical logs available for all of these wells, especially oil and gas wells, including temperature logs, which were very important, and LAS files, which I'll discuss in a second. So most of these geophysical logs look something like this. They're just paper records. They might be rotting in someone's basement. We were able to go collect a lot of these files and scan them. And so most of these geophysical logs have header information that contains data about the log itself or the hole itself. And then, of course, going down the log, which is usually quite long, there's some sort of curve or multiple curves reporting a variety of different measurements. Okay. And then, if we were lucky, some of these geophysical logs were digitized into a text format. This is the LAS file format. We were able to produce some of these LAS files in-house, so we were able to collect them from you guys. We were also able to produce them ourselves. Some of them. They take a long time to produce. And then lithology logs, of course, are the kind of companion type of logs. These include drillers' logs, completion reports, anything that was usually reported out in the field, hopefully by a geologist, somebody out there while the hole was being drilled, and the cuttings or core were being returned back up during the drilling process. So these lithology logs have some record of what was encountered downhole, and they vary in their how nice they look, how legible they are, etc., etc. Also, we found these sort of strip logs that recorded lithology for all of our boreholes. Also associated with those boreholes are bottom hole temperatures, if we're lucky, any heat flow calculations that were made, if possible, especially for geothermal wells or research wells, and then thermal conductivity measurements. So sometimes some of the cuttings or core were sent to a lab and recorded for thermal conductivity measured. And so these are downhole samples, but also sometimes we had surface samples of specific geologic units that were also recorded downhole. So that's a variety of data that we submitted to the NGDS from all of our states from boreholes. Then also we were interested in any information about geologic formations, including general geologic maps, descriptions of specific geologic formations that had uranium, thorium, potassium in some kind of elevated level, and also geochemistry of those geologic formations. We also submitted gravity data, so that included gravity station data specifically with individual measurements, and gravity maps like this one that's in the background from Dr. Costain. These help reveal the locations of buried intrusives. Another type of data that we compiled for the NGDS were data about springs. Hopefully they were indeed thermal springs. They include descriptions, just general descriptions, but then also aqueous chemistry if there are any lab measurements taken from water samples. So this is us out in the field taking some samples from springs with folks from West Virginia University. And then finally, the last main type of data that we were collecting for our states were just publications, any kind of publications relevant to geothermal in any way. We compiled them all together and submitted to the NGDS. So that gives you a broad overview of the types of data we hunted for in our quest. And the next step is how we actually collected that data. So of course, Virginia, had this wonderful collaborative effort with Delaware, Maryland, North Carolina, and Georgia to compile all sorts of types of data that I just went over. And the way we did this is, if we were lucky, some of these different state agencies or federal agencies had databases like the Tier 2 types of data that Steve was mentioning, and thus could grant us access to these databases that we could go ahead and pull a lot of those metadata records directly, which was very nice. Or, which was mostly the case, we had to visit the State Geological Survey, for example, directly and hunt down all those paper logs and scan them by hand one by one, and then develop our own metadata records for each one of those individual log files, for example. And then all of that information was compiled into spreadsheets, Excel spreadsheets, so that we had a nice metadata record to submit to the NGDS representing all those data types. And then the files themselves that had been scanned were sent to the Kentucky Geological Survey, to Doug Curl, who will be speaking next, so that the Kentucky Geological Survey could be our hub, our host for most of our data. And then, of course, the two are linked to the NGDS so that people can access the data files themselves from Kentucky through the metadata record that currently exists within the National Geothermal Data System. Okay, so now I'd like to take some time to focus on each one of our states specifically, just to give you guys an idea of how much data we were able to round up and deliver. So again, this was a collaborative effort. We visited many different state and federal agencies and had open communication with many different agencies in order to collect all these types of data. So let's begin with Delaware. We'll kind of start in the north and head our way south. All right, so beginning with our base records, our wells, or boreholes, we had about 5 geothermal wells for Delaware from Virginia Tech, Dr. Costain's work, which meant that we had about 101 well logs to submit to NGDS for Delaware for these geothermal wells. You can see the data coverage over here by the maps. We had many, many more water wells, of course, thanks to a database that the Delaware Geological Survey had in-house. And you can see throughout the years of this project, we were able to compile thousands of well logs from these water wells. So all of these files that I'm going over are now in the NGDS and publicly accessible to one degree or another. And then we have our oil and gas wells. Delaware actually does have a few that we're able to hunt for. These are test wells predominantly. And we were able to find in total from this DGS database about 40 or so well logs for oil and gas wells. Geologic maps in total from GDS publications, about 18. Then we had about 50 total publications that we thought had some relevancy to geothermal energy for Delaware. We were able to compile about 50 or so descriptions of various different lithologic units that were of interest for Delaware. Again, from Delaware Geological Survey publications. And from all of our wells, we were able to compile a variety of bottom hole temperature measurements. These came from both the Virginia Tech geothermal wells and from the Delaware Geological Survey database, giving us over 50 total temperature measurements, borehole temperature measurements. We have 5 heat flow measurements from Virginia Tech and about 235 thermal conductivity measurements. And so this is almost our total package for Delaware that we've submitted to the NGDS. For each of the states, I want to address kind of the problem areas that we encountered. These highlighted items, oil and gas wells, borehole temperatures, heat flow measurements, kind of give you an idea of where we think we're a little bit weak, where our weakest link is. So we just don't have very much good deep temperature data for Delaware, which is understandable. So let's shift now to Maryland. Again, from Virginia Tech, we were able to compile over 100 well logs for geothermal research wells. And then you can see the coverage again for water wells always increases. So hundreds, thousands of logs from water wells, which is great. These came from Maryland Geological Survey publications, from an in-house Maryland Geological Survey well catalog, as well as NWIS, the USGS National Water Information System, which has been very useful for us. But of course, the problem with this is when you have data from multiple sources, even though it might be the same types of data, and you're trying to mesh them together and produce metadata records for all of them, it can be kind of difficult. Maybe conventions can be different. Maybe the coordinates aren't exactly the same. Maybe you don't have coordinates. You just have an old topo map with someone's X on the spot. And so again, as Steve was mentioning, when you want to kind of mesh together these data records from multiple sources, it can be a little tricky. So we had to be careful that we weren't duplicating log entries and including everything we possibly could. Which was, again, a little bit of a difficulty because in some cases, these wells that we are locating are lacking really important data, like dates or coordinates that are mandatory in order for them to work as part of the NGDS. And then a lot of these logs are also available only for purchase through the Maryland Geological Survey. So in some cases, accessing the data has been an issue. So for oil and gas wells, again, hundreds of different logs, mostly from Maryland Geological Survey, also from MDE, Department of the Environment. 70 geologic maps, 92 publications from a variety of sources, 93 descriptions of geologic units. And then from our wells, we had over 100 borehole temperature measurements. 19 heat flow measurements, again from Virginia Tech, and about 900 thermal conductivity measurements. There's one thermal spring, which we have a description for, and that's our package for Maryland. So again, main issues, meshing well records from a variety of different sources. That's kind of the one that pops up, and that's not just for Maryland, that's been a reality for all of our states. And so really it's just our wells that have been a little bit problematic. So moving on to Virginia, we have a bunch of different geothermal wells, meaning about 300 geothermal well logs. And then water wells, we have a nice distribution of water wells that have log files that we were able to submit. So over 2,000 of those mostly came from DEQ, Department of Environmental Quality, and DEMAR, our own geological survey. Our oil and gas wells, as you can see, are mostly condensed here in the southwestern portion of Virginia, where our oil and gas is available. This is still in progress, actually. We're still compiling data records for our Virginia oil and gas wells. But there are many, many, many of them thanks to the Division of Gas and Oil database that is online, and you will only be able to submit a small percentage of the total data that exists there. So that's something that potentially in the future could be revisited and submitted as a whole to the NGDS.
Wendy, why only a small percentage? Just so many in time, or?
There are a variety of different reasons.
Okay.
Time, yes. As I said before, a lot of our log records come from a variety of different sources, each of which is unique and has its own pros and cons. And so the DGO database is so huge and in some cases difficult to navigate in a way that it's hard to pull all records at once and confirm what type of logs they are, make sure all the attribute data is accurate and correct, etc., etc. So that's really limited our ability to go through this database in particular and extract records. So it's really more of a painful process for a lot of these databases, going in one log at a time and manually checking it, making sure the attribute data that's available in the database is correct, matches with the log itself, except that the coordinates are correct. So it's just a long process. Okay, and then we have over 160 geologic maps being compiled for Virginia, and there's still more to add as they're being produced. Over 100 publications, descriptions of over 300 lithologic units, and about 100 geochemical analyses from our own internal database. And again, here we go, we see this problem crop up occasionally. Different databases have their own problems and accuracies, improper sorting and whatnot. So that's something that has affected us as our own state, as well as various other states in our database searches. And then thousands of different measurements for thermal conductivity for a variety of different samples from Virginia Tech. Thousands of bottom hole temperature measurements, predominantly, like I said, from our wells and our well logs. And these came from all different sources, DGO, DEQ, Virginia Tech, and our own in-house records. We have over 80 springs in Virginia that we have metadata for. And we have water chemistry for some of those. 35 heat flow measurements, and a whole lot of gravity station data. We were able to compile over 9,000 measurements from publications. So that means opening a book and typing each line by line by line into these content models, these Excel content models. There are still more publications containing gravity station data that we need to compile and submit. So this is an incomplete record. 10 gravity maps, 24 descriptions of buried intrusives. And then we have a variety of locations that have a ground source heat pump installed. We were able to compile a list of about 700 of those that came from our rebate system, school districts, as well as individual companies that install these ground source heat pumps. But in this case, sometimes we didn't have exact coordinates because these were residences that didn't want their locations released. And there's, of course, more data, more of these installations that are out there and haven't been recorded. So again, these highlighted in purple are kind of Virginia's weaknesses for all the reasons that I've already described. Okay, so we're going to skip North Carolina, save it for last, and go to Georgia. So for Georgia, we have, again, our map here with our coverage, about 24 different geothermal wells from Virginia Tech, each of which has some kind of log file. And then over 600 water wells, which means over 2,000 well logs. These mainly came from Georgia Geological Survey publications, NWIS USGS database, and also from the Geologs in-house database at the USGS in Atlanta. Again, some of these issues crop up. Lack of really important data, such as dates, correct coordinates or coordinates at all, and other supporting information for those records. And so in some cases that meant that we were unable to deliver some wells and some well logs because of the lack of that data. So there's a lot more data out there. It just needs to be corrected, smoothed over. Same thing with the oil and gas wells. We have a few hundred for Georgia that we've submitted. A lot of these came from the Georgia Environmental Protection Division, as well as the Georgia Geological Survey and the USGS. But we know there are still more log files for some of these wells at the Georgia EP that have yet to be scanned. They're still in paper format. They're not, haven't been digitized yet. 27 geologic maps, 33 publications, 171 lithologic descriptions, 100 geochemical analyses, 176 thermal conductivity measurements, and hundreds of borehole temperature measurements from all our wells. We have 7 descriptions of thermal springs for Georgia, 6 heat flow calculations, only 59 gravity station data measurements, and about 9 gravity maps total for Georgia. 10 descriptions of buried intrusives. And so that's our tally for Georgia. Again, the weakness are the wells, and the fact that most of the well data for Georgia is concentrated in the coastal plain. So we'd like to be able to balance it out by getting more data outside the coastal plain. Again, possibility for the future. And again, we weren't able to complete our data sets for some of these items. Okay, so finally, North Carolina. North Carolina is still in progress for all of our states, with the exception of North Carolina. Our deadline is September 10th. So everything's kind of rounding up and finishing off right now, except North Carolina will have through December. So we still have a little bit more time to compile our data. So far, this is what we've submitted. Over 25 geothermal wells with 75 well logs, over 1,000 water well logs, or wells, over 3,000 water well logs. These came from the DNR groundwater database for North Carolina. Again, all concentrated so far within the coastal plain. Oil and gas wells, over 800, a couple hundred logs for those wells. This compilation is still in progress. And that means that these are all the data items that we would like to compile for North Carolina to finish up. But many of them are still in progress. But these numbers give you an idea of how many we're anticipating submitting or have already compiled at this point for all these different items. So a similar set of data types that we have for all the other states. Okay, so hopefully that gives you a better view for your own state of kind of where we stand. Perhaps you've noticed in some of the numbers that I've compiled that you feel as though there are more data records that exist or extra databases that I haven't mentioned that host data. If that's the case, please feel free to come and speak to me so that we can make a tally and attempt to compile a complete record for each one of our states, which is ultimately the goal. Okay, so now we have all this data. How do you actually access it? Steve mentioned how you do this. I want to touch on this again. As I said, all the data, the physical log files, for example, have a metadata record that's been tallied in a spreadsheet with a variety of different attributes that were considered important. And you can access those metadata records for all the actual data through the NGDS. And then that will link you to the hub, our host for our data, the Kentucky Geological Survey, where you can retrieve the actual scans of the log files themselves, for example, and extract whatever data you want for whatever state you're interested in. Okay, so currently the way to do this is to go to the NGDS geothermaldata.org website, which looks like this. You can just type in geothermaldata.org and it'll pop right up. And then if you come down here, you can see this Find Data button. You click on that, and you can type in a specific search, or you can define the search area just by making a box on the map. I find that if you're looking for our compilation of well log records, for example, the best way to go about finding that information is by typing in the state that you're interested in, and either type well or log up in the search box. Because there's such a variety of data that exists out there for all the states, if you do a more generic search, you're going to come up with a whole bunch of different hits, and you're going to have to sort through to find exactly what it is that you're looking for. So the state plus well or log brings back the records for the logs and metadata for those logs that we compiled. So here we go, first hit, sure enough, Georgia well log observation data. So this is the compilation of well logs that we put together. And if you click on that, just as we mentioned, this little box will pop up to the left describing your different access options, and you can click on this first area up here, Preview Data Table, and it'll just give you a quick view here of what's contained within that record. And so each one of the different well logs are listed here in this table with a variety of different attribute data, as well as a link, an online link to the record itself. So this is a quick way to find something. Or you can go to this next area here, zipped Excel spreadsheet. And you can click on that, and that'll allow you to download the exact spreadsheet that we were compiling with Arizona for your state's data. And so you can scroll through this and see all the files that we submitted, all the logs, all the wells, all their attribute data, and again, a link to the actual file itself if you'd like it. So I definitely highly recommend that everyone takes time to go and do this, mainly to see what we have out there for you guys so far, to double check its accuracy. If you notice any inaccuracies, lack of data, misspellings, incorrect names, sources, please again feel free to contact us so that we can make those corrections to your data records. Okay, so just to conclude, for the future, I think it would be great, I'm sure many people have said this in the past, but I think it would be great if each one of our states had one master database, maybe for all the geothermal information we've compiled, maybe just for their wells. I think that would be the best. A master well database that includes all the different wells that exist out there, all of their related log files, and all the different identifiers that that well is known by, whether it came from the USGS, Department of Environmental Quality, State Geological Survey, everything. So you have one master resource, a tool that people can go to get an accurate idea of what they're looking at. Again, because the biggest problem in compiling this data was just that it came from so many different sources, it was really hard to mesh those items together. In some cases, we could only tell if it was the same well that came from two different sources if we plotted it up in GIS, for example, and saw that the point location was the same, the coordinates were the same. And even then, we're still not completely certain. A lot of these data records are very old, pre-GPS. Some of our Virginia well records go back to the 1800s. So, I mean, you can kind of make guesses about the accuracy of locations and attributes, who was actually drilling the well, who was actually logging the well, and so all that information would be very relevant to a user who's trying to find accurate information for your state's wells. So, ideally, I would love a perfect database for each state. And then, of course, as I mentioned, a lot of these data sets are incomplete for one reason or another. There just wasn't enough time. The database was so huge, there were so many different well records, we didn't have time to compile them all. Or there were many that we could not submit to the NGDS because they lacked coordinates, they lacked other attribute data that we needed in order for them to work as files in the NGDS. So it would be nice if, in the future, each state was able to recognize the gaps in their data based on what we submitted and say, okay, here are 10 more wells that Virginia didn't add. Why didn't they? Here are the data records. They're complete. They're accurate. And now we'd like to add them in, tack them in as an addition to the NGDS. So it would be nice to know if that was possible, and if so, how each state would go about doing such a thing. And then finally, we have a great data set here that we've been able to compile. It would be nice to move forward with that data and figure out how to produce some useful tools for industry, for the public, for research, so that we can make use of the data ourselves. And we've done this great job of making it accessible to the public. The next step is really what we want to do with the data. So again, thank you to all the states involved, all the individuals, and all the help you've given. And that's it. Any questions? Yes?
Wendy, you, in your discussion of several of the states, you made reference to buried intrusives. I presume those to be under the coastal plain.
Yes.
What is your criteria for identifying those buried intrusives?
That's a good question. I mean, in some of these cases, we refer to the experts, such as Dr. Costain from Virginia Tech, who has a very strong background in geothermal. Overall, we're just looking for elevated levels of uranium, thorium, and potassium for specific area intrusives that might be of some use to the geothermal industry.
I'm not real clear how you identified that in a very intrusive.
Right. Well, we do have samples taken from a lot of these area intrusives. A lot of the geothermal wells, in the case of Virginia.
So specifically, you have evidence indicating that there's an igneous rock or granitic rock there.
Correct. Yeah, we have well cores, a lot of the geothermal test wells that Costain has drilled, targeted specific intrusives that were identified previously based on gravity analyses or whatnot. And so we have drilled to that location, hit an intrusive, and in many cases sent samples for analyses. So we might have polar oxygen chemistry for some of those samples and know that they have elevated levels of uranium thorium potassium.
And how many of those are defined solely by gravity anomalies?
I don't know. It's a good question. John, do you have an idea about that?
Most of the ones, I would say, all of them.
Then my follow-up question is, how do you discriminate those based solely on gravity from buried Triassic basins or other mudstone rocks and buried volcanic sequences?
It's a really interesting question. The highest peak flow in the southeast United States is at Stumpy Point in North Carolina, that we find anyway. And it turns out that that's a granite, but Alex, it's Precambrian. Is that right? And how does that fit in to what we've been looking at in our exploration strategy, which deals with really the 270 to 330 million year old intrusives, which are the post-metamorphic. And here's this high heat flow sitting out there at Stumpy Point. And why is it there?
It's, first of all, it's why it's Precambrian. It's unmetamorphosed. It's an unusual granite. It's a perluminous granite. It's one of the ones that had corduroy in it.
Yeah.
So something really exotic there. At the time, of course, understanding may have progressed since then. It was thought maybe it was a little fragment of Africa that behind.
so that it is not like what we see exposed southeast. So yes, that was a great surprise. First of all, it was underwater. It was then quarter up there, then dating.
Is it high uranium?
Yes. Yeah. The other thing that I've been told that only 1% of the Piedmont has been mapped. I don't know if that figure is correct. Maybe others in the room could say something about that, but that's not very much. So we don't know a whole lot about what's going on out there, and especially underneath the Atlantic coastal plain. I'm a great believer in mapping at the 7.5 minute ordinary scale. I just was so sorry to see that effort being diminished for whatever reason. And well, at any rate, I forgot what I was going to say next.
We can have a discussion about buried intrusives at some point later on if you'd like to delve into that.
But the buried intrusives really show up. So the ones we've looked at show up in gravity, but and they are post-metamorphic, and therefore they retain the uranium thorium, which is but the most important part is of the heat flow is uranium and thorium. That's 80% of it. The other 15-20% is potassium.
But again, those are only for basins for which you have direct evidence.
Pardon?
Those are only for basins for which you have direct evidence.
Yeah,
for intrusions.
Let me make one point if I could to clarify and to address your question. In the work that we have done for the other states, like North Carolina, we have really not tried to do any sort of interpretive work. What we're doing is basically gathering factual information where it exists to provide the NGDS. And we're not trying to do any sort of interpretation of gravity anomalies and decide whether or not it's very intrusive or not. That's not the intent of what we've been involved with. But what we have had in the work that we've done so far is a very good collaborative relationship with each of the surveys, with various contacts, many of whom are in the room here, and others couldn't be here. But and that's been very informative. So we rely upon, when we're talking about a data set like that, we rely upon contacts at each of these surveys to help us decide some of those marginal or baseline decisions. But if there's something that needs to be corrected in a list of data that Wendy has described here, whether it's even, there's a lot of room for interpretation, even, for example, the borehole, the bottom hole temperature data, whether or not it represents a really truly valid bottom hole temperature measurement based upon the drilling conditions at the time. There's a lot of room for interpretation. But we really don't want to get into that at this point. We're just gathering data for the GDS, for the states, and we hope that through further collaboration with those states that we can improve the accuracy and reliability of that information for geothermal applications. So that's, your question is very good. And the other point I want to make too is that in a lot of cases with some of the data that we've dealt with the other surveys, we have been told and we understand that certain parts of it may be even confidential. For example, with the gas and oil data from some of the states, they don't really want to release even, I believe it was even location, specific location. So we've had to work around some of that. But we've been very respectful of the confidentiality requirements for certain data sets that fall into these categories. And if there's something that you see, and we, as Wendy said, we encourage you to look at what's in the NGDS now. If there's something you see there that shouldn't be there, or there's some data field that gives you problems, or there's inaccuracies in it, we will do everything we can to correct that.
The ideal is to have a complete data set. For North Carolina, we're at somewhat of an advantage because we still have time to add or modify. But like Billy said, that's why we kind of still need you guys' help to make sure that what we have out there is correct, accurate, and as complete as possible. But in most cases, there's a reason why what's lacking is lacking. Yeah.
Yeah, I think the idea of including the sort of basic observation data as close, the raw data, so to speak, as well documented as we can is part of what we'd like to do with this, with the idea that, that people can add the interpretations on top of that, but really having access to something as close to the source as we can get is, in the end, what a lot of people are really looking for. I had a question also about the geologic maps you were compiling. Are you just looking at published maps, or are you also doing things like theses and dissertations and more gray literature kind of?
We do have theses and dissertations as well compiled in our publications list. So if any of those did contain relevant data, then yes, that would have been data that would have been added.
But in your map index, the geologic map indexes, does that include maps and those kind of sources?
I think so, yeah.
It does include those. It also includes a lot of the historic maps that aren't necessarily held in current collections. We actually went through a lot of our collections in our basement and scanned really old, like, canvas maps from the early 1900s, and we submitted those.
Yeah.
I first got involved with this project was when I was in New Hampshire, and one of the first steps we did was, grants that went to the states to look at the data sets, as you mentioned, to find out what was there, do an inventory, so we wouldn't have replication or duplicates in different places. So it comes to mind now that when I look at your work, Virginia representing the various states here, since that time, for example, Delaware, we've become a node in the GIN system, which is, of course, the framework that's being built on ASD to answer part of this question. But the point now is that, we have these data in our systems as well. Now, from my understanding, you've taken the things that were relevant to geothermal and now hosted a KGS server. As we go forward, because we are going to talk about sustainability later in this program, tomorrow, what do we do about potential duplication there that links to our databases that might have this as well as the stuff that was loaded there? Are we potentially heading toward a clash there? How would we deal with that?
I think ideally, each state geological survey would love to host its own data. I think in reality that isn't always possible, as is the case in Virginia. So, it seems to me as though if you are beginning to host your own data, then all that would need to happen is for you to identify those records in the NGDS and update the link to the actual resource and just redirect it to your survey. And hopefully that would be a straightforward sort of process.
Yeah, that sounds to me like what we would do is basically move the data. The metadata would point instead of to the data in Kentucky would point to your server when it's
I think in our case almost all of it was digital format.
Not all these records were the newer records that are out in our web mapping services now for all our geologic maps and whatnot.
So that's as part of the ongoing maintenance of the system will be this issue of as sort of states bring up their own servers and inevitably over time, where these things get served is going to change. The metadata has to get updated so that it points to the right place to get it.
Also, we scanned so many different log files, and those scans are available to you guys. And something that we've been compiling currently for each state is a disk that contains, or multiple disks that contain everything that we have compiled for the NGDS project. So, like I said, in many of those cases, those are scans that we made ourselves when we visited your survey, or LAS files we produced in-house ourselves, or files that already existed from you guys. But we want to compile a total for each one of your states, so we can give it to you, and then you can also choose if that, in fact, is the scan that you'd like to use for that well log, if you have better versions. Yes?
No, I don't want to bring in one issue of North Carolina. I want to talk about that in the North Carolina section here too. I just want to bring you up to speed on something. My bill for GIS storage was $62,000 for last year. That was a cut from $124,000 because that's what the actual bill was. They said they cut it in half. That's what we have to pay per year to store stuff out on the system. The whole thing is that it's public record, therefore we're putting it out on the system. The guys in water quality have a BIM system that's a totally separate internal server run system in the Division of Water Quality where they don't have to pay for anything because they bought computers. We're required to use OITS. Well, now that water quality is being combined with water resources into now Water China, and now 1/4 of the entire department of environmental resources is one agency, they're going to have to come to grips with, how do you deal with moving all that data onto the new system? I appreciate working with our colleagues in the Division of Water Resources with that and those others there, because it's like they were real helpful in showing me that a lot of the data they have in the database are the deep wells that are from the oil and gas program, where they came, got our data, and put it in the system. They didn't ask us to review it. They didn't ask us to even request that we review it. We know there are mistakes in it because we've seen it from looking it up on our own.
Right.
So it's one of those unfortunate situations where, because they're the owners of the information, and to the folks in water resources, as it is with many of our other water agencies in there, plus and minus 50 yards is close enough. Okay. Therefore, having things like a well is mislocated by 5 decimal places, where it's what was put in, it was only put in at 3. It doesn't matter. The well is no longer, it was drilled, they completed the data, they collected the data, and that's it, it's done with. You can't go back to that point again, you never really need to. And that's one of the things I would, I urge that the folks at the national level with this project look upon it being that there needs to be an annual process of data reconciliation, data verification, where some way, some group out there, some organization out there is starting to say, yeah, this data was good or this data was bad, and the reason why it was bad was because it was, they said it was all in Fahrenheit. There's no way it was in Fahrenheit, it was in Celsius. And someone missed that one. It's like, okay, that attribute needs to be corrected. But I look at there and see, did a gentleman's job for us, thank you very much. I was hoping to the reason why y'all had to come and visit us and help us. I'm not happy about it, and I want to make sure everybody understands is that having a nice national program, we're prohibited by law from our state legislature from putting state data on another server. So, for example, when they say they found out about our National Geological and Geophysical database at the USGS, and they found out there was North Carolina Geological map on there, and I said, oh, sorry guys, we send in our deliverables for state map. That is what's put out there. That's not our data, that's the deliverable for the contract for state map. We don't put anything else out there, we just send them, that's it, that's all there is. So it's not our property, it's the deliverable for the contract. So they backed off of saying, that you are not allowed to do that. It's like, they understand, folks, how quickly you get divorced from the system. And I look at there and say, thank you for what you did, thank you for what you did. It was very nice you came and visited us and helped us out with this, because I hate to have a giant hole in the system where North Carolina was not contributing because we weren't able to.
These sorts of issues are not uncommon, and I think it's just the reality of the system, and each state is unique and has its own hierarchy and laws and regulations, all of which we've had to address in one way or another, and hopefully we've done that in a way that works for everyone. The one advantage is that these Excel spreadsheets that are the metadata records, there are columns in there that discuss location accuracy. There's a notes column, and we've done our best, not as much to make a judgment call about whether or not this data record is of value or could be used, because we're not experts in that area, but we can, in some cases, recognize when there's a problem. And so where we've identified problems, we have made sure to make a note of it in the metadata record. And so hopefully it's something that in the future, for you as a state survey, if you see those, you will also see a note that addresses that location, uncertainty, temperature issues, and whatnot. So hopefully we've played our role in helping improve the record without actually doing anything directly to it. It's only been in certain instances where we have hesitated in delivering certain items, like we have delivered logs that were questionable because, you know, this might be useful to somebody. It's got a curve on it. It might not tell you what the curve is about, but it's got a curve, and maybe someone knows better than I do what it means. But, you know, we very rarely decided not to submit a well log, for example. The only reason we would is if it, you know, the header information was completely illegible and you could barely see anything on the log. So hopefully, like I said, we've done our part to just put everything out there, and then the user can make the decision about the quality of the data, and the source agency of that data can also make revisions, corrections, and decide whether or not it needs to be pulled from the database in the long run as well. Yes?
It's more of an information question than the listing of the geological maps in your database, which cover a large number of data files. Do those point back to the National Geologic Map database, or is there some footnote that tells a user who may, and we unfortunately find we have a lot of users that are totally oblivious to the National Geologic Map database, nor how to access it, much less use it, so that they would be able to find that information.
Yes, we have worked with the National Geologic Map database, USGS map database, quite a bit, and it depends state to state because, you know, every state has their own preferences for where the record is coming from, where the user is being linked to for that specific map. But yes, in some cases, I believe we do link to the map database, especially if that's the only location where those maps are being housed. I'll also say that, again, we do have some historic geologic maps that we've scanned that are not on the map database, but the USGS would love to have all of those records. And so as each individual state goes through what we've submitted, you might also consider adding your data to the map database. Yes.
And if they had a requirement request that came to us in writing from USGS to please submit historical maps to that, and you've got some money to pay for the staff member to do that, and I'll be glad to see that as a deliverable of a contract, and
right.
then I send it off, because my answer back to y'all would be, or back to USGS would be, I can't do that.
Yeah.
I'd just like to add, I mean, in the long run, our objective would be that the map catalog, the NGMP map catalog, would be basically one of the nodes in this system. The problem right now is the only way to search that is by using the web page. They haven't exposed a catalog service on that map catalog. So what we've been discussing with the guys at the survey, with Dave Soller and with science-based people. The objective is to basically have that map catalog be another catalog service that's part of the system. And the idea would be that then as states, we would register metadata for our geologic maps into that catalog system, and it would be available in NGDS and through the map catalog and through the national map and through data.gov. So that the idea is you put the metadata in one place, and then it basically propagates throughout that catalog.
Well, it may be just a suggestion until the ideal day arrives. You may want to put a little footnote there someplace on your pages to maybe help the user become familiar with it.
Ideal, I guess I haven't looked at the metadata they're generating, but what we try to do with the Arizona maps is basically cross-reference the maps with the identifiers for the map catalog, so that one of the distributions you see would be a link to the map catalog. Now, in a lot of cases, all they have in the NGMP is a landing page for the map. Right? It doesn't actually get you the map. So what we want to be able to do is have the metadata record take you to the map, whether it's a map service or a download or whatever.
And in many cases with our data, if there are multiple sources for the same data, it's housed in multiple locations, and we try to put a link to each one of the places where it's housed. And I'm not sure how that kind of spits out at the NGDS end, but
well, that was in the search page there, where you see when you click on the thing on that, at least in the current search page there, you see that list of the different distributions. So it's this sort of, librarians have this idea. There's the work, which is the map, is the intellectual thing, and then it has different distributions. There's different ways you can get a hold of it. There's a map service, a download. It might be available as a PDF from 3 or 4 different locations. The way it's involved.
Yes, I had a question. Is there a difference between a geothermal well and like a log that is collect the fluid acidity temperature, like a regular log, or what is the difference between?
well, from my understanding, there are a variety of different types of holes that are drilled for a variety of different reasons. And maybe for the geothermal wells, for example, that Dr. Mustaine has done, they're test wells, essentially, specifically for research.
They're heat flow.
Okay.
They're heat flow. So they've been logged for temperature. And then from the temperature, you get the geothermal gradient. And then you multiply that by the thermal conductivity of the rock that you determine in the lab. So that product gives you heat flow. So a geothermal well, it's, I suppose it would be better to call a heat flow. Well, the heat flow well isn't a well.
It's sort of like a special case of it just need a little bit more research.
Yeah.
Right. But there typically are a variety of different geophysical logs for a variety of different holes, and it just depends on what the water has in mind.
I guess the second part of my question is, when we submitted our data, we have fluid temperature and resistivity sort of hidden within a lot of our files, not specifically identified. Is that actually teased out in the metadata? I can't remember if the individual curves are actually listed or...
So if we have one log, so this is something I thought of a lot, we have one log file. So it's a scan of one log, and within that log there are many different measurements or curves reporting a variety of different geophysical measurements down below. And so each one of those curves is individual, but there's only one metadata record for the log file, but then it is listed all the different measurements that are included in that log file.
And then in that content model, we also have a reference to the well header, usually,
right.
that log came from.
Right.
I remember going through this too. It was really complicated because it's like, well, I have well header, and then I'm duplicating. You're not really duplicating because you're describing just one of those curves.
Right. So there's a well header spreadsheet, and that's just each well that exists with attribute data, and all the different logs that exist for that well are listed in that one entry. Then you have the well log spreadsheet header template. And that's each individual line are all the individual log files. So you can have many that go to one well there. So they're represented in both ways.
Just in the interest of staying on the schedule, Joel, you had one question too. I know you had your hand up for a while, but then after that, there will be time after, we want to take a short break and let Doug get set up for his presentation, but then there'll be a short period of time right before lunch where we can revisit all this and ask further questions. But Joel, you had something?
Yeah, I just had a question about that Virginia gas and oil well database. I mean, and your probing of it. I mean, have you actually been able to get at actual well logs, or just like permit information and metadata stuff?
Yeah, the metadata is kind of listed in the DGO database online, but then you can link to the actual log files themselves. They aren't always the correct ones. So there's a lot of blood, sweat, and tears that's have gone into looking at the DGO records, but yet you can't access the logs themselves.
You get like drilled logs and then e-logs right off that?
Yeah.
You have to kind of, hunt it down.
You can get a variety of different log types, but yes, sometimes you aren't going to get exactly what you think you're going to get.
Okay.
I can help answer that also. In part of the regulatory process with the Division of Gas and Oil, they're required with the completion of the Sporadic submitted law. For the most part, over the last 3 or 4 years or so, they've put all of those in as LAS files. Before that, the other 10,000 wells, they came in as paper copies, long paper copies. They're just physically within the files. We're in the process of trying to scan some of those things and make them available, mostly just as PDFs or exposures. And so, they're required to be there by regulation, by law. And so there's a tremendous amount of information in there that is very instructive.
It's not like proprietary.
There's a kind of confidentiality kicks in. It has to do with that 3 months after the well is completed by default, or like 18 months after 18 months after the well has been completed, 3 months after completion, or they can go ahead and request a variance on that, like 2 years or 4 years of confidentiality. But for the most part, those are not confidential anymore because there is so much of a volume. There's really not a lot of wildcat wells being drilled. They're just simply production wells. And the issue is that there is so much of a volume of wells, they're right next to each other, and you get an over density of your data sets that really does not contribute to things anymore. A couple, 2 or 3 or 4 wells per quadrangle is probably enough.
Oh, sure. Hi, everybody, and thanks so much for all of your efforts. These have been very good presentations, and I'm trying to sit in for the majority of them. Also, just wanted to say that this is a really important effort. Lately, we've had, at the federal level, a lot of policy guidance pertaining to access to federally funded information. So as you move forward, you might see this affecting state governments where there's information that's been funded with public dollars. For example, the North Carolina issues with not being able to put the data online. At some point, the policies might translate to the state. I'm speaking specifically of, I think it was the February 22nd memo from the Office of Science and Technology Policy, and the subject is increasing access to the results of federally funded scientific research. So that's helping us even justify investments in data in NGDS and incentivizing data providers. So thanks again for your efforts, and I'm going to try to sit in on as much as possible.
All right, great. And so Arlene is online, and then I believe also at one point we had Tim Reinhardt and Steve Hansen online from and then we might, as soon as it's a civilized time in Arizona, have some of our staff on as well. So thank you for the opportunity to introduce everyone. Just want to let you know that that's what this equipment is for. And so if you are presenting, the snowball mic does pick you up fairly well, but obviously the closer you stand, the better off you are. So, or the louder you yell.
So I'm Doug Curl at the Kentucky Geological Survey, and we're both a data provider like everyone else into the system, but we're also the one of the NGDS hubs for the system, and I'm going to mostly talk about the hub, our hub part and our role, since we're actually serving a lot of your data, and so I'm hopefully going to answer the question of where's my data coming from. But further into that is hopefully maybe one day we won't be a hub, and I think that's really kind of the goal is to ultimately eliminate the need for hubs, because every state will be serving their own data in some capacity or way, and so the hubs are really, I feel, sort of a stopgap so we could get this thing going and actually have a place to serve data from. But ultimately, hopefully states will be able to do it themselves. And there's some tools like Steve mentioned the CCAN node in a box tool. Things like that are being developed where hopefully states can take that or some other node type thing or spin up their own server fairly easily to serve their own data. So my goal is to be obsolete, I guess, as a hub. But for now, we're a hub, and I'll talk about how it's kind of the mechanics of how we do this, and really just very mechanical about how things are published and that sort of thing. Because Steve really hit on a lot of the parts about interoperability that I'll discuss that as well. So as I said, we're the data provider, and I'm the PI on the data providing part, and then I've been that for about 1.5 years, and then I've been the hub kind of coordinator for Kentucky since the beginning of the project. And my background is geologic. I'm a geologist, geologic mapping, but I'm now the head of our geoscience information section. So really do a lot of providing our own web services and developing web applications and that sort of thing. And I was thinking about this when Steve was talking. I guess a lot of our data at Kentucky is actually kind of what you call Tier 2 and Tier 1 data. So we have a lot of files, but we have a lot of Tier 2 data, and that's not great for interoperability because you take data from Illinois and Kentucky, and they don't really talk to each other. So this project has been really great for us because we're taking that Tier 2 data, that data that's in our own sort of data model, and putting it into these content models. And I think for us it's been really valuable and sort of restructuring how we think about how we serve our data, at least me. But anyway, that's my data provider spiel. So there are hub states as part of the NGDS, and this is just a map displaying where these who's serving what, and basically the data is served by 4 states, and then there are some self-serve states, so states that actually serve their own data. Arizona is the hub for really the Rocky Mountain, the western, what do you call that, southwest region, and also Nebraska and North Dakota. And then Illinois serves the Midwest and then Northeast, and Nevada serves the Rocky Mountain region and the Pacific Northwest, and Alaska. And Arizona goes to Hawaii, and we do Puerto Rico if there was Puerto Rico data. We'll have to go. We should have our meetings down there.
Fine.
So yeah, Kentucky is we're the Southeast, and so it's your data. And then there are some self-serve states. So we would serve West Virginia, and we did for a while, and then they were able to come online and start serving their own data. So we actually just took down the services fairly recently. So that's one of the, I think one of the goals is that states can come online and provide their own data. And really the advantage of doing that is you're the host of that. You can update it as you need. It's faster updating, and so at least that's the hope. So just an example. And then there's some other states that host their own, I guess, as well. So Steve talked about these data tiers, and I'll address. I want to bring these up again because really it's how we serve the data is really dependent upon these different tiers. So we have Tier 1, which are again things like images, text files, PDFs. It could be any sort of file-based type data that's not in a database that can't be expressed in some sort of content model or data structure. So we serve that. We have Tier 2 data, which actually I don't think we're serving any Tier 2 data from other states. Like I said, a lot of the Kentucky data is what I would consider Tier 2. So as part of NGDS, we're not really, I think, really the goal is to get data into these content models, and so that's what's been submitted. And so really, Tier 2 data doesn't really, we don't serve that. We could, but it's just that, you all have been submitting data in this Tier 3 format and these content models, the Excel spreadsheets that you submit. And so that's the NGDS content model. And these have standard file, field names and tables and that sort of thing. And then, so I'll discuss how we go from that Excel spreadsheet to actually becoming a service that you can consume. So mostly focus on the Tier 3 data, but also talk about the Tier 1 stuff as well. And again, not too much Tier 2 because there's not much of it. Really the Tier 1 data is, as Steve said, the majority, the bulk of data that we serve is Tier 1 data. And these are the file-based things that have been sent to us, and I'll go through that process. Just a little bit about our infrastructure. I think one reason we were selected as a hub is because we have an existing web GIS serving infrastructure. And right now we're running 2 Microsoft servers. These are both web and GIS servers. They share the load. And for the Tier 1 data, really the important part is they're web servers. They don't really involve the GIS servers because they're just files that need to be accessible via the web, via a URL. And then, so that data is actually stored on a network-attached storage. It's a RAID 5 unit if you're familiar with that kind of stuff. And it's replicated for backup to another unit. So when we get the Tier 1, the file-based data, we back it up ourselves. And I'm sure, I talked to Wendy and she said they backed up. So, and then there are also DVDs and they get sent to us from Virginia in that case. But I did a very quick and dirty calculation on what we're serving. This is non-Kentucky data because the Kentucky stuff is, it's a lot, and it gets confusing because we have stuff that's not involved with this project being served with stuff that is. So I just calculated really the non-Kentucky stuff, and I estimated about 130 gigabytes of Tier 1 data. So these are all files of various different types. I don't really look at the different types of file, I just get them and then serve them. But you can kind of see the rundown of what's being served. I highlighted the ones in yellow are the ones from Virginia that I get. And hopefully these, I know I'll be getting more. So the numbers didn't quite match Wendy's. She had more in her presentation, but she said she's sending me more, so we'll be putting more and more stuff on there. So anyway, I didn't say the size of this NAS unit is I think it's like 3 terabytes or more. So plenty of storage to handle this so far. So the process for adding files to the repository from my perspective is usually I retrieve the files directly from the state, although just the other day I got an email from Arizona and they're going to send me foreign files. So that's not exactly true, but it was true until like yesterday. But anyway. So I'll usually just receive the files directly from the state. In the case of Virginia, they've been sending me, Wendy's been sending me DVDs of data disks via the mail. We have an FTP server, so we can use that route. It's a little clunky, and really the DVDs work fine, and it's nice because then you have a hard, backup. So I don't really care. I work with any sort of system. We can use Dropbox or whatever you can. However we can work it, we'll figure it out. So, but anyway, I'll receive the files directly from the state. It's a very simple process. You copy the files to the drive. The drive is already, it's in a web accessible space. And then I'll just email the Arizona survey with the links so that they can update the metadata records about where those files are actually located. I usually just give the I don't provide the links for everything because the root folder is where the things reside, and then the file names, they should have those already from the metadata that's been submitted. So this is, if you ever want to look at it, you can actually browse the directory through that URL. This is sort of what it looks like. If we look at the Virginia geothermal wells, this is what the directory looks like on the web. And so each of these is a different file that's been submitted. And I'll have I just assume that they have a metadata record. And so these file names with that URL get sent to Arizona, and then I'm probably going to get this wrong, but they turn that into a URI, which is more universal and can always redirect to this location. Now, say you're a state and you've decided that we're going to host our own files. It's very easy to change that URI to redirect back to your server in case Delaware, somebody wants to serve their own tier 1 data or whatever. Just say we're serving our own. This is the root URL, and then that URI will get changed. So I don't go into a lot of detail about the whole URI thing because I gotta get bogged down, but we can discuss that later. But anyway, this is basically it's just file storage and then they're web accessible. So that's it's just as simple as copying stuff to a drive and then they're available. The services for the tier 2 and 3 data, again, don't have tier 2 data, but I want to mention it in case we ever do. Again, we have our WebGIS. That part's not any different. However, in this capability, we actually use the GIS servers. And the GIS server is ArcGIS Server 10.1. Because we have an Esri license through the university. We're part of the University of Kentucky. We have a license through them. And so we're able to run ArcGIS Server 10.1. Now, all the hubs right now are running ArcGIS Server. That's just because we all have Esri licenses, and that's what we've kind of agreed to do. However, it's not the only option. I mean, there are a lot of other types of ways of serving data. I'll get to that in a second. So when we serve the services, you basically get 3 things. You get an ArcGIS Server service, and that kind of comes with publishing a service. And you can do things with that service. You can consume it, you can write applications around it, etc., except they're all Esri based. So you're sort of in the Esri world of consuming that service. But really, the requirement for NGDS is to make these interoperable and also open and to be widely available. And so we use these what are called OGC compliant services. And Steve talked about these a little bit, but these are WMS and WFS services. WMS basically provides an image of the layers within the service, and they're symbolized. So when you bring it in, you're actually looking at a map that's symbolized. However, you don't have access to the vector data, so you can't download individual features. And that's why we have the web feature service. When you display a web feature service, it's actually the individual vectors, and you can download that data and you can analyze it and do stuff with it. And Steve showed those in an example of both of those. So our real goal here is to serve WMS and WFS services, and really ArcGIS Server is just the means by which we do it. So there are other options. There's a product called, of course I'm not that familiar with these, but there's a product called GeoServer. I think there's one called MapServer, and there are a host of other ways to serve OGC compliant data. So if you're interested in serving your own data, you can use these other options, which are much, much cheaper than ArcGIS Server, in some cases free. You need a server is really the big cost there, but you're not paying for an Esri license. So I guess what my takeaway is don't think that you have to use Esri products to do this. There are many other options for publishing OGC services, but we choose Esri because we have the licenses. And eventually we might go to something like GeoServer in order to sort of separate ourselves from the Esri world, especially if the data is being consumed by commercial applications and that sort of thing. We might run into licensing issues, and these are things that I really haven't explored that much, but it's something kind of in the back of my mind is, Esri, we're, using this sort of academic license, but what's really the limit of how you can use that? And if these data are being consumed in commercial things, that might not, really fly that well. So I think, I could see eventually going over to GeoServer. One other thing about our infrastructure here is it's pretty old. Actually the NAS units are brand new, so where the data is actually being stored, which I think is really the important part, is maintaining that where the data is stored is brand new drive, and then we back that up. But the actual web and GIS servers that we're running are 5 years old, and so we're hoping to upgrade these soon, and hopefully they'll be faster. We're going to do these still in-house. We explored doing something like Amazon, serving the things through something like Amazon, but we're going to buy another server or two and serve them still in-house because it's just more cost-effective, and we can maintain those in-house. But that's another option is, if you want to set up your own server, you could, there are now cloud-based type services out there where you don't actually have to maintain hardware. You can do a subscription to something like Amazon, and spit up, these other options. If you have an Esri license, you could do RTS server on this as well. So just some options to throw out there. So this is kind of the meat of the thing. We currently have 68 total Tier 3, what we call Tier 3 services for all these states. These are pretty much all the states that that we're a hub for, except for West Virginia. We used to serve West Virginia data, and we no longer serve any others. And the types of services that we're currently, so I went through and sort of tabulated what we were serving. This is the list, but basically these match those content models that have been submitted. So things like, well headers is the number one thing that we ever got was well headers, and then from, like we were discussing before, from well headers you might have logs and different measurements. But we have also things like faults. We have active. We don't serve. I don't think we serve any active fault layers, but they do in other states. And then so not just point data, I guess is my point.
What's a seismic hypocenter?
Those are, I assume they're seismic.
Locations are. They're called seismic hypocenters because there was some concern about calling them earthquakes. Just from
They're what?
They're earthquake hypocenters.
Why do you call them earthquake hypocenters?
There was that marketing. Yeah. Arlene can address that. Yeah, is Arlene, she's still there? I mean, there's just some concern about earthquakes and sensitivity about induced seismicity related to enhanced geothermal development. I think is probably the biggest issue.
I know, but you can't really carry this forever.
I've opened up the speakers if Arlene wants to say anything.
Hello, can you hear me?
Yes.
Loud and clear.
Oh, great. Yes, the Geothermal Technologies Office Director had asked us to change that, and I don't really see where it's a problem from a technical perspective. What's the issue?
why not just call it earthquake?
Yeah.
I'm sorry, I'm having a hard time hearing you, Kim.
The question was why not just call it earthquake hypocenters rather than calling it seismic hypocenters?
Yeah.
Well, I think actually seismic is a more scientific terminology, and in terms of geothermal development, a lot of what we are looking for is micro-seismic activity, which is below ground. You know, for the most part, our scientific underpinnings aren't based on what the general public views as earthquakes. You know, they could in fact be different data that's collected for an earthquake versus something that's a seismic or microseismic occurrence. So I agree with the office director. I think it serves a number of purposes. I think scientifically it gets more at what we're looking for from an RD&D perspective, and I think from a public perspective, you know, there's no need to have someone thinking that geothermal is going to cause earthquakes just by looking at the title of a data item.
Hey, Arlene, wait till
Yes?
wait till the public finds out that weather is what's causing the earthquakes in the eastern U.S.
Pardon? I'm sorry, I'm having a hard time hearing you.
The statement was, wait till the public finds out that it's the weather causing the earthquakes in the eastern.
That it's the weather?
Yes.
I think you need to expand on that, John.
Well,
Yeah, I'm not clear on what you mean.
here, but Arlene, I'll send you a PowerPoint presentation.
John will send.
It's called "Why We Have Earthquakes in Virginia."
I think you've already shared that with me. I appreciate the information. I'm not sure how it's relevant to the topic of calling the data a seismic hypocenter versus an earthquake hypercenter, but I'm happy to receive it again.
All right. So I'm just messaging. I think the states that we have those the hypocenters are, I think, Alabama and Arkansas. Some other things of note here. We do have some tier 1 services that are services. So these are imagery and maps that are actually georeferenced. But we can provide them as a service, and right now they're not a WCS. They're just basically a georeference map that you can but you're allowed to do that through ArcGIS service as a service, and so you get all that georeferencing brought in. So that's why there is this T1 and those. I think the only state we're doing that for is Louisiana. They had some georeference maps, and the Illinois survey is surveying a whole lot of georeference maps as these T1 type of server services. And then this bottom one here, the one geology features, these are things, contacts, geologic areas. But I call them USGen 1 geology features because we actually serve them in a different space. They can be, I guess, a geothermal deliverable, but really the idea is to have these accessible in the USGen system, and then also 1 geology. But we serve those, I think, right now for Arkansas and Florida, and Kentucky will have ours soon. And if you want to have yours, you can. Yes.
Are we allowed to ask questions as we go?
Oh yeah. I meant to say this is very interactive. So
yeah, I
please
just
stop.
wanted to know, maybe I'm directing this at the whole front corner. Is being an NS or NGDS node the same as being a USG node?
At this point, yeah, because basically USGen is just the sort of approach, right? It's sort of the network framework, and so all any server that's offering NGDS services is using the USGen protocol. So the distinction is sort of what's in the name, whatever.
So if you want to just say we're a USG node and not, but for the sake of this talk, you're calling yourself a...
Well, It's an NGDS node because that's mostly where the funding's coming from, but it's using the US GIN network.
Yeah, just want to make sure it's straight up here for me. That's
right. Yeah. Yeah. I got confused on that when we were starting to do the one geology stuff. I was like, well, it's not really NGDS, but it is, but it isn't.
Because I'm just having that same.
You guys are setting up one geology services too.
We did already, but I was having the same thing, and that's why I wanted to ask that question.
Okay.
Thanks.
So these are the types of services, and if you can actually browse these through a URL. This is the URL that ArcGIS Server provides. It's called a REST endpoint. REST means available on the internet as services. It means something else that I can't remember. But this is the URL if you actually just want to browse these services, and you'll get a web accessible directory. So these are all web pages. These next few slides, and if I have time, I can go. We can look at these more interactively if we want. But just some screen captures of what these look like. So this is a service directory. These are all in this AISG geothermal. If you browse this whole thing, there's a bunch of other services that we at Kentucky serve, but all the geothermal AISG stuff is, or NGDS, that's it's too many acronyms. So you can actually just browse these, and if you click on one, of those links, you'll get a nice description of what the service is and what's contained in it. If you scroll down, or if you hit the layer, you can dive in and see what the field names are, and it's readable HTML. However, like I mentioned before, the real purpose of this is providing these OGC services. And when you look at all of this stuff, you might think, well, where's the OGC part of this? And they're very, well, not very, they used to be way down at the bottom, but in 10.1 now they put them at the top. But these two links are the WMS and WFS service links, what are called Get Capabilities service links. These are really, this is the goal, is to get to these. It's not the service directory, but this is a kind of a nice way to sort of explore the data in readable text. So if I click on one of these capabilities, it's XML, and so that's the standard format we're using, XML. And basically your content, I'll discuss how I do this in a minute, but your content model basically gets pushed into this XML format. The capabilities is just a way to see what can this service do, and then also some of the metadata about the service, who's providing it, who contributed it, etc. So this is WMS capabilities, XML, and then the WFS capabilities, XML. And you can see why it's, it's kind of nice to look at just that service directory, because that's more readable than reading a bunch of XML. But to consume these, this is really the important part. And I won't go into too much about that, but just one thing you can do in these also, if you want to just look at the data very quickly, one thing you can do is you can actually bring it into ArcMap directly, and it'll bring the ArcGIS server service into ArcMap, not the WMS or WFS, but the ArcGIS server service in ArcMap. And you can also view it on arcgis.com just by clicking that link, and it might look like that. So these are the Virginia well headers. So if you just want to explore the data very quickly through the service directory, that's a way to do it. And in this case, I clicked on, I enabled the pop-up to sort of show you that the attributes that you get look like your content model. So they're, that's your content model working, I guess. So that's what the end result kind of looks like. So I'll just kind of go through the mechanics of how we publish this in case you're curious how this works. So what you do as surveys is you fill out those Excel spreadsheets with the content models and put your data in there. Mostly, I think Virginia's been doing a lot of that work, right? And you will send them to the Arizona survey, or you submit them to the Arizona survey. Arizona survey actually does a lot of processing. They take those Excel spreadsheets, they'll put them into what's called a personal geodatabase. They make sure that things look okay. They might have some interaction back with you about if things are wrong or whatever. But once they feel like that data is in pretty good shape, they'll send it to us, the hubs, as a personal. I mentioned that on there, but they'll send it to us as a personal geodatabase. And we also get an ArcMap project, which actually will display the data. So that's a lot of work by the hub, by the states, you all, to compile the data in the Arizona survey to get it in this nice format. So really, as a hub, our part is to take that personal geodatabase and then convert it into one of the services. And really, that process is not that bad. So we import the data into a file the way we've been doing it. There wasn't a set cookbook for this, so kind of just had to figure this out as we go on. But we import the data into a file geodatabase, and that's stored on that NAS drive, so it's backed up, and it's also accessible to the web, a GIS server. Then we'll open and save the ArcMap project. That's the MXT, if you're familiar with ArcMap. Open that MXT, and in ArcGIS server, you need that ArcMap project to publish the service. So we open that, we check the data, the connections. We also edit some of the metadata if it needs to be edited, and then basically we publish the ArcGIS server. It's a fairly, it probably takes about, to go from when they send one to publishing, if I did it just absolutely immediately, that process is about 45 minutes. So it's not, it's not too time consuming. However, once we publish the ArcGIS server, in that process we have to edit the WMS and WFS properties, like get all the metadata in there. And then we actually do a validation. And you can validate through this URL here. There's a way to show that. I meant to have a screen capture of it.
Clicked on it, so it is trying to load.
Oh, okay. Oh, you clicked on it. Yeah, there you go. So the Arizona survey developed this page where you can actually validate a service. So when you have a content model and the data is in there, it needs to be in a very specific format. The field names need to be correct, and then the data within those fields needs to be correct. And so you have to sort of figure out that this thing is going to work, and it's going to be interoperable. And so we have this Arizona survey developed this WFS validator, and so once we publish a service, like I showed you those service URLs, we can go to this WFS validator and put that URL in there, submit it, and I won't go through. We can do that later if we want, if we have time. And it'll actually tell you, okay, this service is valid or it's not, and it will spit back some reasons if it's not. And so in this whole, I guess we can go back to the PowerPoint. In this whole process of publishing, we've been trying to do more of the validation at the hub level. The Arizona survey used to do a lot of that validation, and we're trying to take some of that load off to do that validation. So really that's the current model for service publishing. It's pretty, it seems simple. There's some steps we have to kind of figure out along the way and that sort of thing, but this sort of system works. Now in the future, we'll hopefully take more of the load off Arizona survey and get things up faster because they've developed a tool where we can actually go directly from the spreadsheet to a geodatabase at the hub. So in this case, we would just retrieve the spreadsheet that you all submitted from the Arizona survey, they might do some data checking on that spreadsheet, but they'll send it to us. And there's a tool you can download that anybody can download if you have a server, ArcGIS. This is really for ArcGIS server. That will convert that Excel spreadsheet all the way to a geodatabase that you can then publish. And so it validates the data. So it actually does the validation, that data validation at the beginning rather than way at the end, which is also really nice. So you don't go through the whole process of publishing the service and then have to go back and configure something. So it'll create a geodatabase. We actually have to edit that personal geodatabase for reasons of moving fields, because ArcGIS is different from what the content models require and that sort of thing. But, it's just a small step. And then we'll basically go through the process of moving that to a file geodatabase, like I mentioned before. What we do before, we'll actually create an ArcMap project, do all the metadata, and publish, and then we might, we'll do another validation just to make sure it went okay, and then we'll email Arizona with the links so they can update the metadata. So that's how an Excel spreadsheet basically becomes the service. Now there are cases where we need to update the data, and so we might, if you have, we might have already published the service, like well headers, and then for your year 3 deliverable, submit more well headers, and so we need to update that. The service is already running, so we don't need to recreate the whole thing. So we simply just receive the data from Arizona, import that into that existing geodatabase, either append it or reloaded it. Sometimes they'll send us the whole thing again, and then automatically the service is updated. So service updates, once the service is created, is a very, very quick process. And I think we could probably develop some tools to really, really automate that. But it's actually pretty fairly. So I don't have a fancy end slide. So it's like the bulk of my talk. But any questions or discussions or? Yes.
You have to bear with the question.
Sure. Yeah.
To my knowledge, the Department of Environmental Quality, and it probably doesn't matter, but we have our own geophysical logging truck. Okay. Up until this project, we mostly log a lot of coastal plains, wells, mud rotary. So the temperature log when we run our Century multi-tool doesn't mean anything because the drill rods were just pulled out of the mud hole. There's no temperature profile that's had time to develop. Okay, we run the tool. We get that data. We get a temperature log from our Century tool. It doesn't mean anything, but we get it anyway. Well, from this, in the future, now I know that a lot of people are interested in real temperature logs in deep wells. So, and when we go out and do some work in the future, if I've got a 1,000-foot well that's been in the ground, no pump in it, I'm going to run a temperature log in it with a Century geophysical tool. I'm not really interested in what the temperature is at 1,000 feet, but somebody else is. So I'll collect it when I'm there. Here's kind of my question for the future. If I've got a log, one geophysical log from a new well or existing well, how many man hours is it going to take from the time that I get a LAS file, because it's a digital equipment, and let's say I send it to Wendy or send it to somebody. It says, here's a new temperature log of a 1,000-foot hole in the Virginia coastal plain. From there, what's involved and how many man hours and how much money does it take to actually get that new data all the way through what you just described to, in so that someone from California
next month, when they use this system, can say, oh, here's another new well. And this is data in a place where I really wanted to know something. Is that?
So in this current system, it would be a yearly update. You know, say, okay, for the next deliverable, we have well logs, and in the case of Kentucky, we get water well updates every it's like half a year or something, and then we would put that into the system, into a content model, submit it, go through this process. The actual process from when we get that content model is very quick. Making that content model is the work. And it would be really nice to streamline that, where the states have tools to sort of automatically import their data into a content model. Maybe those have been developed by individual states. We're working on that. You know, we do everything in Access and with queries, and so we develop a query to sort of push the data into that model. But I think the short answer is a long time, because yes.
Well, I mean, it's a long time just because of the time frame
process,
and the other things. But the actual mechanics of registering that new data set would involve. I mean, right now we don't have an interface form set up specifically for that purpose. But for instance, the form we have for registering a new tier 1 data set, just a file-based thing. You know, you fill out a form. It would take you, 10 or 15 minutes. Yeah.
That's the answer.
And you could file online something.
10 or 15 minutes.
Okay, well
that's
because it's not a new data set.
Oh,
it's
right.
just one more log to add to a currently existing data set.
Yeah.
Well, in my example, it was.
Yeah.
We already had this well already in the system, and I went out and collected data, and it was drilled in 80, and I'm going out next week. Right. Now, how about now? It's a brand new well, and I'm going to drill a 1,400-foot well in the Northern Neck next year.
It should still be the same,
because
it's a like type of data that already exists in the data system.
Okay.
Right, but to actually get that new location, I think getting the tier 1 part is very quick, like we said. However, if it's a new well location, that update, there is a timeline between when we get that actual location, because it has to be part of some deliverable, or maybe hopefully we can develop tools that we actually get a new location in.
Well, that's another thing for the future that I would like for all the states to have, is some way to add data to the data system. And what I would like to have is, for the Virginia survey, is on our website to actually have a button that the user can click, and it says, add geothermal data. I have more data. And you click on it, and somehow it takes you somewhere where you can enter, say, I have this type of data, click on it, and then enter in what it is. Yeah. And then it'll get shipped to wherever. Right. And if it is compatible, then it'll be uploaded right in.
If I get a new well, can't I just FTP it to you, Wendy, and you ship it on? Or do what you want with it, but it's no effort, really, to add new wells.
The real problem is that the data collection part of this enterprise is going to be dismantled starting in September and completed in December or January, and most states won't have a system for entering new data because people will be gone or moved to other projects. Wendy will be working on another project come January.
Yeah, but the thing is that, are you using LAS 3, 2, or 1 as a format?
I don't.
Okay, let's say LAS 3, then the log has an LAS format of 1 to something like that. And I don't see the problem. I mean, you just get on your PC and you just ship it out.
Well, there has to be the time to do it and a person to do it. So the question is, how easy do we make this? Is it something that anyone can do? Can anyone add data to the NGDS, or does it have to come directly from a state survey?
It should come through you.
Well, no, it should come
Well,
to the
yeah, so there needs, I mean.
Well, I mean, if I,
Well, I didn't mean to maybe jump ahead in our agenda.
Yeah, but I mean, that's the critical question.
If there's a better time that we want to talk about this, we can move on to.
The mechanics of doing it are pretty straightforward. The engineering, having the people to do it is probably the difficult part.
Okay.
Yeah, I was going to say the knowledge base is really, you need someone who can identify what the fields are and what the data valid terms are, and whether that's going to be built into the form or however it's done.
Okay, there's a question that's probably a little more survey-centric, but it's related to this. Let's see if Doug may address it. But two programs that have been funding mechanisms for work for state surveys, the first one, the National Geothermal Data System and State Map, Geological Mapping. And Geologic Maps, we've heard, is one of the products that are being loaded into this because it aids in geothermal exploration. Now, from what my staff has informed me of, and this is not my forte, so pardon me if I misspeak, I don't speak, but basically, to get money from State Map, we have to push our data up to the USGS for the national map, and their protocol there is similar but slightly different than some of the same protocols for the way maps would be built here. We're getting to a fork in the road where they're requiring through the new National Cooperative Geological Map 09 protocols for how you create the different layers for the databases, I guess. So I just wanted to know, is that on your all's radar screen, and is there some way of rectifying this? Because I'm sure other people are kind of getting to that. Do we use this model that we have to report maps to USGS for this, but it may not be exactly compatible with somebody applying extra work or doing something else, and we don't know if that's an issue for us.
Right, so the NCGMP 09, that database basically would be a tier 2 delivery in the framework we have right now. Right now, the geologic map delivery stuff we've got is using the geoscience portrait. One of the things that we've been working on is actually sort of a push-button process to go from an NCGMP 09 database to the geoscience portrait service. You can do it because all the information you need is in the database. It's just that's again one of the reasons to pursue using these standards is you can start to automate that kind of stuff. But from the point of view of the if and when the state map does actually start requiring that delivery, right now it's still the map. I mean, we're still giving them PDFs, right? And so from that point of view, just creating the metadata record for the PDF, that's why we want to make that one process where you create one metadata record. It's in the map catalog that can be harvested for NGDS catalog as well. That's why we want to get those things integrated, and it hasn't happened yet, but it will.
Will there be some type of path or direction of what's the most optimal way to do that? Converting from one going this way to that way.
Well, I hesitate to make promises. I can tell you how it should work is basically you can do one or the other, and that they would be harvested from each other. And so you could just have your choice, whichever was easier for you. For a lot of us, we're used to putting stuff in the map catalog, and so to me, in a lot of ways, it just makes sense to keep doing that.
Right.
NGDS
that's the other thing. Some people have already started and have established change.
Right. So that's why what I've been working on, Dave, and you guys should too, to say, hey, make the map catalog harvestable, so these other search engines can search it more effectively. So that's.
Thanks. Doug, I have another question. I guess you mentioned that I think it's a reasonable objective to make yourself obsolete and to push or enable as much as possible state surveys to take on the role of distributing this data as much as possible. It seems like what we wanted to do. And one of the things we really were challenged with from the very start was just the cost of storing data. And we have in Virginia probably the same situation as a lot of other states where we have a sort of an overarching agency that supports our IT infrastructure, which includes server capacity and things like that. And so when you're talking about storing raster images and other things and taking up a lot of storage space, it does begin to get rather costly. And so we made a business decision early on that,
Well, we just weren't able to absorb those costs, even in Virginia, much less the other you weren't going to try to do it for the other states that we were working on behalf of. So right now, Kentucky, the Kentucky hub, or the hub at Kentucky, is serving our, Virginia's data as well. But ultimately, we want to get to the point where we are serving this out and have it essentially Virginia being the hub for this stuff, whether it's a USGen or NGDS hub, however that works out.
The Virginia hub, survey hub.
Virginia survey hub.
And the advantage of doing that is you can, we're just kind of data update is much faster if you serve your own data.
Absolutely right.
You get a new record, hopefully that would just.
You could have the ideal would be you're serving your well data. When you get this new log, there would be just a website with a form. You would log in, fill out the form saying I've got the file, and you would say where's the file, and you'd upload the file, and it'd be in there. It should take 10 minutes, ideally.
Right. And so not to steal the show tomorrow that Wendy's going to go into, but we have started to look at different options there, and not just for this project, but for our department as a whole. And so we'll hear a little bit more about it. Well, my question is, do you have any sense of what the cost is? And I'm not sure how you do this, but you've got enough data now that you're serving out to these various states. Do you have any sense of what the cost would be to process and hold a unit of data that pertains to this project?
We can probably actually.
I think they'd probably answer. We did come up with budgets actually for that purpose of determining, sustainability costs.
It really depends on what you currently have available. We've seen, and it also depends on what you're planning to use and what the licenses are that you could have. We're fortunate in that we received our GIS license through the University of Arizona, so we have a special academic rate. That is not the rate that's the same for governments or for private entities. It's, I would say, what, 10 times higher?
100 times
100 times higher. I mean, it's very, very costly for private sector use of our GIS license. So it's very variable. We've seen anywhere from on the low end to set up your own server man hours, $17,000 to upwards of $50,000, $60,000 to do this. That being said,
but that estimate includes also some FTE support.
That includes the man hours to support it. Right?
Without that, you're nowhere.
Absolutely.
And we'll have a little bit more detail on the sustainability discussion. The Note-in-a-Box software, the CCAN software, I'm trying to refine those numbers a little bit, but we've heard that on an Amazon Instant Machine, you can run that anywhere from $75 to $100 a month. So that then is dramatically lower at about $1,200 a year. So, but that doesn't have the man hours included on that.
That would just be the hardware and software, but it's all open source. But it is, I mean, the $62,000 that those guys are sticking you, I mean, how much did your 2 3 terabyte NAS devices cost? 16,000?
Yeah, I think.
I mean, for that kind of money, you should have 100 terabytes.
But I'm getting with that a backup site in 2 locations in North Carolina, within 24 hours a day. Everything's backed up every 14 days on. So, for example, it's every week. One of the servers is backing itself, backing the data back up from each other there. So there's a lot of redundancy. There's a lot of stuff there. But we also have a state IT that they control. It's their app. That's where it is. So I just want to share with everybody, when we're looking at a state map, and I have my staff working on the state map. Got it? And you go through 3 revisions or 5 revisions. Every one of the revisions are saved. There is no revision 1, revision 2, final. There's every single step along the way. So sometimes we've gotten as many as 27 revisions of a state map before we send it off to the USGS. And that whole history is kept because those are all public records. Every one of those is a public record, so someone can see how we got from A to Z versus this is the final product. Everything before that is our responsibility to keep up with. That's not how state IT looks at it. It's public records, and that's where it's supposed to be. And one of the other questions about this is that I look at there and see Arizona, you didn't cheat because you are affiliated with the university. Others of us that are not affiliated with the university can't have that option. So we pay corporate prices for our licenses.
Can I actually, I need to put Delaware folks on the spot here, but can you guys say a few words on what you're doing? Because you guys do have a GeoServer up and running. You're not using our server, right?
That's right.
Yeah.
Yeah, we used open source. The guy that put together our US GIN node used all open source software to do it. So he doesn't, I won't say he doesn't believe in ESRI. I'll just say he doesn't really think that we should be a total ESRI shop. We do use ESRI because we have an ELA with the university, so we can have any product we want from ESRI, but it's probably a good thing to have eggs in different baskets there. And so we have put up our USGN site and have all of our map services running in map server. And then we use GeoNetwork as the catalog for all of the metadata. And so we recently got a grant from Arizona 2 to put up this USGN site and document, kind of like that node in a box thing. It's kind of like what we had to go through as the Geological Survey to put together our USGN site, and we did do a study of what's the best way to get the metadata from our catalog now, because our catalog 10 does metadata completely differently than older versions, and into the new GeoNetwork catalog. And so there are a couple other open source packages. One's called GeoCat Bridge, and you can actually use that product as an open source product. It runs as an extension in your catalog or in your AutoMap, and it will publish your map service right to map server or one of the other open source map server products, and it will actually make the metadata and create the map service just the way you have it portrayed in our map. So there are open source ways of doing it. It's just that you need to find a Duff Curl or a John McCallaghan to do it for you. Because those of us who are missed the technology wagon in the last 25 years, it doesn't come that easy, and it's not that always that obvious.
And from the investment side too, we're kind of going into strategic planning, and we're kind of at a crossroads of how do we go forward as far as cloud-based services or our own, and security issues and things, and all this kind of comes into play here. You know, quite know what's the best way to approach it, and you might find that out in hindsight, but
well, what's best this week might not be the best.
Right, especially since the University of Delaware got hacked and some 2,000 people's data.
I will also say too that using open source software too, there is in my mind, a little bit of a hazard, I guess, would be a good word to use, that you're relying on the open source community to keep that up to date and keep up with the bugs in the software and keep up with the vulnerabilities in the software. And so it is a little bit of a leap of faith to go in one direction, but it can be just as bad the other direction too, because for those of you who use Microsoft products, we will constantly have to keep them all up to date. And as we move forward here in this world of technology, that becomes a full-time job for someone too, just to keep everyone's computers up to date. Otherwise, then you become the weakest link, and there's that little bit of a headache as well. But these data, putting the data together is, I applaud Virginia's efforts because they did, 5 states? And that's really great because just in my one little state, just doing our geologic maps, I was in charge of doing a study on what's the best way to get the metadata done and get it actually exported into these Excel files. And then also to do the one geology Excel file, it requires a lot of work, and it's not something that you're going to be able to just go to your geologist and say, okay, this is how we're doing it now. And so you might have to hire someone who just takes care of that part as well.
Actually, I don't want to hijack tomorrow's conversation because this is where we're talking about in terms of sustainability, but I actually think this is a great point that Sandy brought up. And, you know, for a long time, we maybe didn't have a full-time IT person on staff because we didn't need it. You know, and then as computers became ubiquitous and you had servers on site, you ended up having to bring in somebody to help manage that. Same thing goes with your website. You know, at first you might not have had a webmaster or a web person on your staff. 20 years ago, it's probably non-existent, but I guarantee you each and every one of you has somebody managing your website or a portion of it today, and that's part of your operating costs. You know, is this the direction that we're moving in with data services? And we're arguing, yes, it is. You know, in 20 years, you might have a full-time or 2 or 3 data person on your staff, and that's just part of your general operating costs in maintaining your data as we become more data intensive. I mean, what's we're doubling the amount of data that's created every 2 years. Is that the most recent statistic? It's just insane. So, anyway, that's something to think about as we move into the sustainability talk here. Is this something that needs to become part of operating costs within surveys?
And then also, I mean, during the initial build out of your system, they'll cast a very wide net. So you may want to look at what you're actually collecting and storing, and there might be fewer or maybe more of a core set of data that's critical to your mission. And that might lighten the load, maybe consolidate nodes or whatever.
Well, that I mean, going in the sustainability picture, one of the important things that actually is still missing from the technology, even certainly from what we're doing now, is the ability to monitor. When you set up these data services, how's it being used, what's being used, and then I think as we move forward, we need to develop the capacity to do that a lot better than we currently can, so that you can say, oh, nobody's using this service, a lot of people are using this service, so this is the one I need to maintain and work on. And so that we need to get there. That's just part of the evolution.
Kim, maybe you can answer this. What's the, how would you rank the relative cost of hardware, software, and personnel?
The relative cost of hardware, software, and personnel. That's a loaded question.
Well, I mean,
and I say that because, again, it depends on where you're at and the choices that you're going to make in terms of software. You know, I mentioned the fact that we can get the Esri license from the University of Arizona, so we have an academic license. And Steve, do you know off the top of your head what we pay a year for our Esri license?
$2,000.
$2,000. You know,
when we calculated out what it would cost, you know, at the commercial rate, it's like $1 million.
But the hardware is at the bottom, I guess, right?
It depends.
The
hardware is at the bottom. Yes.
Yeah, the costs are coming down. I mean, I can buy a terabyte now for $100.
Absolutely, absolutely.
Yeah. Well, in our analysis of the cost at Arizona, it ends up being about 80-20. 80% of it is people, and 20% of it is the hardware and our software costs.
But again, it's also a qualifications discussion. You know, I can't be the person that goes up there. I'll be the first one to say I'm in that generation that's, you know, and been in those technology.
This creates a line in the road for a state survey because, as many of us know, budget constraints, you know, we get forced to downsize, and as our workforce is getting older, you know, there's a need for maintaining the scientific core. But then you could easily invest whole FTE into the data management side of things, but you need those people to collect that data, that person manages it, and it's coming to these kind of critical points and questions, you know. Once again, that does fit into the sustainability, because if the administration, everybody else is really interested in big data and how that goes forward, you know, some help in that regard can help the whole system.
It's a new paradigm in workflow.
Well, this is a great discussion. Actually, this is going to touch on a lot of the topics I hope that we will talk about tomorrow in the afternoon discussion. Talk about ways of sustainability. And again, thinking, I mean, if there's a way to leverage, you know, the regional aspect of this and work cooperatively, maybe not just as individual states, but perhaps as a regional partnership. I think that would be probably cost effective. So we can explore those challenges tomorrow as well.
All right, I followed along the example that was given me about it being basically geothermal resources development and state regulatory framework. Our perspective on here, there are a lot of things that have changed in North Carolina in the last little bit, so it is a dynamic system in place here. We started out in 1823 with the oldest state geological survey in the country. We've been tasked when the Organic Act was created to basically examine, describe, and map the geological resources, geological hazards of our state. Our job is to find the resources. I don't get into whether we exploit them or not. We just provide a job to find them and publish those findings. We provide unbiased, impartial, relevant technical information, and we're the custodians of rock samples and stuff like that. So if anyone wants to go see it, we have a repository that keeps up with all of it. Our retention policy for papers and stuff like that, the geological survey is real simple. It just is one line. We don't throw anything away. That's what the ability to have us pull stuff out of the fire. And these two posters on the wall right there, my colleague Jeffrey was working with USGS, and also on this, we have our carbon sequestration study that was done for looking at potential for carbon sequestration areas in the coastal plain. This used a lot of our deep wells and information on those deep wells to get information. So it basically has a total relevance to the geothermal issue because both the Hatteras well is the deepest well we've had cut into our coastal plain in North Carolina. So what I'm going to talk about today is basically defining the resource. We look at prior geological investigations, development of the resource, and state regulatory framework. First of all, define the resource. We talked about that this morning. Hot rocks. We don't have any, like the geysers, geothermal type stuff. We don't have that in North Carolina. So when the opportunity came from the ASG through the Arizona Geological Survey of, we want you to play, we want everybody to play, it started off with a very simple issue of why? So when I started going up to the management team and saying, fine, I'm going to apply for a grant for over $100,000 for a project where we have no resource. Well, we might have a resource. The key thing comes down is that Hot Springs. We have one. Hot Springs. It's right on the Appalachian Trail in Madison County. It's just water that came from the river and went down into some warmer rocks and comes back up to about 104 degrees Fahrenheit temperature. So it's not considered a hot spring. Insulated rocks, lots of them. One of the biggest ones was back in our meeting, ASG meeting in 2011. I was sitting there and they started talking about one of the big projects that had come in, geothermal project. It was one where they had drilled a series of wells at one of the new company headquarters in Raleigh, North Carolina, and they had been pumping ethylene glycol in along those series of 48 wells to provide a reduction in the cost for heating and air conditioning the building by using that information. That's how to do that. Well, that is a great project to look at, and I want to talk about that later on in the regulatory framework, why there may be in North Carolina a hiatus in those kind of projects. Prior geological investigations are our oil and gas exploration, as well as our detailed geological mapping. We have 128 wells that were drilled between 1925 and 1988. 98. A number of the coastal counties are covered in that area. Basically, those top 10 are 85% of all the wells drilled. You look there and see most number of wells we had drilled in 1 year were 19 back in 1971, and the Geological Survey was composed of 4 people at that time, including the state geologist. And they had to be on all those wells to deal with that issue because that was the regulatory framework we were in at the time, back in 1971. That's Hatteras well in the foreground, and that's the Hatteras Lighthouse in the background. It's now been moved back from the coast a good bit. But to give you an idea, this was drilled down to 10,000 feet total depth. Deepest well drilled in the state. About 100 feet was drilled in the basement, so there's like actual basement rock samples we still have in our collection. from the Hatteras well.
What kind of rock?
Jeff? Rano?
It's just called some sort of a Rano rock at the bottom, but
Was it metamorphosed?
No, it's a Cretaceous Jurassic strata right above it.
Oh.
This is the Hamlico Sound one. That's a seaplane you see in the foreground there. So this was drilled out of the sound, about 30 feet of water, and that was drilled at 47, went down 6,000 feet. Both of those were what we call no-shows. Well, if you look back at the 1940s, no-shows meant I don't have a producing well. There may well be gas indicators or something like that, but it's like no-show meant you can't turn into a producing well. Our detailed geological mapping includes Hot Springs, North Carolina, 124,000, as well as our work on state map and the Raleigh 100K sheet. So we go to the thing of the state paradigms. First one of the state paradigms is the Division of Land Resources became the Division of Energy, Mineral, and Land Resources, mainly because shale gas was found in our state. USGS assessed it. We got a name change for our division. After 42 years, it would be called the Division of Land Resources, now called the Division of Energy, Mineral, and Land Resources. I'll tell you what mineral is, but they didn't say minerals, it just said mineral. That's the way the General Assembly wanted it done. Secondly, that was in July of 2012. This year, the State Energy Office was absorbed by our division. So that's where the energy section comes from now. It took the General Assembly 2 years to do it, but now there's an energy section that now is not cast to look at just energy from energy efficiency, green buildings, the STAR program for appliances and stuff like that. This is an energy office that will now be tasked to find energy resources, whether it be wind, solar, or geothermal. There is exactly 0 people in the Geological Survey, in the State Energy Office that knows a single thing about geothermal resources. I wish we could have one of them here. It would have been nice to have them here to just get a first introduction to how much the wealth of information and how much expertise there is just one state away that they could talk to about geothermal resources. Also, our stormwater clouds were absorbed into Denver. For y'all, the Division of Water Quality, 35 years ago, there was a war going on within the Division of Environmental Management. That was the one that kept care of water and air. That was basically a third of the agency. The entire of the Department of Environment, Health, and Natural Resources. That organization had a war going on between the 2 lead chiefs for, is it going to be water or is it going to be water quality? And the way they did that is when they broke them up, they broke the water unit into 2 pieces, a water resource group and a water quality group. Both of them do duplication of effort by going out and doing each other's work on looking at characterization of stuff, which is really the Geological Survey's domain. So one of the problems you face with is after years and years, decades of duplication of effort and such, the General Assembly just said that's the end of it. And they're not being combined into one unit. The advantage with that is that all of a sudden for Wendy, when she comes back down, she will then find that there's a whole bunch of water quality information in those wells that are recorded in the Division of Water Resources online database that y'all had searched. Because the water quality data was kept in a secret VIMS system only used by the Division of Water Quality. Well, you have to understand, part of this being, if you're going out sampling someone's private well, and the private well shows a cedence of one of the particular items there, and you're sent the notice from the health department saying, please don't drink your water or put filtration on your water, they don't want that to be like in the national database. In fact, our Water Science Center intentionally does not report like 2 decimal places the locations of the wells because we don't want people to find out what well that actually is. They get a general idea within half a mile or so. And sometimes the wells that are located in the county, it's listed as being in that county, line up outside the county because when you round it to 2 decimal places, the point moves outside the county's borders. Even some locates offshore. That's the way the system's set up. Our task with our new administration is customer services job 1. We are real big about being customer oriented. So if someone wants to know something, A third of my staff's time is spent answering inquiries. So when someone calls in and says, I got a geological question about North Carolina, our responsibility is to answer that question. It's not to send them to a website. It's not to say, oh, well, if you go to da-da-da, they want the thing to come from us.
Excuse me, Ken?
Yes.
Did you say the water quality and water resources, did you say they aren't no more? Or they just
they have been, the water quality has been absorbed with a 15% expected downsizing within the next year. So if there's duplication of effort, if you're one of those duplicated persons, there was a good chance someone will be leaving the organization. See, the key thing comes down to right now is that when you have drillers we have a drilling crew in our Division of Water Quality that drill for the Division of Water Resources, because the Division of Water Resources does not have their own drillers to put in observation wells.
So what's the name of the state organization that these people are going to be under? Tell me that again.
Division of Water Resources.
Division of Water Resources. Thank you.
Division of Water Resources. Okay. Now, what you're talking about is the two biggest divisions. One little teeny division being Water Resources absorbs a division that is 4.5 times bigger than it. And boom. So now you understand who's the losing side, who's on the winning side. The biggest part of this with the geothermal issue is it comes down to the whole issue about it being information that was basically unavailable even to me. I can't get access to the DIM system. I'm not allowed to. Only if you are a DWQ, Division of Water Quality, can you get access to the system. So there are now data sets that will now open up. And yes, I know it's, we have to get it all done by the end of the year. But like we have the opportunity now to go fishing off for something you're looking for that might actually be in a database that you and we now have access to, or potential access to. Okay? Now, the other paradigm is one that's really kind of bad. When you look at that company, I think it was Cisco was their new headquarters. They had put in 48 wells to basically see that they were looking at a 30% reduction in their cost of heating and cooling their building by using this geothermal system. Well, it turned out that 70% of that 30% reduction came in the form of a grant or a payment made by the State Energy Office for the Green Efficiencies Program, because that's sort of rewarding you for having taken the risk of putting in that geothermal well system. Well, General Assembly said that program just ended. That's it. We're not giving anything more. So now you look there and see, I'm the manager of the office at Cisco, and I'm now looking and seeing, I'm looking at a 30% reduction in energy costs. It's now going to be amortized, where 70% of that was coming from grants over the next 15 years. I now have nothing going on after the third year since that plant went in. How am I going to explain to management now? We probably will not amortize the building of that geothermal network in the construction of that building. This is one of the things we're looking to see is that, folks, when someone talks about, I want to do geothermal energy, it's always based upon, do you have the money and efficiency to get it? It's not just it's a good idea, it's is it actually the cost-effective way to get this done? So I just bring a perspective of having had 6 months with a new management team, and it's like, there are a couple of things. It's always about the economic. It's not about just saying, oh, we want to do this, it's the green thing to do. Secondly, is there a customer out there looking for information? Now we have a very good weapon because we now have people who actually want this information. Companies, commercial companies want this information. And we've collected it for the citizens of North Carolina. So for them to have the advantage of it, we want to participate in this program because we're getting information that companies could use to potentially look at new sources of energy in North Carolina. We have people to connect to for the people that are in the energy office of like, I know nothing about geothermal energy. I have a professor they can talk to, retired from Virginia Tech. I'm not going to, my job is to get them to the resource. That's the resource. I don't need to go and say, Dr. Tell me what you know. No. Just hand it to them, and he's a nice guy. He's really nice to talk to. Just talk to him. So one of the critical things about it, looking there and seeing is that we may end up where, and this is something I want to make sure everybody understands, we collect data, we collect it in a cohesive manner so it can be shared easily with everybody else. And part of my discussion with y'all today, and really would like your input here, is when it all started out, we'll tell the whole story. We applied for the grant expecting my landslide folks. We had a 5-person landslide team. Our landslide team was already identified as being potentially defunded. I'll say it the right way, defunded. The Home Builders Association and the Realtors Association in Western North Carolina said, we do not want this because this will be the beginning of zoning. So the problem was that I had sat down and put a plan out of taking existing grant systems we had and finding places to put all 5 of my people. The word came down, they're gone. I go out the last day they're working for us with the HR manager to remind everybody that no, you're not going to get hired by Ken because the state wants y'all dismissed. So I planned to put my 5 people in various other positions within the organization that were vacant. As lateral transfer didn't work. So
and is it that easy?
What?
What you just said, I mean, just getting rid of people like
yes, they defunded. That's it. We're not going to do this anymore. I get money from the General Assembly. I am a state agency. I'm not part of the university system. I don't have a professorship that goes with my job. Serve below our state geologist. David, what is it, 22, 23 of us state geologists actually have a full professorship? I mean, like, for example, Harvey Thorlson. Yeah. He's a full professor at Minnesota and state geologist. When you go into the Indiana Geological Survey, you go in the west door, it says Indiana Geological Survey. Go in the front door, it's the geology department at Indiana State University, because that's the way to do it. Now, that brings you at an extra lot of reflection because, see, I can identify a professor, I can apply as an academic for grant money. I also apply as a state agency for grant money. My overhead is differently between those two. My overhead from USGS goes to pay the lights in the building in other units. It doesn't pay for my lights, it pays for someone else's lights. But that's the cut the department gets, period. So one of the things about it is like, there's no match to this. This is free money. But the whole thing is that they wanted free money where we hire someone temporarily for a very short period of time, like a year, and then they're gone. We had no scanners. We have no equipment. We can find it. I can dig it up. We got to take it somewhere to get it done commercially. Do you bring a person on board to collect the data and to get it formed up and put it in boxes where we can then make it turn into digital files and such? Or do we say, fine, get the equipment that we'll use one time, get all this stuff, we'll rent it, and then end up being where we don't have much money to pay for a person? So I bring up this as an example of being where I'm in like Gumby. This is like Gumby world where I can bend and flex whichever way you want me to bend and flex. Right now, this is a hot item because the energy office has been brought into our unit. The energy office has been asked about geothermal, and they said, we know nothing. I said, I know a lot about geothermal. I also know a lot about what I don't know. And know where I can connect you to people who do know. If the green building program has been ended, and the General Assembly is not going to allow grants to go for green building anymore, there may well be in North Carolina a little eddy of, they don't play that way in North Carolina. It might be in South Carolina, it might be in other states, Virginia maybe, but it's like, it's not going to be in North Carolina. Because they look upon it as being its actual dollars of cents. If this technology is worth it, it can stand in the sun, as opposed to being propped up by 70% of the cost being basically paid for by tax dollars for a period of 15 years. So that's what shale gas thing. I get the dollar from Jeff every time I put the shale gas picture up there just to show you that kind of thing there. The key thing about it is that this area and this area in North Carolina, our shale gas project, some of my fellow state geologists, that's what I've been being busy with for the last 2.5 years full time on doing this, with getting all the rules in place to deal with the shale gas program. But a key thing about it is that, a lot of the stuff about it being there, in this entire basins here, we have, Jeff, four wells. All right, it's like just TCF. Yeah, it's 4 TCF. 4 trillion cubic feet of gas. Well, hey, that's North Carolina's consumption for what? About a year. The whole thing about it was that we got into USGS credit for only stuff we can prove. We didn't get a chance to say, oh, in a good day, on this good day, this is a good work. That's not going to be what you can prove. So the key thing I want to do is in the discussion today is, one, I want to thank the folks at Arizona Geological Survey, the people that are in the program for helping us get this thing done. I thank the people from the Geological Survey for helping us out with this. I'm sorry it didn't work out. I wish it would have. It didn't. But I look at there and see one of the biggest questions we face with here is that this is something that could be potentially important for the commercial benefit, and have y'all captured the commercial benefit of this project? I'd like to send you some stuff about it, because the whole thing of the thing, there really is a potential there to say, this is one of those, it's a good idea to do this, and like, oh, it's a good idea intellectually, it's a good idea economically to do this. Okay? Because it may turn out to be, X, Y, and Z geothermal companies actually looking at the databases to see that, and there's actually corporates coming in to look at the stuff, not just a scientist or someone interested in geological information. But I will sum up here about this, bring up the issue about it being, standards are real good. It forces everybody to speak in the same language and share some of the same language. We're supposed to use centigrade, right?
Supposed to. Depends on the day of the week.
My whole thing is that I did not want to really take up the whole afternoon with my full 30 minutes. I want to go ahead and get to this really quickly and deal with you. Or this way. Thank you for the opportunity to come out here. We wanted to show you some of the stuff we're working on here. But the idea is that one of the things we're looking at, Jeff can more explain this than I can, because these are projects he was the lead or was our point of contact on with USGS. I look at there and see right now that, as we talked about, and I wasn't picking on you or picking on the state there, but it's like y'all's is to collect it, not to QA/QC it. It's back to us to QA/QC it. And we end up having where stuff doesn't make any sense. Well, hey, that's selected out from this file. The name of the file was this. This is what it was. Hey, it was misfiled. We can find that stuff for you. We can find that out. This is not the right well number and stuff like that. So that's telling me my time is up. Thank you. Are there any questions for me? Thanks.
Thank you. Jeff, there's a couple of minutes that you've got still. Is there anything that you wanted to point out on the poster particularly that you could describe?
Yeah, I'll just take a couple minutes. The reason I brought two posters. Okay. Hold stand up. So I'm standing up. The reason we brought these two posters along for this particular group is because it bears what its focus is. One left is carbon dioxide sequestration, saline aquifers, and the one on the right is in terms of oil and gas exploration on the coast, going into old wells with new technology. But the reason for bringing these to this group is because it really gives some idea along the east coast of what geothermal gradients are to bedrock and to the depth. The deepest well in North Carolina, and I believe on the east coast, including up through Newfoundland and that area, is 10,044 feet, as Kenneth mentioned. The Hatteras Lake well, and so the bottom temperatures there are only about 112, 113 degrees, something like this Fahrenheit. So they're quite low, but yet you'll see that there's some anomalous oil concentrations that we found with fluid diffusion technologies. And, there's a whole separate story I can speak to you about that offline. But at least it will give you some idea of depth of the land close to the lake. And at 100 degrees or 100 feet, degree per 100 feet, we just can't barely get it much higher than about So that provides some constraints in terms of geothermal activities or gradients along the coast. So I'll go ahead and discuss this with you separately, grades or however it is.
Thank you, Jeff. Next up, we're going to hear from, I believe, okay, Scott.
Well, I'm just going to give a talk after.
Okay.
I'm just going to give you a real brief overview of the geothermal climate in South Carolina. I could be a little bit clever. But I'm going to look at the development and regulatory training. Thank you very much.
There's a pointer and right and left.
Am I close enough? There is a state energy office in South Carolina. It's in the Budget and Control Board. And if you go to their renewable energy page, you'll find that they actually have a little blurb on geothermal. And when you see what they're really interested in, they're really interested in promoting heat pumps for home use, in some cases commercial uses. But mostly they're interested in tax breaks. So they're interested in giving you a tax break to install heat pump systems. And that's where their real push is at. If you go to the rules and regs of South Carolina and you query geothermal, you come up with about 1, 2, 3, 4, 6 hits.
Sorry, I'm trying to fix something.
Not do the dance.
Technical difficulties.
There we go.
There we go.
So they're about 6 hits, and they come under things like public buildings and properties, environmental protection, conservation, taxation, under the agriculture department. I don't know what that's about. So when you look for rules and regulations that might control the development of geothermal energy in South Carolina, it just doesn't seem to be much. And that's the way they like it right now. The only control that we would have, or the state would have, on geothermal development is under the Department of Health and Environmental Control, under their well standards. And the well standards are probably very familiar to everybody. They're going to be very similar. They do actually, by name, identify geothermal systems. And they define what the drilling is like, how it can be done, how you can't cross aquifers, how you can't contaminate aquifers. And just like in any water well drilling situation, they describe how the grouting has to be done. They say how it has to be identified and how that has to come back to them, with that tag on it. How it will be reported within 30 days. And then again, a standard well record form. And the driller's log, information that might be collected. Now, one thing that might be useful in the future would be a temperature field. So if we could persuade whoever that would be to include a temperature field, that would probably be a good idea.
Quick question.
Sure.
That form, your form, is that done, let's say you have a 50 well geothermal field for a school. You have one piece of paper for each in the field, or one that?
One for each tag.
One for
each tag for each well ID. So, and I don't know how DHEC actually treats that, but they may treat a well field as one, but I doubt it. I would imagine they would say every well has got to have an identification number. Okay. But it is South Carolina.
Thank you.
You may get away with it.
Just on that note, when I was in New Hampshire, that issue came up because I sat on a lot of the boards, geologists, and we came up with a compromise that the deepest well drilled in any field before had to be tagged in the report because that way it was logged.
And this is, new territory. And so there probably isn't anything, and so in the long run, as you say, there probably will be.
We also got legislation passed that anytime there was more than 3 wells drilled greater than 1,000 feet, the temperature profiles had been done.
And there isn't any requirement like that. And again, I can see that being very useful in the future. collect as much information to promote the industry as possible. So what is the legislature up to? Well, the legislature is up to its usual thing. They're just looking for exemptions from the state sales tax. So they're trying to pass every kind of sales tax and exemption tax that they can to promote geothermal. And here's another one doing the same thing. One is that they want to make the Department of Natural Resources, which is the Department of Geological Surveys, and to be the reviewer of all state permits for geothermal. They want us to be able to say, this is good, this is bad. And that may be a way for us to get into this game, as Ken was saying. And that's this restructuring act of 2013. So, really, rules and regulations for controlling geothermal, there's not a whole lot in South Carolina right now, because it's just such a new idea. I've tried contacting the geothermal office or the energy office in the geothermal group, but it's one person who's doing several other as well, and we've just never, in 3 years, never been able to get anything going. But after tomorrow's talk, I think I might have a lot more ammunition to go after. So I'm going to turn it over to Patrick now, and this is actually really interesting stuff, in my opinion. Patrick is a graduate student at USC who's working with us. He's doing some geophysical modeling of aeromagnetic data and gravity data, identifying the structure of the basement beneath the coastal plain, trying to use the most recent data sets, trying to get some real high resolution information on here. And I'll let Patrick continue.
Thanks, Scott. So yeah, Scott asked me to present to you all or share with you all some research I've been doing at the University of South Carolina in conjunction with the State Geological Survey and USGS, modeling and mapping the buried basement of the coastal plain of South Carolina. I'm going to start with an overview of the project, discuss some of the data sets I'm working with, present to you the 3 two-dimensional forward model profiles I've developed, say a few things about where this research is going in terms of Earth scope, which is making its way into Eastern North America over the next 2 field years, and then try to relate my work to the topic of discussion here, geothermal prospectivity. So an overview of the project, basically the idea is to leverage the excellent spatial coverage of potential fields data and incorporate with that other geologic and geophysical data sets to mitigate against the non-unique solutions that are inherent to potential fields modeling. The motivation for research is basically that, as you all know, the buried rocks on the coastal plain record the history of North America over a Wilson cycle. In brief, basically Paleozoic continental assembly and collision, and then Mesozoic rifting, the camp event, Central Atlantic magnetic province, and then drifting. We believe the methodology at work here is very well suited to identifying major tectonic and geologic features, Paleozoic faults and granitic intrusions, as well as Mesozoic rift basins and associated mafic and plutons. And we believe the project will assist with CO2 sequestration assessment as well as geothermal resource assessment. Analytical products coming out of the study, a database of rock properties, including densities and magnetic susceptibilities, several strike and diff-oriented 2D profiles forward modeled for gravity and magnetics, and then from inverse modeling, a basement map featuring depth of basement, major tectonic elements, structural elements, and basement geology. This slide summarizes the data sets I've been working with. We have a gridded aeromagnetic data set publicly available from USGS that Daniel's put together. Land gravity and basement well databases, courtesy of the South Carolina Geological Survey. Several seismic refraction and reflection studies, and then a database of rock properties from lab measurements and literature review. This is the aeromagnetic data set. You'll notice that for most of the state, especially onshore, we have a line spacing of a mile. The flights were flown at 500 feet. and then stitched together and gridded. This is the land gravity. You see that the sampling density is much better in the coastal plain than in the Piedmont. Station spacing here is 6 to 7 kilometers, whereas in the coastal plain it's 3 to 4. Basically, the takeaway from these two slides is that it's a very rich potential fields data set. Here are basement wells. There are about 60 of them. Most of these are water wells, but there are some oil and gas wells, mostly in the Triassic basins, and some test wells here in the Savannah River site, Savannah River National Laboratory, DOE property. And this sort of pulls together those data sets. This is the gridded aeromagnetic data along with the basement wells and 3 profiles here in the Savannah River site. This corresponds to size data 4, 2D seismic reflection study, and then a coastal strike-oriented profile. And another thing I want to mention here, I heard it brought up earlier, aside from gravity, how can we identify buried intrusives or intrusives in general? And one addition to that is magnetics. Along this trend line, you can especially make out the edges of these granitic plutons, the Pageland, Liberty Hill, Winsboro granite here in Edgefield. And then there's another one here in the coastal plain and here that you don't see very well. But if you switch to gravity, again, you can make out the weak outlines of the Piedmont granitics, but then also prominent gravity lows here in the city of Orangeburg, South Carolina, and here between Georgetown and Myrtle Beach, South Carolina. The initial profile in the Savannah Riverside area we decided to start there because we had the richest data set. These points correspond to the shot locations for a 120-kilometer long seismic refraction study done by Lucaire et al., USGS Menlo Park, collected in 1991. We have a rich well database in the Savannah River area, and this is SRS-7, a small 2D reflection profile. This is sort of just designed to show you the methodology. This is a line drawing coming from the Lucaire refraction study that we've loaded into our modeling software. And if you look closely at these points, the blocks, the polygons in the model correspond to the line drawing. This is the reflection profile, which was not as helpful as the refraction, but was also used to constrain some geometries. Here is the first model profile, just to help understand. This top panel is magnetics, the lower is gravity. The heavy points are the data, the light dark pencil line is the model, and the red pencil line is the error. The depth here at the bottom of the model is at 40 kilometers. Starting in the northwest, the most prominent feature is the Graniteville Pluton. Depth to the Pluton is about 60 meters. The thickness is about 2.5 kilometers. And we did sort of a rough volumetric estimate and got 2,000 to 3,000 cubic kilometers. Zooming in, the next thing is the Dunbarton Basin here. Depth to the basin is about 250 meters. The Dunbarton Basin is a 1.5 kilometer thick, deep, asymmetric down to the northwest Triassic Rift Basin. It's underlain on the southeast side by a large igneous diabase sill. The depth of this sill is about 400 meters. It is 2 kilometers thick with conduits going down to 6 kilometers. And also there's a major fault here, which corresponds to a major contrast in seismic velocity in the refraction study. I believe it to be the northwest bounding fault of the South Georgia Rift Basin, or sub-basin. Moving on to the second profile. Again, this corresponds to size data 4, a industry quality 2D seismic reflection study, also done in the 1990s. This major point here is it takes us from the Piedmont into coastal plain all the way to the coast, and takes in also the USGS Clubhouse Crossroads well cluster Again, the methodology, here's the line drawing that we worked with, loaded it into the modeling software, and started making polygons. Here's the model we came up with, arranged in the same way. The major feature here is the Springfield Pluton. And what we did is we took a smaller profile line across the heart of the anomaly and inserted it or projected it into our profile to try to model the maximum depth for Pluton. So this is the same profile with the data spliced in, and then a zoom of the same. The Springfield Pluton is buried by 90 or so meters of coastal plain sediments. It is a 3.5 kilometer thick granitic body with a conduit down to 6 kilometers. And a volumetric estimate of that is 3,000 to 4,000 cubic kilometers. The last profile is here along the coast. Runs from Hilton Head Island to Myrtle Beach, South Carolina, and takes in this prominent magnetic anomaly, positive anomaly, in the vicinity of Beaufort. And also that coastal granite, or coastal gravity low, which is right about here. We didn't have as robust geophysical constraints on this one. What we're seeing here is an A prime to C prime cross-section of wells from USGS aquifer study, presented in professional paper 1773, which basically just helped us constrain depth to basement, or the depth of the coastal plain overburden. We had some offshore refraction studies that were of some help, Dylan et al. And then really the major constraint was this profile intersects our size data 4 profile, which is right there. So we were able to tie it in that way, and we started with those polygons, fitted a regional, and then proceeded from there. The major features are the magnetic high referred to right here, and then a large granitic body in the north coast. Zoom in, this is the mafic intrusive. Depth to the intrusive is about 800 meters. It's about 1 kilometer thick. And then a zoom in of the granite. Depth to the granite here is about 400 meters, shallower as we get into the Cape Fear Arch. Thickness of the granite is 3 kilometers there and maybe down to 7 in the conduit. And then relating this to the EarthScope work, this map just kind of summarizes lots of things they're interested in investigating. The Paleozoic structural fabric from collision, the extensional rift basins, and the camp magnetic event, and then also the rift drift transition, seaward dipping reflectors, these sorts of problems. I apologize for the bad focus. This is a snapshot from a breakout session of the EarthScope meeting in May. All these are funded projects in Eastern North America. Two are of particular interest to us, the Sugar Project, which are these 2 little short black lines, and then another onshore-offshore refraction study here. This one is principal investigators Beatrice Magnani, formerly of Memphis. I think she moved this summer to SMU. And Sugar, right here, all these 3 names, is also an active source refraction. We find that refraction works very well with this modeling methodology to help blend constraint. Here, only Sugar has a web page, but here are the principal investigators, Donna Shillington from Willamette Doherty, Daniel Lizardi from Woods Hole, and Steve Harder from UTEP. And basically, we're going to attempt to piggyback on this project and take this methodology to Georgia. As you can see, the Piedmont magnetic green continues in Georgia. Here are the updated locations of the Sugar lines. It's kind of all we have at this point. The gravity, same story. You see these gravity lows creeping into Georgia, and also a prominent coastal low, not unlike the one we modeled up here. And then to try to relate this to what we're talking about here today, you might be familiar with this. This comes from John Castaigne. These are geothermal wells in South Carolina. I'm going to look at a few of them. The black dots represent ones that are whose data are on the site, on the custom site, and the gray ones are locations that I think could be prospective based on my work. The edge field, granted here, you see the thermal gradient around 18 degrees C kilometer. The Springfield Pluton well, not far from our size data 4 profile, located about here relative to our model. And the plot for that, is between 20 and 30 degrees C per kilometer. And then the Ori well C13 up here by our coastal granite, it's located there relative to our model. And a plot for that, between 30 and 40 degrees C per kilometer. And then some of the ones that I think are interest, AIK, Aiken 858, and Allendale 357. This is in the vicinity of the Savannah River site, and a lot of the Savannah River prospectivity has been based on a series of wells collected by Marine and Seipel in the mid-70s. And they are located right around here. They're tracing this northwest mountain called the Basin. So I'm not sure they accurately captured the prospectivity of this area. Aiken 858, we actually have a temperature record for it, at least at the bottom of the hole. How accurate that is, I can't quite say. But it's a USGS seismic hole, 650 feet in depth, bottomed in pink granite, and the temperature at that depth is 30 degrees Celsius. And then Allendale 357 sits on top of this mafic igneous sill, and could be prospective as well. So I have take any comments or questions anyone might have.
So what is the final product that we're going to try and get out for the geothermal project?
Well, upcoming is it's going to be a basement surface map featuring depth of basement, major structural elements, and basement geology based on a three-dimensional inverse modeling of potential fields data. We expect to have that before the end of the month. Thank you.
Next up, we have Lester Williams, who's a hydrogeologist in my company.
Yeah. Oh, I didn't even realize that. Are you serious?
What are you going to tell about your database?
I didn't really prepare anything. I'm sorry, I must have totally blown everything. I mean, I could talk about what we're doing.
Well, Lester's work is actually, we have had gone to Lester quite a bit to pull information, particularly with respect to water well data. So we've relied on Lester quite heavily. Of course, Georgia does not really have a geological survey anymore. So the contacts that we've had with other folks there in Georgia trying to gather information about geothermal data sets, we were, it was difficult at best, but Lester was very, very helpful, at least in compiling information about the water well. And maybe you can just, off the cuff, describe that data set.
Sure, yeah. So back a few years ago when I started a larger kind of a framework project in Southeast, and similar to the geothermal data system, when we went into it, there was really very difficult to find logs or data and things like that. So the first thing that we did was we went down to the state and we scanned in a lot of the geophysical logs and data that was readily available. We also went back to our office. We've got a rather large
filing system with historical data, and we're able to supplement information from our files that seem to be missing. But other than that, it was pretty much digging, trying to find whatever information that we could. We compiled that into basically a database of TIFF images. And for our work, we needed the LES files, so we did digitize quite a few of the wells for doing our correlation work. And of course, all that was provided to the project. We did also compile bottom hole temperatures from the log headers to sort of look at that, but we didn't really go too far with that. What else? There's a lot of lithologic descriptions, although that information is very difficult to get in a format that you can automatically put on cross sections and things like that. So we compiled, basic lithology type of database for our work. But other than that, I don't know what else I would expound on. But
okay, yeah, that's fine. Wendy, was there anything that from the Georgia survey? I mean, one of the things that we did have difficulty with were the oil and gas wells. And there were a number, you listed a number there. And I think there's still, we do know that there are still quite a few logs available that we need to go get. The question is where they were, so that was one issue.
Right. There are more well records at the Georgia EPD that we've been kind of in contact with them. I mean, part of it is just figuring out for all the states where there are multiple agencies housing data, understanding how they all communicate so that we can know, for example, how much data Lester has for the USGS in Atlanta versus how much of it is housed by the Environmental Protection Division in Georgia, and to know how the records overlap.
That's sort of a challenge, is trying to, locate where the records are, actually have the resources to go out and actually scan logs and catalog them, and that kind of thing. For our project, we were mainly focused on the coastal plains, so obviously that was available, but all of the Piedmont and the Valley Ridge was pretty much untouched. So those files are actually still sitting out there ready to be scanned.
And where are those?
Those are downtown Atlanta.
Okay. Because we know we have records for oil and gas wells that are at big BD.
Yeah, yes. I mean, you have, it's not a huge, it's all wildcat wells in the coastal plain. Then you have your cluster wildcat wells up in the Valley Ridge. It would be very beneficial to the project.
Sure.
And you could probably do it within a few days. I mean, it's just one of those things that if we had the time to just go up there and scan them in, you could get them. But that's where most of the deeper temperature data would come from.
Right.
And I know there was one issue of confidentiality, I think, with respect to this as well.
Yeah, I think, this kind of came up with a couple of states just acknowledging which well records we could release, whether or not we needed to modify or shorten coordinates to make it acceptably made public, if there are any sort of header data that we didn't want to include, et cetera, et cetera. So those are issues that have come up in the past. And again, I would stress to each of the states, if you're looking at your well records that are within the NGDS, you see specific items like that you think need to be modified, let us know so that we can make those revisions. Also, another issue that we hit with Georgia, and and I guess some of the other states too, is just sometimes an agency will have well records, and they might not be in a database, but they might be in folders and filing cabinets, but there's no real one person at that agency who really knows what's in them. They know that they exist, but nobody's really taken the time or had the time to go in and document and record what's there. And so sometimes we have missed completing our well records, missed wells, just because we are uncertain of what data is actually housed within certain agencies. And we don't know until we actually go down there in person. And we might find a whole slew of geophysical logs which take forever to scan and digitize, or there might be none. Or there might be no lithology information, no completion reports or driller's logs. So from the beginning, it's kind of hard to know what data is available, if anybody knows what data is available, and what percentage of that might be acceptable for the geothermal data system. So those are some of the issues we came across.
I might want to mention one of the things that we focused on our project, and I tried to get as many of these as I could, but starting back in the 1970s, in the Southeast, we had a Southeastern logging unit. Out west, I think Scott Keys had one out west. There was another one somewhere, maybe out in California, but it wasn't until the mid-'80s that data was digital. But we do hold, and you haven't heard of it, but I hold the rest of the digital data from that program that's essentially unpublished. But that was a really good program because there's a lot of wells where he didn't have a very good calibration on his temperature log, but for the most part, that's where your really good temperature data is going to come from. Well, it was just, we had a Southeastern logging program. I know they had another unit running at the same time in Colorado, doing a whole bunch of work. So there's probably a lot of data out there that is quite valuable. But along with that, there was actually, I don't know if you remember this, but in the mid-'80s, we did a project, I think it was with Virginia Tech, where we went in and did some more detailed temperature measurements. So we picked a series of wells throughout the whole Georgia coastal plain, and those became part of more fine-tuned temperature data. But, the only reason I came across that, I was just sort of going through the files, and all of a sudden I found it.
And sometimes that's the case. If there are sources of data that kind of float to the surface after we've been hunting around, and someone might offhand mention a data set that wasn't readily available to begin with, or only one person knew about. So definitely we're interested in anything we can get. Also to note, we are in the process of compiling. We have one more month before all states finish except North Carolina. So by the beginning of September, we would have compiled and submitted all of your data to the NGDS. And by then, we will also have compiled all of those data records, as well as the metadata spreadsheet files for you onto disks that we would burn. And we'll send those to you guys so that you have a complete record of what we've compiled for each one of your states. And then you can just go in and see the metadata records, check their accuracy if you wish, and see all the actual data records that we've submitted. Also included in those CDs should be a complete record of what we had or what we had accumulated from you but not submitted to the NGDS, with an explanation of why it was not submittable, whether we ran out of time or whether there were problems with the data themselves. So that would be a record for you, a hard kind of copy record for you guys to have at the end of the project that you can build off of for the future.
going back to George, I can't remember if I sent you that, Tim Jones' paper. Do you recall if I sent you Tim Jones' paper on GSS?
I'm not sure.
If it hasn't, I would be glad to resend that to you because he is back and forth. He's compiled all the basement, or all those in particular in terms of the South Georgia. Things that would be a very valuable resource. If to extend beyond that, one thing you could do here is you could have Mike and Laurel and maybe query IHS. I think you'll find them to be somewhat flexible these days, at least give you a perspective as to the well count, if not the locations. And then Tim Jones himself maybe might want to contact you directly and ask him if he has copies of all the logs.
Great.
That's about 100, I want to say 116 wells, something like that. It's over 100.
Yeah. So again, this is kind of a luxury for us with North Carolina because we have an extended amount of time to complete that state. For the other states, this is kind of like the last minute. Okay, here we go. It's finishing up. So yeah, it would have been nice to have had another meeting, another workshop at the beginning of the project to just kind of organize where we are and what sort of resources we had. But definitely that's something that we can work forward with for North Carolina.
Approximately how many decimal wells are there? 160. Well, in the coastal plain, I don't know, what is it, 160 something or 16 or 160. 60. And most of these go all the way through and go right into the basement. And some of them go many thousands of feet into the rift basin. I know we're not talking about Florida, but I'll just mention that our studies covered all of Florida and a big chunk of Alabama. And particularly in Florida, over the last few years, we've compiled from a lot of consulting reports, very high quality Schlumberger type of temperature log data. Most of this the state has, but a lot of it they don't because it's in water management district databases. We've compiled all of that for the study I just completed.
Was that a study? What kind of study was that?
I'm doing a framework, hydrogeological framework. In that process, we compile all that information as well.
So do you work with the Florida Geological Center?
We work with them pretty closely, but those logs aren't necessarily sent to the survey. They're done as projects through the water management district. So we worked, basically traveled around and collected logs for over many, many months. There's a lot of very high quality data that relates to the boulder zone and the low temperature wedge of water that comes in through southern Florida. I know there's some interest in that. And then also the older, there's several key test wells in the Sunnyland and through that one oil field down there that one of the older hydrologists had temperature data collected on it. So there's like several key wells that he used for those publications. We have all that.
We have a question online.
So in reference to temperature data, with your most recent publication, one issue that we've had with some of the temperature logs is that the units are in cycles per second, and the bottom hole temperature or maximum temperature isn't recorded in Fahrenheit or Celsius. And we didn't know how to convert that, so it's been a little bit of an issue to get it into a format acceptable for the NGDS. And I was wondering if you
cycles per second.
Count per second. So what happened in this happened on the Southeastern logger. If he wasn't confident in his calibration, he basically, everything was recorded in the CPS. But if he got a calibration on that particular day, he would put it in there and he would actually put the numbers that you would actually be able to see. If he didn't put that on the log, there's no way to actually know what temperature that is. You just have a basic profile.
I see.
So you could use a nearby well and normalize the data and back it out from that, but you have to do some interpretive stuff. But that's the same thing with the density tool and our neutron tool. He would follow. Sometimes it was very hard to calibrate the instrument, so he would follow a commercial logger like Schlumberger. He would run his density log, or they would run theirs, we would run ours, and then he would back out the calibration from that. So, not if it's reported in CPS and he doesn't have the numbers actually put on there, there's no way he can. In fact, I even pulled his old files out and got all of his calibration records, and it's almost impossible to link up his paperwork with the actual well.
So why is it difficult to calibrate temperature?
I don't know why.
It's simplest.
Probably, he basically lived out of his truck, and maybe some days he just forgot or he didn't do it. See, for hydrology, for the work that we were doing, all we needed to know was where the inflections were, because water will move up and out or down and out. So we just need to know where those inflections are to know where the water producing intervals are. And I guess it's all relative.
Are you talking about Jerry Island?
Yeah, Jerry.
Well, Jerry would work 24 hours a day.
He just
He
went back
came
to
to
the truck.
Virginia, and he'd get here at 5 o'clock in the afternoon, he'd say, where's the first hole? And then at midnight, you're sitting out there with him, he's got all the patch cord putting in. But when he got here, he was working. That's the way Jerry worked.
So that's pretty much how it had it. Now, post mid-90s, when he retired, we bought portable loggers. Those are all calibrated.
What kind of log?
Just a portable logger. We have a Century and that's it. We retired his truck after we retired.
So this is also common, it seems, in the mind of the scientist who's out in the field doing what they're doing. They have an idea, they have a reason for what they're doing, what they're measuring, and they're not necessarily thinking about how what they're doing could be relevant to other things in the future. And so you come back 20 years later and look at their data and see all the things that are missing. And so I really think this is a good lesson for scientists in general nowadays, now that we're becoming more global and using databases and collaborating. When you're out in the field and you're taking measurements, maybe consider what other bits and pieces would be necessary information for other people to know in order to use your data and apply it to other whatnots. So just like Scott was saying before, yes.
In terms of you're compiling a lot of data here, and I guess some of these LAS files and stuff are then going into so those end up in Kentucky, but the other stuff you're compiling, like in Florida and those other places, is there any sort of?
Well, y'all didn't ask for it.
I was just wondering, what do you guys do with it?
Oh, well, we do have an internal data system, and I have published quite a bit of it online, so we do have an online report. But other than that, it pretty much is held internally, and we just use it for the project at hand, and after that, it just gets retired. This is all data that's, you can get it, but we put a lot of effort into actually getting it from everybody, so it might be worth it to spend a little bit of time to maybe go back through what y'all have already gotten from FGS and make sure those particular key wells are at least had.
Sure, so more and more issues. So definitely databases, data sets, like from the USGS, who have potentially projects that are covering multiple states or regions. Knowing from a state perspective if those data sets are being submitted to to the NGDS directly from USGS, or need to be submitted to the NGDS through us? I mean, that's
But I think Andy Smith is the guy that y'all are probably working with in Florida, and I could very easily just give him the data, and then it all came to me from other state agencies. Maybe that would be the way to go.
Probably put you in touch with Rodney to him.
Yeah, Rodney. Yeah.
Because Andy I know has been out.
Oh, yeah. Okay. So, I mean, I can get him the data.
That'd be great.
Like that way, they won't have to dig back up.
And then,
I have an online question.
Yes.
So sorry. This is specifically related to the North Carolina, South Carolina data, and the question is, how might this data contribute to development of detailed regional, would be the smallest practical scale, or site-specific is best, thermal gradient maps for identifying heat pump and direct use opportunities? The depth to locate heat for geothermal power production in these regions is cost prohibitive. So yeah, so the question is essentially how do we produce maps, thermal gradient maps for identifying heat pump and direct use opportunities based on the data that's been collected?
well,
Anyone want to take this one?
so I used Virginia as a guinea pig, and we, not wanting to step on anyone's toes, didn't attempt this with any other states, but tomorrow I'll give a talk about the derivative products maps that we've been producing and are producing currently. And hopefully one will be a heat flow map for Virginia, or at least for southwestern Virginia. So definitely, I think it would be great if each state could pick up where we've left off and use the data that we've compiled to produce derivative maps, temperature, depth, calculating thermal conductivities, isolating gradients from different wells, and potentially making heat flow maps. So in some cases, those sorts of map products exist already, and in some cases they don't. But I think those are great tools in addition to the NGDS for each one of our umbrella states. So maybe that's something that you guys could do in the future.
So not to steal your thunder for tomorrow, but how difficult was that process? Based on your
I will only say it depends on the quality of the data you start with. And, you know, the inaccuracies, the uncertainties propagate all the way through the process. And, I mean, I think it's, for me, I mean, geothermal isn't my background. And once I could scramble through the process of figuring out how to do the steps and use the help of Dr. Costain and Southern Methodist University to put together some sort of methodology that would work for the types of data we have, then it's a pretty straightforward process. It just takes time. But the quality of the end result depends on the quality of the data that it came from at the beginning. And that's where it gets a little rocky depending upon how old your data is, how many temperature logs you have. If you can trust the header on top of the logs, that gives you a bottom hole temperature measurement, et cetera, et cetera.
So you mentioned the SMU group. That brings up sort of a question that I'm always, you know, they have those temperature with depth maps and heat flow maps that they recently produced. So is there much overlap between the data they use for those and what you've been able to dig up? Or?
Yeah, so the SMU, okay, if I can get this right, I believe there were a couple nationwide maps that were produced. The last one I think was in 2010, 2004, 2010. And then there was the Google West Virginia map, is that 2011?
Yeah, it's more.
Earlier maps had very, very few data points for Virginia, at least. Very few data points in the East in general. But as years progressed, they were able to accumulate data. In the most recent map they've used, they did tap into our Virginia DGO database and extract temperature logs. So there is overlap. definitely between what they did and what we have done. But we did use a slightly different methodology for various reasons, and so it's a little bit different of a data set.
But there's no overlap between what you're doing with the heat flow map and anything that SMU has.
Some of the well points may be the same, and I do have the raw data from SMU that we could refer to. The problem is they only used a bottom hole temperature measurement and the mean annual air temperature for their gradients, and we're doing something a little different. We're relying only on data that we have. In other words, we're using complete temperature logs from wells, and the reason I'm doing that is because I need to do that in order to understand whether or not we're doing it right. And
yeah.
so,
I mean, you're actually determining heat flow, whereas SMU in there.
that's something we did not do. We only use depths based on the temperatures that we have from logs. So we were constrained by the data we actually had in hand rather than relying on complex mathematical models.
So you're not extrapolating deeper.
Right. Yeah. And so I think in that instance, it's a pretty straightforward process. And hey, if I can do it, anybody can.
All right, any other questions? We're scheduled to take a break at 2:30, so why don't we just go ahead and do that right now?
All right, my segment here is geothermal resources development and state regulatory framework for Delaware. And just a bit of news on myself. I'm the new director of the Delaware Geological Survey. I took over just a little over a year ago, so a lot of the work and negotiations of Delaware's role in all of this was done prior to my coming to Delaware. Here's a picture on a survey here at the University of Delaware campus. Today's topic is just an overview of the geologic setting for folks who may not be aware, such as our zoning here. Some data pertinent to geothermal, a little bit on the regulatory framework, and I guess time for questions. This is a view from one of the map services we have called Digger, the Delaware survey. It's pretty new, and just you can put layers, of course, of geologic maps, and using it here to show you the northern part of Delaware is Piedmont rocks, crystalline metamorphic inconvenience rocks. Roughly about 6% of our area is underlain directly by the Piedmont, and the majority is underlain by coastal plain sediments. There's a picture of that now. The Piedmont rocks are somewhat grayed out on top. This looks a little better. And most of these layers here consist of typical coastal plain sediments, clays, silts, sands, some coarser sands, mainly Pliocene to Pleistocene in age. And currently, a lot of our geologic mapping work is taking place here in the southern part of Delaware. A couple slides here going into that. Here's a cross-section kind of going from the C&D Canal, which is just south of the Piedmont area. Going south, you can see our rocks of the coastal plain sediments dipping off to the southeast. We get to about 6,000 feet depth down the basement. We do not have a lot of good information of what's going on down here. Delaware, being a small state, also is not blessed with oil and gas, mineral resources, coal, anything that we typically have done deep drilling for exploration and other things. So there's a paucity of deep data in the state. But some information, I guess, that would be valuable for geothermal energy. And when I think of geothermal in Delaware, I think the real options here, of course, being small and knowing what the gradients are. Looking at the geo-exchange of geothermal, the low temperature heating and cooling units and what the opportunities there are. Of course, that depends on the ground temperature in the shallow wells. That's really controlled by air temperature precipitation. Here's our annual average precipitation. You can see we have plenty of rain there. It's about between 40 and 50 inches a year, and becoming the lowest average elevation state in the country, more than Florida and Louisiana. Groundwater table is pretty shallow in some places, just a few feet below ground level. A lot of the geothermal systems use groundwater as the heat transfer fluid. Once again, water use in Delaware, you can see groundwater plays a very important part. We're actually, for a small state, we're an agricultural state. A lot of the southern, mid-southern part is farmland, or as well as chicken farms. We'll talk a little more about that as well. Some average annual temperatures. This is from a geothermal report that was done by Woodruff in 1989. We collected the monthly average air temperatures, Fahrenheit and Wilmington. I averaged them up and came up with 54.7. And here's some data from our state climatologist office, which DGS works very closely with. We have a lot of emergency management websites that have both the stream gauge, which DGS manages, tidal gauges, as well as grain gauges and things. Together, we put these sites together that help emergency managers, both on the local as well as the state level. But here you can see some of the average temperatures from our stations here. And this is pretty much right on in the mid-50s. There's roughly about a degree increase from north to south of the small state of Delaware. The subsurface data collected by DGS, we put it into our databases, and here definitely a place that's doing a really good job. Scott Andrus, Sandy was here, but did yeoman's work on getting our database setups working. So we have a lot of data in digital form, and it's updated every few months. And, oops, that's a typo right there. It should be 6/21/13, not 3/21. June it is. But anyway, here's what we currently have for well records. Roughly 148,000. 32,000 of those have DGS identified codes, which means we know where they are as far as having a georeferencing identity with them, which of course is important if you want to use that data for subsurface evaluation in water wells. For a large part around the country are really the best windows into the subsurface right now. A little over 6,000 outcrop records, 46,000 rock samples, 67,000 water samples, 4,500 wells with water levels, which is quite a bit. A lot of those are our monitoring well network. We're currently expanding now with bonds issued money from the state of Delaware. These are all issued with real-time data loggers. And roughly over 3,000 geophysical logs representing a little bit over $1 million linear feet. So we have quite a bit of data, not all of it, of course, in the set that Virginia collected based on the merits and usefulness for geothermal, but certainly I think there's more that we can put in there. As I said, if you're really looking at geothermal energy optimization for a state like Delaware, it's probably in the shallow ground source heat pump avenue, and there's a lot of different types of data that can value that. And I know we're going to talk a little bit about sustainability tomorrow. But on this note, I'll mention, prior to coming to Delaware, I served as the Director of Science and Technology for the National Groundwater Association. And one of our sessions of the state geologists in the meeting, we invited a couple of drillers when we were in Iowa who were really big in geothermal. Working in national groundwater, I can tell you that the association that represents well drillers, they were taking it on the chin in the economy tank because why do you drill a well? To supply water for a house. Why do you build houses? Well, people need it. When the economy crashed, housing starts crashing as well. So what really saved a lot of these drillers were geothermal well installation, because we're still money and grants and support. We're putting those in a lot of, more of the civic infrastructure, hospitals, schools, military bases, etc. So the NGWA is taking a big role in kind of stepping up their support information for their association members. And so we invite these drillers to say, what kind of data do you need? What do you need to know? Because I was trying to get a junction of them with state surveys, realizing what kind of data we're putting together. And it was very valuable because a lot of them were saying that when they contract, if the pumps, or if the thing does not measure up to the efficiency, everybody starts pointing downhill, and usually start with the driller, and they say, drill a well, you didn't understand the geology well, and so they're looking for information about subsurface conditions, heat capacities, different types of rocks, the groundwater temperatures, all this kind of stuff. Some of the more stupid ones, not everybody. Some guys are just simply plunking holes in the ground and moving on. But some of the better firms are kind of taking the next step and looking a little bit more at some of the geological engineering constraints on putting in a good system. Other subsurface ceramic, the deepest hole in Delaware is a little over 3,000 feet. It was an oil and gas test well drilled in the 30s. Once again, compared to North Carolina, was 10,000 feet of much less depth and control than our state. In our database, we have about 3,000 wells that are identified as geothermal in the water use field. And that's out of about 148,000 records, so about 2%. We'll talk a little bit about that too. Many state surveys participated in the National Geological Geophysical Data Preservation Program, including BGS, and putting a grant in the work successful this year. But that allows us to take money and take some of our archive data, be that geophysical logs, some of the cores, preserve all that data, which once again plugged into our geothermal database. This may be all valuable information for evaluating subsurface conditions in the future. One of the things we want to do is take that, I guess, tier 1 data we have now, these well records that are in paper form, that have a lot of ancillary data that we don't often find in the digital databases that are sometimes just kind of select fields that are major, but we will be able to tie those to each one of those records eventually. So it's going to take probably several years. We need the funding, we need to do the whole entire data set, but eventually we should have that. So I mentioned we're also mapping superficial maps right now. We're concentrating kind of in the southern part of Delaware, where our beaches are. That's the income generator. And you can see some of the quads outlined were recent projects either going on or coming to completion. We also map a little bit offshore based on data we have here for sand replenishment studies, and which helps to understand the deposition models both onshore and offshore. Data entered into the ASG National Geothermal Data System, compliments of Virginia, and I think we all heard briefly about this from Wendy earlier. Well header data, borehole temperatures, soil log observation data, EGS geological publications to include some of our maps. There was one study that was done specifically for geothermal, and this looks at shallow subsurface temperatures at selected locations in Delaware. This was done in 1989, and there was a lot of talk at the time because we are basically sandy unconsolidated sediments in a good part of our state. The geothermal industries were looking at more of the not drilled wells but buried lines, the shallower trench type. And so here we're really looking at temperature profiles just a few tens of feet in the ground versus the changes in temperature with the weather and everything. You can see the deeper they are, they tend to be more muted from the changes, much just the same as we expect groundwater levels to mimic the high precipitation months and low precipitation months. So no big surprises there. Some other information that's of value here. This I pulled from National Groundwater, but it originates from the EIA. But it's a geothermal heat pump shipments by destination, and it's kind of a proxy way to see which states are really big into this geothermal heat pump type of application. You can see some states. It's interesting, a lot of them are in the Midwest. If you look at Iowa and Indiana, 18,000 units were sold or moved to that state, so you can assume that most of those were installed there or whatever. Delaware, were roughly 2,000. But what's interesting that it kind of popped out at me, and this is just for 2 years of data, 8 and 9, these are actually somewhat slow years. If you remember the well data I showed you a little bit before, that of wells that were tagged as being geothermal in the state's reporting database, there's only about 3,000. That seems pretty low when you consider if you assume each one of these goes in and is using a well, even if 1,000 of them were, that since that time there would be many more of those. So I guess when we talk tomorrow about some of the things that we can look for improving data collection, if we're going to monitor the growth of geothermal energy based on what we're producing in this geothermal database, we need some metrics to do that. And right now, the well database that are kind of tagged for geothermal versus the hardware that's being installed there, they aren't matching up very well. So I don't know how we rectify that, to be able to really get a good monitor. Like I said, there are some groups, some industry trade groups, I think, that might be trying to get a better handle on that. Delaware does have regulations governing the construction, use of water wells. There's a water well board that reviews licensure of licensed well drillers. And well permitting is conducted by DEMREC, which is the Delaware Natural Resources and Environmental Control Division in the state. So they do have these well construction guidelines that talk about casing depth and proper screen setting, construction of the wells, etc. They do have some guidance for geothermal wells, although just from my experience looking at others as well as from my work in national groundwater, they are not very robust, I would say. There's certainly too much more that could be done. Another interesting website is the Geothermal Heat Pump National Certification Standard website. You can go there and find each state, and actually the data to populate this was done on a contract for national groundwater, but it'll give you information about every state. You can pull up Virginia, whatever, and it'll tell you if they have a board of licensed geologists or engineers, regional water, all this kind of information that's somewhat related to the geothermal industry. So it's kind of a good place to go and get some information quickly if you want to know what other states are doing in this arena. Still, we don't have regulatory responsibilities at the Delaware Geological Survey, but our Organic Act does state specifically that the state geologist in the survey shall evaluate all activity in oil and gas, and specifically mentions geothermal energy. So that is part of our domain in Delaware. And also, under the regulatory side, DEMREC, the group I mentioned, does have these grant programs for promoting green energy. Delaware is very green in that regard. The university has its own large wind turbine out at the Lewis Oceanographic Center. But anyway, you can see the word geothermal there, specifically, and they will give grants to enhance or support the installation of geothermal heating and cooling systems in Delaware. Just under the opportunities, this is an interesting statistic. Delaware's poultry farms provide 70% of the state's 2001 cash farm income. So we are a big chicken place. And you find a lot of these large chicken farms all over kind of Delaware, but Maryland included. As you know, it's very hot out in the summer in this part of the country, and these chickens are happy and produce better and don't die off if they're not too cold in the winter and not too hot in the summer. And some of the ways they cool them are having large ventilation fans that blow air through there, but they also use something called fogging or misting, where they spray water to keep the birds cool, which is efficient and seems to work. You know, when you have groundwater there are some issues in some areas of extended pumping has led to some decline. But nonetheless, some of the unforeseen consequences when you're adding this moisture to all these chickens and their dew, you're creating wastewater products. We do have nitrogen problems in shallow groundwater. So it might be interesting to see if ground source heat pumps can be used to cool these, because at least it would minimize that waste problem, water problem. Chickens also can get fungus from all that moisture and other diseases. So need some opportunities to work with ag people and see if we can instrument some of these and see if that might be an opportunity to expand the use of geothermal energy in these areas and have these large kind of lots. Houses. You don't have to cool these down to, temperatures comfortable for humans. They actually don't need it that cool. They just want to keep it enough so that they die off and it gets to like 90 degrees or whatever. And I end up with my typical sales slide here and what we do. The same thing we've heard from other surveys. So committees provide data, publications, coordinate with federal partners, and consultation. And with that, I just want to answer your questions. No? Anybody awake?
Does anyone online want to ask a question?
Hey, where's that rock? That's a nice picture.
That's not showing here. No, just standing to down.
That's a good reservoir. The water was down 15 feet.
That's right, that was a big
Rock is nice and clean.
beautiful.
We usually get to see those rocks.
Prismatic fold.
I have a question.
Yes.
Matt is listening.
one of your earlier slides, you were talking about the number of wells that existed and data records that you had in total. And you said that quite a large number of them, like 2% total, were labeled as geothermal. Are these water
wells that were drilled probably for open loop source type, using groundwater to cool for their geothermal heat pumps?
So that was the initial purpose, and then they were switched to water?
I don't know, and I actually have a call into the person because I know in New Hampshire we had where you could check off, and sometimes you might just simply convert your water well or split the water to be a supply, but then you can file a rectification. But see, that's part of the problem. I think that people are supposedly required to do that, but there's no teeth in it if you don't. So that's probably why those numbers are so low, that there's really no incentive for you to have to change the purpose or intent of your well. But once again, it still leads us to not being able to really see what the health of the market is or growth.
Do you necessarily have any supporting data other than just the title geothermal within those well documents that would help say in truth that yes, this was drilled originally for the intent of being a geothermal?
I don't know. I'm attending my first water well board meeting next Tuesday, as a matter of fact, for the staff person that's been on that board representing EGS is off on sabbatical, so I'll be going. Like I said, I just got there, and a lot of the changes I mentioned earlier when I was in New Hampshire, by the end, we had all that stuff listed on our well report forms. We had a lot of changes. They had to report temperatures, blah, blah. It took me only about 8 years to get all that done through the board and rules changes.
Jim Lovett from Virginia, from our Division of Gas and Oil.
Well, on behalf of the Division of Gas and Oil and the regulatory agency responsible for the Virginia Geothermal Resources Conservation Act, it's a pleasure to be here. When I talked to Billy about doing this presentation this year, when he invited me a couple of weeks ago, the way that this section is set up as far as geothermal resources development and the state regulatory framework, when we talked, we realized that the geothermal resources actually had to do more with the hosting agency of the Division of Mineral Resources here that Wendy's going to be taking care of and things like that tomorrow. So I'm not going to go into much detail of that. What I was going to end up doing is actually addressing the Virginia Geothermal Regulatory Framework, which, in listening to the other presentations from the other states, I'm kind of surprised that actually the Virginia system that's in place is actually very robust and very detailed. And so for those other states that are maybe looking at developing some regulations, some laws, that they may want to look at these things as far as some potential templates to use or don't use, and particularly for the groups that are collecting information, that we will go through this and look to ensure that the information sets that are being collected will assist in addressing some regulatory requirements of things. Let me further introduce myself a little bit. By title, I'm a mineral specialist and inspector with the Division of Gas and Oil, but probably more importantly to this group, I'm also a geologist, a certified professional geologist in Virginia, done economic geology and mineral resource exploration, geologic mapping for about 35 years. I worked with the Division of Resources for 25 years, and about 5 years ago I was laterally transferred over to the Division of Gas and Oil. So the reason that I say that is I'm one of you guys. I know most of everybody out in this audience are geologists. That's what I'm particularly and personally interested in my heart. I'm interested in the geothermal gradients of Virginia, the shallow intrusives, the structurally controlled warm springs of western anticlines. And so as we end up going through the regulatory framework of Virginia, I will do my best to kind of put a geologic bend on things to be able to keep everybody kind of connected in. To understand the regulatory framework in Virginia, it probably will end up making some sense if you end up looking at how the structure of our organization is set up. Like I said, I work with the Division of Gas and Oil. The Division of Gas and Oil was one of 7 divisions underneath of the Department of Mines and Energy. The four on the left, the Division of Gas and Oil Mining, Division of Mines and Mineral Reclamation, are all enforcement groups. The ones on the right, there are Division of Administration, Energy, and Geology and Mineral Resources, which is the hosting group up here, or more information services and support agencies, which are my part. So going up section, we are all under the umbrella under the Department of Mines, Minerals, and Energy. And I believe the Department of Mines, Minerals, and Energy is one of 13 major agencies underneath the Secretary of Commerce and Trade. That secretariat is one of, I think, 12 secretariats underneath the governor. Now, why I brought this slide up a little bit, when we talk about the regulatory framework of Virginia and laws and regulations, for the most part, the laws are kind of made up here on top as far as the governor, the secretariat, and the elected officials in Virginia. The laws that are directed on the department level, as far as the Department of Mines, Minerals, and Energy. The department then is empowered to be able to do the regulations, to enforce the laws and do the regulations, which then trickles down to the divisions and the different divisions underneath of that. And so for the most part, the law's going to go here. The laws and regulations then are created and come down to the division, to the different divisions as far as ourselves at Division of Gas and Oil. If you do a search on the legislative system in Virginia, as far as geothermal resources, the first thing that ends up popping up is the Virginia Geothermal Resources Conservation Act of 1981. I put the 1981 date in here, and I'll explain this a little bit. I mean, that's the real data, but that's not its official title, but I wanted to make record of that. This appears within the Code of Virginia. It's Title 45.1 under Mines and Mining, Chapter 15.1 of Geothermal Energy. It's not a law. There's only 11 different sections in it. It's kind of a classic format as far as the title, purpose, includes duties and responsibilities of the department, some of the other legal things down at the bottom as far as penalties, judicial review, and things like that. And we're not going to go through all of these, but for our purpose of discussion today, there are four of these that I have ended up picking out, and I will pick out some very selective components of this to be able to address this group, to be able to end up kind of tying some of these laws into Virginia. Talk about, first of all, its title and purpose. Under the law, the chapter is cited. Its official name is the Virginia Geothermal Resources Conservation Act. I don't know if other different states end up having a formal act like this. It's intended, or what the purpose is to foster the development, production, utilization of the geothermal resources, prevent waste, protect correlative rights, protect the state waters and potable waters from pollution, safeguard the natural environment, promote geothermal and water resource conservation, and safeguard the health, safety, welfare of the citizens of Virginia. Now, I don't know if you are at all familiar with gas and oil law of Virginia, but actually it's very, very similar to this. And one of the reasons that probably our laws are a little bit more advanced, maybe more robust, for the record, Virginia has about 10,000 gas wells that have been drilled in Virginia. There's 8,000 of these that are producing right now. This kind of comes under the same umbrella, and the terminology is very, very similar. Particularly, the charge is to be able to prevent waste, protect correlative rights, and safeguard the health, safety, and welfare of the citizens of Virginia. Now, the application, which is section number 3 within the law of Virginia, this is actually a very important thing that we have to be very, very careful as far as the terminology that's being used. The provisions of this chapter, referring back to the law, regarding the permitting regulations and reservoir management applied to geothermal resources at temperatures above a minimum set by the department. And leasing royalties and severance taxes applied to geothermal resources producing more than the volumetric rate set forth by the department. So within the law of Virginia, there are very specific temperature and volume requirements to address or to apply these laws to.
Who is the department?
Okay, we'll get to that. Okay, okay, wait, because that's a very important segue as far as the empowerment of the law as far as trickling down.
Okay, well, here we go. This is your question. Section 6 of the law, the duties and responsibilities of the department is the department is hereby given jurisdiction and authority necessary to enforce the provisions of this chapter, which is the law, which is the Department of Mines, Minerals, and Energy, which is this kind of segue and tie into the regulations, and shall have the power and authority to enforce the rules, regulations, and orders, which then promulgates down to the Division of Gas and Oil. Okay, so it's a very good question. But within the law, within the Act, it specifically identifies who the department is and where this is going to the proper division. Additional duties of the department shall, by decree, we shall consult with the State Water Control Board. This is old terminology, referring back to the Department of Environmental Quality. And shout out to you guys that are here from DEQ, and with the State Department of Health as necessary to protect the potable waters of Virginia. What's key about this is that the Department of Mines, Minerals, and Energy and the Division of Gas and Oil has primacy over the regulations and enforcement, but we do not ever work in a vacuum. And by requirement, we are required to end up working in partnership with the Water Control Board, DEQ, and the Department of Health as necessary. This is very similar also to the gas and oil regulations that we partnering with both of these groups when necessary. Something that was in our law that maybe people are not aware of, but I think is very, very important, is section number 8, the reinjection policy. The department, the State Water Control Board, and the Department of Health shall jointly develop, revise as necessary a policy on reinjection of spent geothermal fluids, and the policy shall refer to the reinjection into the ground of waters extracted from the earth in the process of geothermal development, production, and utilization. What's key about this is, by law, we have the opportunity to reinject fluids back into the ground. That is actually the preferred method. And I know some places actually this is outlawed or this is regulated, but within the Virginia law, doing geothermal development, it has the right and opportunity to go ahead and reinject the fluids back in. This is all going to get tied back together into something just in a few minutes. Now let's jump to the regulations. The regulations of Virginia, which is the administrative code, which is now kind of coming down to the division level. This is found under Title 4 of Conservation and Natural Resources, Agency 25, directed toward the Department of Mines, Minerals, and Energy. Chapter 170 of Geothermal Energy Regulations, for any of you people who want to really look these things up and confirm them. There's only 9 sections within this part of the regulations because it's fairly short. You type it out, I think it's only about 7 or 8 pages long. It's really not that detailed. Has all the classic kind of things that you would expect in the law as far as the definitions, resource conservation, environmental components such as well construction and maintenance, records that need to be turned in, groundwater monitoring, and all. Again, we're not going to end up having time to end up addressing all of these, but I'm going to pull out small components of 2, 4, 5 of the sections that is pertinent to the geothermal resources that we're talking about here today. First of all, a geothermal resource means a natural heat source from the earth at temperatures above 70 degrees Fahrenheit or at temperatures of 70 degrees Fahrenheit or above, with volumetric rates of 100 gallons per minute or greater, and the energy that may be extracted from that natural heat. Now, if you remember in the law, it says that it would end up having both a temperature and a volume requirement, and it was promulgated down as far as the regulation for the department. Hang on just a second for the department to go ahead and identify what those are. And so within the regulations, it specifically addresses these 2 components. Yes, sir?
Is there a requirement for me if I wanted to put a geothermal installation in my house or the school? Do I need to report that to somebody?
Okay, that's part 2 of this. Hang on with me, that's where we're going to go. Okay, so let's go ahead and address these things, and then myself as a taxpayer of the Commonwealth of Virginia and also as a scientist, I had that same question, and we try to end up being a one-stop shop. So hang with me on that, but that's where we're going to go. Okay. Let's see, Section 20 of our regulations refers to the resource conservation. And this is to foster the geothermal utilization, prevent waste, protect relative rights, safeguard the environment, and promote geothermal resources conservation and management. These are virtually the same things that are addressed in the law. Again, if you're familiar at all with the Virginia gas and oil regulations, they're very, very similar as far as setting things up, particularly preventing waste, or protecting relative rights, safeguarding the environment. The department may designate geothermal areas, which refers to either pools, field rules, and things like this that is done within the gas and oil industry very commonly. It may require well spacing, it may require utilization, and may allow sequential utilization on a case-by-case basis. This is purposefully written very flexible because it has to do with current technologies, it has to do with BMPs, it has to do with how the resource is being utilized right now. And so when these were all written back in 1981, they weren't sure exactly what those things were, but it empowers the department to go ahead and create tools, particularly as far as the well spacing and utilization. And as a heads up for the geology people, this is where the geologists would come in as far as providing expert testimony to the board as far as what appropriate field or pools that might be, exactly what appropriate well spacing that may be, as far as exactly what utilization that might be to be able to protect relative rights. And then those that expert testimony then goes on transcript record, and those are where the decisions are being made. And so this right now is specifically written kind of flexible. I mean, these are things we just did with the horizontal well development and some horizontal well rules within the gas and oil industry as far as looking at spacing, looking at utilization. But you can't do those ahead of time until it comes up, and then based upon the technology that's available right now and its application. Section 40 of the regulations talk about the notification of intent to proceed. Really what this is old language referring to the application process, the application permit that would end up coming to Virginia. Notification and intent to proceed, it must include operations plan, geothermal fluid analysis, and a proposal for the injection of spent fluids, or a proposal for an exception to the injection rule. I know this is a real busy slide, but just to kind of give you a heads up of some of the geologic components that are going to be required within a permitting process. Notification and intent to proceed, which is the application. First of all, the operations plan are very, very detailed in Virginia. These are long established and have worked very well. It includes things, I'm just going to read it from left to right, kind of going along on the top, as far as a certified plat, proposed well location, surface elevation of all the wells, well identification number, tract identification, map of the site and the access roads, the sediment erosion control plan, suspension thermal fluid disposal plan, geothermal fluid monitoring plan, the groundwater monitoring plan, subsidence monitoring, plugging and abandonment plan. And there would be a geological report, hopefully. I mean, this would be done by the geologists, by people like us in this room, using information that hopefully will be supported by the geologic database that y'all are creating. And the things that would be required on that is the depth of the proposed reservoir, type of the reservoir, anticipated thickness, anticipated temperature of the geothermal resource, anticipated porosity, permeability, pressures, geologic structures, and the description of the overlying formations and aquifers. Now these are all required within our permitting process. There are a number of other environmental safeguards put into place as far as the well construction and maintenance. These specifically refer just to the geothermal wells, that all geothermal wells that are constructed shall be designed to ensure efficient production, eliminate waste of the resource, and protect all freshwater bearing aquifers from contamination. And this is done by having appropriate water protection casing, which also is called the surface casing, shall be set at least 50 below the deepest known groundwater aquifer and cemented with the surface. It's either by default, generally we either go 300 feet or 50 feet below the lowest producing well within like 1,000 feet of where that's going to be. And all production must be through API approved production casing that is also set, the production is set in production zone, and that is also cemented up to the surface. I mean, some of these kind of slides, the environmental slides, we could probably spend an entire half an hour, hour period on that, just going through these things. But just to let you all know, as far as some of the regulatory requirements that are actually in place in Virginia. Now, the geothermal injection wells shall also be designed with a casing program that fully protects the freshwater strata. This is done by the injection well should be done through only API-approved production casing that is cemented through the entire freshwater zone and sealed and cemented with a monitoring system between the injection string at the bottom and the water protection string up at the top. This is also controlled with the rate of injection shall not end up exceeding the rate of production rate, and the injection pressure shall be regulated to minimize any fracturing of the confining strata. And these are all out of the set of regulations that are there. Now, groundwater monitoring shall be monitoring through either monitoring wells or existing water wells. Would include both water quality at the enzymatic head with a minimum of 1 monitoring well per production or injection well. And the analysis of both the groundwater and the geothermal fluids shall include a very detailed geochemical analysis. Includes the mineral content of 19 different elements or compounds. I mean, this is like the chlorides, fluoride, sodium, potassium, alkalinity, those kind of things, metal content, arsenic, cadmium, nickel, copper, just kind of naming the ones off the top of my head that I can remember. Some general parameters as far as pH or conductivity, and just for the geothermal fluid wells only would be the gas content as far as sulfur dioxide or carbon dioxide in there, because these end up having potential to be corrosive. Energy in the Division of Gas and Oil, which is ourselves, applies to number 1, high temperature of 70 degrees or greater, high volume of 100 gallons per minute or greater, and production and injection of open loop flow systems. And you have to be very, very careful in the terminology from the regulatory and legal standpoint here. Functionally, what this is talking about, then, these are large-scale power generation, industrial, commercial applications. And one of the things that I pointed out earlier is that this law was written actually in 1981. You remember back in 1981, state of the art was looking at potential power generation and the large-scale applications. This is when this law went into effect. There has never been a geothermal well permitted in Virginia. There's never been one used. I mean, I had to kind of laugh. I've done geology presentations for probably 35 years. This is the first one I had never had a map, never had a diagram, never had picture or anything like that. It's just all words, because I can't go out and say, you know, this is an example of a successful operation we put in. There is none. I can't show you, you know, what a completed application is, because no one's ever put one in. Also, as we go through this is a heads up. As we interpret laws and the other things that have been passed since 1981, this may include the EPA as far as underground injection control program for a Class 5 well permit, which is just a real simple thing. I think that they just turn these in, and it has more to do with just location and some statistical information as far as where they're at and who they're owned, and then the EPA would determine if there's anything else. But as we interpret this would fall under one of the classifications of Class 5 wells from one of the injection wells, and this may also include the Virginia Department of Environmental Quality if there would be any surface water discharge for permit for non-injection disposal. However, now to your question. As a citizen of Virginia, knowing what the technology is, knowing what this is, I finished up this part of it and said, boy, there's a lot that's missing. I mean, this is really not the application, this is not the direction, this is not the technology that's really being in place and being used right now. So I started digging a little bit further. Okay, I did a second legislative search on geothermal and got all sorts of hits from the Department of Health. Now, I do not pretend that I am a representative of the Department of Health or an expert within their regulations, but we at the Division of Gas and Oil try to end up being a one-stop shop. For example, our regulations in gas and oil require that you dispose of the production fluids. These are disposed in injection wells. They're required to dispose of those. However, injection wells are under permit from the EPA. You know, that's not one of our components. This is not something we get involved into, but it's our professional obligation to be able to inform people this is what's required. Equally, if you do a large stream or river crossing within the gas and oil regulations, this then goes to the department or through the Corps of Army or the Corps of Engineers. You know, we're under professional obligation to be able to inform them as far as the right agency. So I did a secondary search on geothermal, came up with all these different hits through the Department of Health in the Code of Virginia. It's on Title 31 or 32.1 from Health, Chapter 6 in the Environmental Health Services. Let's see. We're not going to end up talking about all of these again, but there are some very kind of important things that I want to throw out here that hopefully will bring us full circle back, be able to close up some of these gaps and some of these loops, and particularly address some of the current technologies that are out there. As far as looking at the title definitions, it looks like I made an error here. It should have been before, but you know, I just saw that for the first time. The short title, this chapter shall be cited as the Virginia Private Well Construction Act of 1986. It's important that you recognize that that date postdates the 1981 law of the Geothermal Resources Conservation Act that we're responsible for, and had a significant revision in 2009. Within the definitions, a private well means any water well constructed that is usually intended for a household, groundwater source heat pump, agricultural use, industrial use, or other non-public water well. This is one of the first times that we have actually seen groundwater source heat pumps come up in any of the legislative terminology. Within section number 4, as far as powers and duties of the board, referring to the Board of Health and the Department of Health, the Board of Health shall provide for an issuance of an express geothermal permit. Again, first time I've ever seen this set of terminology. Allowing for the construction of wells used solely for a closed-loop geothermal heating system that shall include construction to be performed by a valid contractor with a water well classification, the statement that certifies that the location and construction of the geothermal heating system will comply with the private well regulations, statement that showing that the site plan, including the location of the geothermal heating system and any potential source of contamination, and a single application fee will be required for any geothermal well system. Even within the Geothermal Conservation Resources Act, you don't see any of this terminology at all. You know, the terminology that is in our part of the law really is age dated in 1981. These are actually this is some of the terminology that was added in 2009. Within the Administrative Code of Virginia, which is the regulations directed towards the Department of Health. This is now under Title 12, Agency number 5 of the Department of Health, under Chapter 1630. This is a huge set of regulations. There's over 50 sections, I think right at 50 sections on here. We're not going to end up kind of going through a bunch of those. I'm just going to highlight, like I've done before, these three as far as the definitions and express geothermal well permit, a little bit about the construction. Definition, closed loop ground source heat pump well. This is word for word out of the regulations. Means a well consisting of a sealed loop of plastic pipe buried beneath the earth's surface to allow the heat transfer between the fluid in the pipe and the earth. Section 271, an express geothermal well permit applies to wells used solely for closed-loop geothermal heating systems. In Section 410, construction in general, a closed-loop ground source heat pump well. Let's see, closed-loop ground source heat pump wells do not have to be cased, and so there's some special considerations, special regulations in here. But again, these are the first time we're seeing heat pump wells, geothermal wells, anything like this specifically identified within the regulations. So let's kind of summarize the Virginia Private Well Conservation Act, which is under the authority of the Department of Health. This applies to, these are all the terms that I've actually pulled out of their laws and regulations that probably have much more to do with the current technology and the current state of the art as far as what's being used and what's being developed in Virginia. And these are the only places that you see the terms like geothermal heating system, geothermal well system, heat pump well, groundwater source heat pump, ground source heat pump. All of these are low temperature, lower temperature, lower volume, closed loop, which means sealed loop of plastic pipe systems. This equates to really small to moderate level or small to moderate scale applications from household to industrial and commercial, and even some fairly large ones. I mean, I've heard of people looking at putting these in as far as apartment complexes, cluster home complexes, some military bases and things like that. So these have potential to be fairly large. There's no size requirement in here. Yes, sir.
And they have to get a permit.
Through the Department of Health.
Okay, so
they get a water well. They get a water well permit.
Right.
They get an express geothermal well permit.
Okay, so
yes.
How do you get access to who's requested permits, which would tell us how many geothermal systems there are in Virginia?
Okay. Again, I'm not the authority and ownership of this data, but what I would recommend, I actually met with our local building inspector people on a county-by-county basis down in Southwest Virginia. They are the ones that actually kind of enforce this in partnership with the Department of Health. When somebody's building a house or whatever, that it's kind of a one-stop shop for them, that they end up kind of working with that developer, and then contact and go back and forth between the Department of Health. So what I would recommend is to kind of check with the Department of Health or on a county-by-county basis as far as where these records are. But as I interpret this, I mean, and I had the same questions you had a minute ago. I got all the way through the regulations, the Virginia Geothermal Conservation Resource Act, and it got to that point. It's like, well, this doesn't really address the direction of the technology and development that is actually kind of going, heading forward right now. And so where is that? There seemed like that there was a big hole, and that's why I kept digging in. So what I would recommend is checking either on a county-by-county basis with the building inspectors and or the Department of Health.
This is something that DEQ might have some insight into, but I'm pretty sure that these records are kept by the Department of Health at the county level, and there's no statewide database. Is that correct?
They're probably paper files in local health district. Right, Scott?
Mm-hmm. That's the impression I got from our local building inspectors down there, that it's kind of done site by site, location by location, but there is not a database. I mean, you can't really search this. They do a very good job monitoring and maintaining that one building construction site. When they're done, it goes in a folder, and they put it in a file, and they walk away. But there is not a master list that goes through. But there's hundreds out there, and from the kind of development that you guys have been talking about, as far as drilling down and trying to find, hot source, radiometric decay, radioactive decay, some things like that. That's probably the technologies that's going to end up being used to be able to develop those. So there's a lot more data out there if we can just kind of find the right people and mine this. And I would have been happy to have shared this with you guys long ago, but I didn't know this until about a week ago. Once I started digging in this in preparation for this talk, because it doesn't come up within the Division of Gas and Oil. I mean, we have, like I said, we have never had an application. We get some calls every once in a while, but we needed to take this one step further to be able to give a complete and professional answer. Yes, sir.
Jim, there's one other small place where geothermal will show up in the state statutes. In the Groundwater Management Act of 1992, there is a reference, something to the effect that for our groundwater withdrawal reporting, our groundwater withdrawal permitting in our groundwater management areas, there is terminology that covers geothermal wells and our regs and our law. When I say our, groundwater withdrawal permitting within the groundwater management
I think I've looked at that, and I think that ends up just giving primacy back to the Department of Mines, Minerals, and Energy.
No.
Okay, because there is a component. I saw language of that. I didn't bring the law with me. That was the one that I didn't bring. But
But basically what it says is if you return it to the source aquifer, you're exempt from the groundwater withdrawal regulation.
Okay, that's
Now,
it.
if you do not return it back,
Right.
and our term is pump and dump, in other words, pumping out one time, heat exchange, and goes somewhere else.
Okay.
Within our groundwater management area, you have to have a permit from DEQ to do that.
That's actually what I had mentioned earlier, because if they are required within the Virginia Geothermal Conservation Act to go ahead and do a re-injection. However, they can petition not to re-inject it and do something else with it. If they do that, then they go onto a surface disposal of it, then that would require contact to DEQ as far as a surface waters permit and things like that. So that was one of the two special cases down below that I pointed out a minute ago to be able to address those. But if it is just simply, return back to the aquifer that it ended up taking care of with two different wells, which was the state-of-the-art concept back in 1981, those are open flow systems, and that does not require a permit by you, but that's what's picked up then by the Department of Mines, Minerals, and Energy.
But if it's not re-injected, you have to get a permit from us.
Yes.
Okay.
Yes.
DEQ.
Yes. Correct. Yeah. But anyways, I mean, this scenario here is probably really reflects a lot more of the current technology and direction, current terminology, and that's we have to be very, very careful as we talk about these things. You know, a lot of people talk about geothermal heat pumps. What are they talking about? You dig a trench and you put something 5 feet down under the ground. Really, that is just simply a local code of Virginia, or uniform building code of Virginia, and it's called a geothermal heat pump, but it really doesn't have to do with a true geothermal resource within a regulatory and legal framework. So to kind of pull all this back together, if we have high temperature, high volume, open flow, ground source systems, large scale, this comes under the Virginia Geothermal Resources Conservation Act of 1981, administered by the Department of Mines, Minerals, and Energy. If it's low temperature, low volume, closed loop, ground source heat system, small to moderate scale, this would then come under, as we interpret the law, and again, I'm not speaking for them, under the Virginia Private Well Construction Act, administered by the Department of Health. And there may be instances where then DEQ is involved in this also. Okay, that's it. Yes. Questions, comments, complaints? Yes.
I imagined that the fluid inside the pipes was an antifreeze type fluid. And so I was surprised to see that these systems don't have to be encased or protected in some way.
The closed systems have an antifreeze type of thing. And by definition, the closed systems have a closed loop, you know. Yeah, it's plastic pipe. But, you know, some of the research that I ended up doing, and I found this pretty interesting, in 1981, the type of pipe that they're using right now with the resistance and the heat transfer capabilities was not really invented until 1986. And so when the law of 1981 went into place, they barely had the technology. I guess they've been playing around with some downward source heat pumps at some point in time, but really the technology was not proven out, and they did not end up having plastic capabilities that ended up being safe enough to be able to do that. And so those were actually developed a little bit later on, but you know, that's under the jurisdiction of the Department of Health, and I was surprised too that it didn't require any casing of their wells or, you know, anything like that. But I can't speak for them.
I would comment that in New Hampshire, we put forth regulations. We had to be grouting because there's a lot of geothermal grouts now that mix sand with high density materials. We need heat transfer because if you remember the polybutylene fiasco of piping that went on in homes that's supposed to last 50 years, someone breaking a major class action lawsuit.
Yeah.
But, you know, ethylene glycol, MTBE was a problem. That would be a picnic compared to that stuff leaking in. That's water soluble.
Yeah.
And if you really want to shoot the geothermal industry a foot, have your well leak into your neighbor's water well in the next house over the suburb.
Yeah. And just kind of when a well kicks on and off, I mean, there's that vibration in it. Our well went down a couple of years ago. We have a private water well. And it went down because it rubbed a hole in the side. It didn't have one of the spacers or it slipped out. And just over a 15-year period of every time that the well kicked on, it just kind of shook it just a little bit and rubbed up against the casing and ended up leaking. So that does happen, but that's within a different regulatory group's responsibility. Yes, David.
Jim, are there any oil or gas wells in Virginia where the producer is extracting heat from the produced fluids?
No, not that I'm aware of. I mean, those are totally different things. The produced fluids are under very strict guidelines and requirements. Those are closed systems. A lot of the produced fluids are very different than the drilling fluids, remember, that those are concentrated brines coming out of formational fluids. That by, they can, but they are hot enough and they are required to be disposed of in an appropriate environmentally sound way, which then to get the permit, I have never seen a permit come in that just simply did not make arrangements, on that permit to dispose of that well in a declared EPA-approved injection well. The volumes of these things are not huge, and that's part of it also. It would be well below, and any of those volumes that we're talking about as far as 100 gallons per minute. I mean, they're pulling out a water truck of these things every 2 weeks. So.
So you're talking about a heat recovery opportunity, David?
Yeah, but Jim says the volume seems to be pretty small.
Yeah, I mean, when the pump jack is going, it's pulling out ounces a pull. These things are down 4,000, 5,000 feet deep. They're just little. They're set up on timers just to make sure that they don't get watered in. I don't know what the temperature of that is, but they're required to end up being in a fully closed system within a closed approved tank with the dike around it and all the gas and oil precaution environmental requirements.
Well, Wendy can tell us what the temperature is because she knows the geothermal.
Mm-hmm. Yes. A word of caution as you guys talk about that, you have to be careful, I think, of maybe getting some temperature out of the gas holes, because what we have been trained to do, actually, gases end up flowing. And so you look for kind of temperature lows in some of the gas holes of where the flow is, because the gas is coming out and actually lowering the temperature of what your temperature probe is. And that's one of the reasons that they run a temperature probe in a gas well. They're looking for lows. They're looking for little
gases expand.
No, I mean it's just blowing out. At that point, when they're running the temperature probe, it's an open flow system. It's uncased and they've just drilled it. Now they're going to run the probe down there to be able to map the geology and get a geological log of it as far as the caliber and size of the hole and the whole bit. But where some of those temperature lows are is where there is increased flow that would end up actually having a cooling component to it. Yes, sir.
Do you think the 1981 Act is even relevant if it only applies to power generation?
I do. There was some discussion, as I have understood, they were really even kind of looking at maybe pulling off the regulations a couple of years ago by our director. But you can't end up, if there's a law on the books, you can't end up pulling off the regulations. There is always, and there may be, opportunity and potential to have large scale. In 1981, what they were thinking about is probably these warm springs over in the western anticlines, potential for power generation, potential for electricity generation, large scale things. These smaller scale units hadn't even been invented and developed yet. And so, Virginia is very careful. Some of the terminology is very antiquated in this, but in working with our policy analysts down in Richmond, the legislative group doesn't like to end up messing with something unless there's a real need to. Unless it's proven that it's absolutely not necessary, or they're so busy, if we say, hey, there's a couple of bad words in here, they're not going to go through the process of doing things until push comes to shove and somebody puts in a permit through us and it goes through a little bit of a review process. Maybe there's a subcommittee by the board created. This can happen fairly quickly. And also I think we're under regulatory review every, David, you did this, 4 years? Yeah. By decree, we go through a regulatory review every 4 years, and we have recommended a couple of terminology changes in here, but it's such small taters as compared to the other things that they're doing, they don't even mess with it. So I think under the circumstances, it's probably good to still, keep the law there, but, within this group, you have to be very careful as far as really, the terminology that's being used, both from a legal and regulatory perspective, as far as what that's referring to.
It seems like with above 70 degrees F and 100 gallons a minute, there might be potential for some direct use type applications.
There may, yeah.
Not power generation, but heating or something like that.
Yeah, yeah.
But the act refers only to power generation.
No. That's, I kind of gave that just as an example. The act does not identify any specific application at all. It's just, these are the components that it ends up having a temperature and volume requirement. And then when you think and jump back to 1981, as far as where things were within state of the art and, kind of remembering what TV shows were on, what music was being played, and the kind of clothes we wore. God.
Are you going to call up the homestead? Tell them that they got to start filing some permits? For all their uses. They didn't drill it.
Yeah, those are open flow things.
Above 100 gallons a minute. 98.
I don't know. We'll sit down and talk to you all about that. Yes, sir.
Jim, the only other thing that I've got some calls, and I'm involved with the Virginia Water Well Association quite a bit, and honestly, I haven't really done my homework yet, but there's these geothermal wells out now called DX wells. And what I think I understand is, and they're doing it west of 95 in the heart of our country. I think they're drilling like a single or a small number of very deep wells, let's say 1,000 feet.
Okay.
And they basically put let's say drill a 10-inch hole and put a 4-inch casing in that hole. And basically, let's say they're going to pump water or some fluid down the inside 4-inch casing to the bottom of the 1,000-foot hole. And then as the water is coming back up to the surface, you go back through the heat exchange unit. Okay. So there's no loop. This is not a loop.
It's a hybrid open flow system. Instead of having a production and injection well and kind of moving it through, that they use just one well and have a production component of it and then a return component of it in the same well.
Now, I haven't started looking into this yet, is, okay, let's say in most places in Virginia, you're going to encounter, groundwater. You do a 1,000-foot hole, less than 95 in Virginia, it's very likely you're going to encounter a water-producing fracture, at least one. Anybody disagree with that?
Agree.
Okay. All right. So if you're just going to drill a hole and then put a 4-inch pipe in it and get, water from somewhere else, at some point you're going to be putting a positive head on that system, and you're going to have water loss. Is that okay? I guess that's okay. I don't know. My only point is, I'm getting more and more calls about this DX type of application. It's not the plastic closed loop in a 300-foot hole.
It's a hybrid open flow.
Yeah, hybrid open flow. So that's something else that I don't know about, but it seems like people are putting them in.
It sounds like that would fall outside of both of these regulations.
I think so.
That could be a completely unregulated application.
That was my point of bringing it up.
Yep. That would have been my interpretation too, because probably it has a temperature regime that would be under the authority of the Department of Mines, Minerals, and Energy. It's an open flow system, which means it's not part of Department of Health, but it probably does not have a volume requirement under DMME. So these are the kind of things in partnership with DEQ, the health department. If we start seeing these kind of problems coming in, the agencies have responsibility to getting together and say, okay, now that there's justification to be able to readdress some of these regulations and make sure that doesn't cause a problem. But I've read a little bit. 100 gallons a minute is a lot. like a 3-ton heat pump uses 10 gallons a minute. I mean, something I read something a while ago. So 100 gallons a minute. I mean, we're talking, 40-ton heat pump or something like that. I mean, or well, I don't know, but huge.
But still, Scott's point about you're essentially putting unregulated water down the hole. In our oil and gas regulation, if you're putting anything down the hole, if you're starting with fresh water, it's got to be at least as clean as the DEQ drinking water standard.
Yes, within the drilling component going through for drilling fluids.
Yeah, for drilling fluids. That's stated in our oil and gas regulation. So you hope that there would be something that if they're putting water in a hole, it's got to meet at least the.
Well, it sounds like it really would just be circulation of whatever the fluids are in there.
I've seen the person who was constructing it in Briefing in Massachusetts, basically recycling
Yeah,
water.
yeah.
So it's native water?
Yeah.
Yeah, I mean, they're just pulling the water out.
It's going to be saturated. It may take a while for it to rise up in the hole. And it should come to some equilibrium, but recirculating the water and capturing the heat. They have some heat exchange south and bottom of those 4-inch pipes. So, but the thing that you might be doing though is that by pumping that around, you're oxidizing the water, you're changing its redox conditions. So then you could upset. Once again, for your neighbors drawing their water well from there, you might start mobilizing arsenic or something like that. I was very happy that, its conditions were absorbed iron and all of a sudden.
Yeah, because we just touched on very, very quickly, just as a heads up to you guys, that there are a number of environmental precautions in place within our laws and regulations. We could have spent again an entire hour just on that topic alone, and with different populations, different presentation groups, and that's what they're most interested in. But within that, they do a very extensive analytical suite of both the geothermal fluids and then the groundwater monitoring also. And they end up kind of checking for both elements just to make sure that there's not transfer of any of those things as far as any arsenic, cadmium, any of those components of it. And so, I mean, collectively, if
you're changing temperature, the solubility of the mineral is really affected by temperature.
Yeah, yeah.
So if you're changing those, precipitation, whatever, that's why heat exchangers, power plants follow up a lot.
Right.
You're changing temperature.
Right.
When you analyze it,
it'll bring that out of equilibrium, and some of those things will precipitate out.
It's unsaturated as soon as you change it.
Right. Yeah. Yes, sir.
One point.
Sure.
I would think that you have to be really careful about writing these acts, because I noticed in the 1981 that the act actually could legislate well spacing.
Right.
And gee, that's a tricky business. And nobody, if I want to replace my air conditioning unit in my house, then it's the builder. It's my responsibility to put the right size unit in, not anybody else's. Whereas with that 1981 Act, it sounds like you're going to say what the spacing is.
We do it for oil and gas.
Okay. See, they would be given
For
the
oil and
opportunity
gas?
to.
We do it
Yeah,
for oil and gas.
because.
Do you think that's different?
Yes, it would be different.
Well,
yeah.
Yes and no. I mean, water is very similar, just kind of moving through porosity as gas is. And one of the things that you have to remember as far as the well spacing, Virginia is one of the few states that end up having unitization within gas and oil law. It's not just simply a rule of capture where you come up to the end of the property line and drill down, and whatever gas that you suck up out of that property ends up belonging to that people. That they recognize to protect correlative rights, there are different gas pool units that a well would end up drawing from. There's, I think, 4 of them in Virginia right now. There's a 112 acre round conventional unit. There are 60 acre units in coal bed methane. There are 80 acre units in coal bed methane. Then there are 320 acre provisional units, sometimes with some of the horizontals, and there's actually some 20 acre units that they can end up stitching together as far as one of the horizontal boring. And what this is an attempt to protect the ownership and correlative rights of where that gas pool is for all the owners that are projected up to the surface. So those two things are actually kind of combined together as far as best management of that resource to protect to protect the utilization of that resource and the conservation of it, and also to protect the correlative rights of the owner of that resource down below. Not all states do unitization. Not all states protect correlative rights. But I've seen the way things are done on many, many different states. And quite frankly, it's my opinion, I think Virginia is one of the fairest ones. It creates some other issues as far as some forced poolings that people don't really like to, don't like about that. But it gives everyone an equal opportunity to share in the ownership of that resource and an opportunity to be compensated for the royalty of that resource also. Well, good discussion. I've enjoyed this. Yeah. Anything else? Good. Sure.
Well, we've come to the end of the presentations for today, and the remainder of time that we can spend here is just essentially allocated to questions and discussion, and pretty much wide open. About anything you heard today, we will start off tomorrow with a couple of presentations from Dr. Costain and Steve, who's done another one with Wendy, talking about derivative products that you've been working on, and later looking at some of the geothermal core, actually, that was drilled as part of the program that Dr. Costain was involved with back in, starting in the late 70s. So we can just take a hands-on look at some of that core, its basement rock, interesting stuff.
Yeah, I have one question that I'm kind of curious about, and this is the group to answer, I think. In the last 30 years, what has been the advancements in heat transfer technology? I mean, for example, can we take a binary fluid and what's the minimum required to generate power? Has that gone anywhere in the last 30 years? Our heat pumps surely have become more efficient, certainly. I mean, I would guess. But how much more efficient? Is that changing rapidly? Or are we just looking at a stone wall of thermodynamics and we can't get any more efficient? I don't know.
Yeah, that's a great question.
I know that there are like hybrid turbine systems that can use fluids that will steam at significantly lower than the black point water. How low that is, I'm not sure.
I was kind of interested.
That's a great question. I don't really have a whole lot of knowledge of that industry.
Yeah, well, everything else seems to have just changed so rapidly in 30 years that I would guess the heat pumps and geosource systems have changed very along with it. I know there's a community in Virginia, is it Bridgewater, that has the entire housing complex is geothermal. I have something on my home page about that, my geothermal page, but I've forgotten what it is. And I did Google it, and they're still in business, and they're looking to expand. So it would be interesting to find out. 20 years ago, they put the first housing division in, and how is that changing now? The difference between, well, these are the kinds of things that foster interest in business.
As we discuss this, I think we have to be so very careful as far as the terminology that's being used. What's recognized as far as the geothermal resource against us, within us as scientists and geologists, is very different than what I hear often, a geothermal resource being used by construction and local building code people. That they call a geothermal heat pump, something that just, they're building a house, they'll put a trench in that's 6 feet down, it's below the frost line, they'll put in a slinky loop, they'll put in just, back and system.
But isn't
Technically,
it?
well, as I have read, technically, that's probably, you know, actually more heat from the sun type of system than a true geothermal system. You know, when we as geologists and scientists talk about a geothermal system, I mean, I kind of think of something much deeper, something actually taking advantage of Earth heat. And so this is within a legal and regulatory context. You have to be so very careful of the terminology, scientific terminology overlapping with legal, regulatory terminology and construction and just, you know, kind of informal terminology.
Well, that's a really good point, because I mean, there are several residences in Blacksburg that have what I would call geothermal installations, and their pipes bury about 5 feet into the ground, and they circulate fluid. Mm-hmm. They circulate actually just water, I think. They don't even bother with antifreeze, yeah. Mm-hmm. But in my mind, I thought that was a geothermal system. Am I wrong?
Well, you're right, but I think the definitions are out there between hydrothermal, primary, geothermal, direct use. There's a lot of words out there that explain really what you're talking about, geo-exchange, which is a trade name. That's really what it is. You're exchanging that heat. It's more efficient than air for a heat pump. And you're also correct that it's really solar energy, because it's based on
that's what I read.
the temperature of the average before.
Yeah, top 6 feet or so.
That's right, before you start getting where the temperature changes from the geothermal gradient.
But isn't a geosource system a geothermal system?
Well, you're using the consistency of the Earth's temperature, but it's not coming from emanating from the center of the Earth. It's coming from the sun, the precipitation. The average annual groundwater temperature is the average annual air temperature.
You know, it's sort of you're using the thermal inertia of rock more than anything else.
Yeah. It's just a heat sink, right? Yeah, a temperature sink, and really a heat source of true geothermal, as we as scientists would think of that. Right.
And you're right. I mean, people talk about it and they drop terms left and right. I mean, I've been on radio shows where people call in and you try to explain these different ones. We had a geothermal bill passed in New Hampshire. It was amazing to go in and educate the legislative committee and then have to go back 2 months later to another hearing and then have to re-educate them all over again, because they kind of understood it when you first explained it to them, like a committee that had to aid the committee to get all the facts right as they're developing the legislation. They don't, it's over and above the understanding of the average layperson.
So within the database, y'all may want to really define some of the parameters as far as what this is applying to, you know, what this is being directed for.
Well, I think even within the DOE geothermal program, there's sort of a lot of these sort of geo-exchanger systems are in the, what is it, the home construction? It's sort of
in the buildings area within
green, yeah. So
it moved out of the geothermal area.
And do you know, how do they make the distinction then between what's geothermal direct use and what becomes
when I was working in National Groundwater, I did a lot of work on Capitol Hill. I won't use the L word, but that was our goal. We were educating, and part of that reason is because some of the federal legislation was giving tax breaks, and if it didn't produce primary electricity, it wasn't considered green energy. Geothermal heat pump systems do not, basically. Right. Efficiently using that heat transfer.
But that also would exclude direct use, which is true geothermal.
That is true geothermal.
And that's a different.
Right. And we were trying to convince them otherwise that basically the amount of energy you're conserving is in essence the same as generated. Or, that concept, don't underestimate the conservation aspect of geothermal heat pumps.
Now, you can use these geosource heat pumps in cold climates.
Actually, they work very well.
Yeah, there's a lot.
That's probably where they work the best.
So where's the air temperature there? That's heat from the earth.
Right. But then they
this
only
is
work.
why bridges freeze.
But then a lot of times those heat systems, including in New Hampshire, will only work so well. I think that they only heat up to like 120 degrees versus 130 from what gas-fired boiler or oil-fired boiler.
Yeah.
So you have to have a backup on really, really cold nights.
I understand that, yeah. And, but still, I mean, there are more average days than there are really, really cold nights. So it's a geothermal system. It's heat from the earth. It's doing the job.
I'm not debating, I'm not arguing with you. You're right. I mean, I agree, but I'm just saying that the point made here is that people are confusing that as being energy from the center of the earth, whatever it's not.
Oh, well, it does come there from there. Right?
Well, not the first few feet. It's coming. That's why the groundwater temperature is warmer down here than it is up in Minnesota, because it's the temperature of the air that keeps that water that goes into the ground and heats it or cools it until you get down below about 10 feet or so, and then it's geothermal gradient.
So where does the heat come from then in the closed loop system if you go up to New Hampshire?
In a closed loop system?
Yeah.
The heat is just the constant temperature of the rock, although it is getting warmer as you go deeper.
Which is geothermal.
But it's negligible. I mean, it might be few degrees, but.
Yeah, I think an example of this conversation too is just within the Department of Health's regulations. I think there were 8 different ways that they referenced geothermal heat pumps, ground loop heat pumps, and all. I mean, when I started pulling those out and did a search on those, I was pretty amazed as far as the inconsistency of the terminology that they ended up using. Some of those were actually trade names, some of those were just informal names, some of those are plumbers' names, some of those are heat pump advanced, system, sales type of names and all.
That one website I showed on my slideshow, I can't remember the acronym now, but basically that is a commission that's trying to standardize all the terminology in the industry for whatever reason.
Kim, did you have something?
Oh, I was just gonna, I sent over the questions, and Arlene's been listening as well here, and I don't know, I've unmuted Arlene. I can either read everything that you've sent over, or if you want to chat, you can do that too. But the first site she sent, maybe I can jump on that computer here in a moment and show off the low temperature and co-produced geothermal page for the Geothermal Technologies Office. I can do that too if you're still on GoToMeeting.
I am on GoToMeeting. You have to wait for the projector to boot up.
Okay, no problem. And then the other part of it, and I'll just read here, is that increasingly low temperature resources below 150 degrees C, once reserved for direct use applications such as heating, greenhouses, fisheries, and mineral recovery, can now be used for power generation under the right conditions. Low temperature resources have the potential to draw geothermal resources from across the nation, not just the hotter western states. So, according to DOE, though, what is a geothermal resource? Geothermal resources are reservoirs of hot water that exist at varying temperatures and depths below the Earth's surface. Mile or more deep wells can be drilled into underground reservoirs to tap steam, and very hot water can be brought to the surface for use in a variety of applications, including electricity generation, direct use, and heating and cooling. In the U.S., most geothermal reservoirs are located in the western U.S. Geothermal energy is a vast, underutilized heat and power resource that is renewable, baseload, domestic, and so then the discussion on geothermal heat pump is that geothermal heat pumps, also known as ground source heat pumps, highly efficient renewable energy technology for gaining wide acceptance for both residential and commercial buildings. Heat pumps are used for space heating and cooling as well as water heating. The benefit of ground source heat pumps is that they concentrate naturally existing heat rather than producing heat through the combustion of fossil fuels. So that technology relies on the fact that the Earth below the surface remains a relatively constant temperature throughout the year. We've been discussing this in the last few minutes. Takes advantage of transferring heat stored in the earth from the groundwater into the building during the winter and transferring it out of the building and back to the ground during the summer. The ground, in other words, acts as a heat source in winter and heat sink in the summer.
It seems like the only way you could really make a distinction is when are you looking at the heat that's brought in as meteoric water becomes groundwater, and when are you looking at heat that's as a result of heat flow from radiogenic heat production in the
It's
crust.
all about water. If we didn't have water, it would be like the moon, 100 degrees on the fun side and it's 0 on the dark side.
Right.
It's water that makes that difference.
Yeah, and there's no way to know, I suspect, where the boundary is between water that's bringing heat from the air, as meteoric water becomes groundwater, and there's indigenous water.
Well, except if you're looking at a discharge area as opposed to a recharge area. Then you know if you're in the discharge area, it's coming from below, not from above. If you're in the recharge area, that's different, but 80% of all groundwater basins are discharge areas, not recharge.
But most of these heat pump systems are so shallow that, you know, discharge or recharge. I don't know. I can see. I mean, I suspect there's, you know, there's probably end members where it's easy to tell, and then there's a lot of gray zones where it's, well, it could be some of each. Likely is. So then, you know, when do you stop calling it geothermal and start calling it something else? And I didn't hear anything in that stuff you read where they actually made that, you know, made a assertion about the distinction.
In a way, I think this whole discussion is kind of out of the realm of what we're here to discuss anyway. It's terminology. We're just here to tell you how we're going to get data there for people to use the industry or whatever.
Well, I think that for these shallow systems, though, there is an interesting thing to me, which is the distinction between conductivity and diffusivity, right? And the diffusivity starts to be more important when you're dealing with these heat exchangers. And are we capturing that data somehow?
And hydraulic diffusivity too, right? I mean, you talking about thermal diffusivity?
Yeah, yeah.
But hydraulic diffusivity is important too, because that's a great carrier of heat.
Right, probably much better than thermal diffusivity.
Yeah, much better. Yeah.
What are we looking at there?
Just websites that are leads and sending on. Leads. Under the building efficiencies program.
Kim, what is that?
The geothermal heat pumps out of the building efficiencies program at DOE. And we lost our. So I'll throw in my 2 cents here and skipping ahead again the sustainability portion, but I do think that this is a relevant discussion because Dave, Jody, I'm not sure if you guys were aware, but there was a lab-only request for proposals to do a similar, essentially thermal conductivity map of the U.S. to determine best locations for ground source heat pumps. And so that I haven't heard anything as to where it went. But that went out only to the national labs, and the hope would be that the national labs at least got the process started and did a bit of a gap analysis, but then we could come back into the states and say, okay, states, let's do the same thing that we did for national geothermal data system here in terms of high temperature electricity producing heat for ground source heat pumps, and that's obviously much more relevant to these states in this community than more of the really hot rock discussion in the Southwest. So I think that is something to consider. I think it's also something that, for the state geologists in the room, take back to AASG and the liaison that's coming up, potentially trying to meet with the building efficiencies program and say, hey guys, we've got this program within, DOE's GTO, can we maybe get something similar within building technologies program?
When I was president of AASG, it was assigned this geothermal, lead was assigned role taking that lead, but I know I was a proponent of putting heat pumps away from the beginning. I know a lot of people did not think that it was relevant. And I go, that's the way, because that's where the majority of it's going to be spent, because there's very few places in the United States where you can use direct hydrothermal for enough hot water for direct use. So I agree with that. It'd be interesting to know what the scale is that these labs are producing these maps, because if you're going to locate your house, I mean, it's got to be like the 1 to 24,000. That's where the value is, because the geology changes from one neighborhood to the next. And if you just do this big gross map, it's pretty much useless, you know. And we are in the best driver's seat for that, because we know that the three-dimensional architecture of the geologic units, and we can figure out what those, you know, thermal conductivities and things are. In other words, the lab would just come and steal the data from all the surveys, and then we create the animal. But
not steal.
Sorry, it's free data. It's public data.
That's what we got.
But you know, there's another. I think one of the other big gaps we've got in what we've been doing is the whole question of the economics of these systems. And I know that, you know, there's one of the drivers about reducing risk that was, if you look at sort of a lot of the initial funding opportunity announcements and things for this program, was the idea of being able to do sorts of financial risk assessment, which means knowing something about costs. And of course, you know, for most of you know, as surveys, we don't get that information. What did it cost to drill this well? You know, what's the return on investment for this heat pump system? Those kind of things. And I think moving forward, trying to be able to sort of get that kind of information is probably as important as, I hate to admit it, as the geologic information. It's just getting that actual financial data. And it's hard to do because, you know, a lot of people.
It's often held free.
Yeah, it's all close, right? Because it has to do with your business.
For the example with the Cisco one in Raleigh, that's all well documented. What they're pissed off now about is the fact that their 70% reduction in their cost of doing this was not able to be recovered by the grants as promised.
So it's a subsidy was promised and then went away.
Yeah. So, yeah, it is telling though that when the incentives get withdrawn, they back off of the decision because it's not by itself economically feasible yet, right? It doesn't make sense from an economic standpoint to do this without.
We live in a capitalist country.
Well, right, but I'm just saying that at this point it hasn't reached that threshold where the technology might push it there at some point.
Well, it hasn't in North Carolina, but in places like Alaska it does, where they, you know, where it's really cold in the winter. It does make sense.
Yeah.
Well, hybrid cars don't make sense economically either.
Yeah.
A lot of people are starving them up, right?
Yeah. I have one, or I had one.
Oh.
And it didn't make economic sense.
No, but I mean, even Teslas, I've read this incredible number of Teslas that are being made every month. I couldn't believe it. For $1 million car.
Another thing that would be useful, I think, addition to the information, we're collecting data and trying to disseminate it to enhance the production and installation of geothermal systems. But, you know, there's a significant amount of them that have failed or have not met specifications. I toured one for a large irrigation guard base, and ironically, Michelle Obama went to be there, and within 2 days in this big hangar to make a presentation, and they were freaking out because they couldn't get it cooled. A hot spell, but they had a several $1 million system, and it was done about 10 years ago, so they really didn't have the background knowledge. And, you know, our investigation, the contract was one of the first big jobs they ever did, but they really underestimated the conductivity of the geological terrain. It was glaciated, sand and gravel, and it was not dissipating heat, and they basically had a heat contamination issue.
So underestimated or overestimated the
conductivity? Well, whatever the term.
They weren't getting rid of heat.
They weren't getting rid of heat fast enough. It was
Yeah.
contaminating. You know, they were building it up, and the system was losing efficiency dramatically. So, you know, that's where having this information about the type of material and its thickness and the overburden, because you could actually drill through it and then be in the ground, and you have a whole different world. But you know, they need to know that sort of information to make these planning decisions. A cookbook does not do it. Right. So anyway, knowing where these sites are and what the failures have been and why, I think would be very valuable as well for promoting this right through that. I don't know if that's part of our mission or what, but you know, there is a substantial amount of information out there.
I think Arlene Anderson would say yes, that's not a huge.
But right now, really, there hasn't been a lot of the effort, the state effort is not going into looking, basically doing the research on these kinds of installations that have been attempted and what the outcomes have been. You know, see a little bit of that kind of information, but it's probably something that you do with a systematic sort of approach.
Now, part of the system was they were returning some of that flow, heated flow into a dry one, where they're basically putting right back into the system. They were thinking it was flowing over, it was gravel. Yeah. Just basically percolating back in. Once again, it's a geologic control to fix a mechanical issue.
We've started to explore some of these types of questions that we're talking about now through surveying the consultants in the industry here in Virginia. We've started to, and there's quite a few of them, but there's a handful that deal with a lot of installations. And so one of the things that we can do with state surveys is conduct some of these types of surveys to get a sense of how many installations there are. I mean, one of the actually fairly common question we get just from anecdotally as a state survey is the depth of bedrock. And so we can do some more surveying to find out what sort of needs there are for these lower temperature geo-exchange systems. But at the same time, I mean, we could tune these surveys to look at an outcome of an older system that's been in place for a number of years and see what the economics, you get a sense of the economics. So that would be an area I think would be where a survey could be very helpful in that respect.
Another aspect of this, getting back to geologic control, I'll tell this one by that anecdote again, but Ohio State University had a huge fiasco here about a year or two ago. They're putting in a well field for systems and they're in karst. So they're putting in air rotary blast holes and also made geysers popping up all over campus. Well, they were contracted to put in closed loop grouted systems. And if we are trying to grout in the karst area, it becomes a very expensive proposition. Once again, the state geologic surveys, when you look at these index maps, not only the thermal conductivity data, but also just the geologic fabric. Is it high refraction? Are they vertical fractures? Because that's everything's going to go against the pressure gradient. You're drilling, it's all wanting to come up. And so all that comes into play if you're going to design one of these systems well and ensure its success.
The biologists have the human genome as the seed. What we have are rocks.
And they're mapping the human genome, and we're still doing pretty poor on mapping the rocks.
We haven't been able to invent machines that tell us what's inside there very well yet.
If that's a true figure of 1% of the decline being mapped, I was surprised when I was told that. But
it might be more like 3 or 4, John. But it's not
very much. But it depends on what scale you're talking about, too.
Yeah,
it's all mapped now, if you want to say 1 to a million. But
yeah, but I mean, it's.
Well, people think rocks are boring, and geology equals rocks. Therefore, we have to become trendy, and alternative energy resources is becoming trendy. So we have to jump on that train and prove ourselves as geologists that geology is not just about rocks, it's about the earth. And then all these other opportunities will make themselves available. Simple solution.
Problem solved. Let's go get a beer.
I second it.
I mean, I know in Arizona, one of the issues we face is, this issue about fracturing, right? So we don't, that never gets mapped, right? We were out there when we were doing bedrock mapping. You're trying to look past all the fractures to see the rock, right? Well, it turns out, that it's a whole different project to go out there.
Well, a lot of the mappers of field books, probably most good mappers, that data is there
somewhere.
That capture of getting these other ancillary data sets that could attach to those, private, tier 1 data. It could be all that data.
Right.
Not to delay the beer, but I'm curious, with the other 2 workshops that you've had, where you've had other states participating, I know there's a Western workshop and then a recent one in Illinois. And given that we all recognize that this is where really the market potential lies in these lower temperatures, has there been any sort of discussion about that even with the other states where there are hotter temperature type resources that are probably the real star players, but looking at the more marketable appeal of lower temperature.
We didn't really at the Illinois workshop. I mean, I think we touched on it maybe once. And I care to help.
Yeah, I mean, those workshops were very
They were
data-based, so how do you get your data into this format?
Much more about the technology.
The technology of what to do with the data, not really caring so much about what the data was, as much as we're talking about, which is actually really great.
Yeah.
But I did, the guy in Indiana, I can't remember his name.
Sean Taylor.
Yeah, he was actually doing a project on low temperature geothermal potential in Indiana. And that was the only discussion I had about any low temperature stuff was he was doing specific drilling projects to explore potential for geothermal. But yeah, those workshops were really, truly workshops where we sat at a computer and tried to get data through content models and that sort of thing. So this is really great because I'm writing down all these different data sets we could be filing that. We actually have depth to bedrock data and that sort of thing. So,
It's probably worth noting this
I was just going to
article.
ask if you guys wanted to comment on it.
This is the result of a project funded by the Department of Energy that what's on the screen there. If you look at the title, it's kind of along the lines of the discussion we just had. So it's available through.
And I was actually going to print copies, but because I printed 25 copies of a 50-page document and hauled them with me to Illinois, I decided that it was.
Yeah, it's pretty
I'll
long. You can email it out to folks.
Yeah.
It's an interesting read. I've looked through it.
My question though to you guys, it says not for publication on this version, is that okay?
I believe this probably came off of the Geothermal Data Repository.
Oh, okay, it just says.
Oh, we did.
Yeah, it does say draft on it and not for publication, but it's
I can go ahead and share
on the GDR site, so you could send them a link to that location.
She's sharing, not publishing.
Yeah, we're not
Oh, all right. I will get it out.
Yeah, there are nuances to those terms. You know.
So since it's from your agent or your agency?
Well, it's actually a project funded by the Department of Energy. And
so if you have in there what the definition of geothermal system is?
This would probably include anything that's called a ground source heat pump, which would be those that are powered by real geothermal and those that are powered by the earth just being heat sink, you know, and anything in between. So this is would qualify as the topic we've had of heat pumps that use the earth as a mechanism to gain more efficiency. That's really what it is. And whether it's actual heat coming from the center of the earth.
Is that a penguin test? It walks like a penguin, talks like a penguin.
I think it's one of those all geo exchange systems are geothermal, but not all geothermal systems are geo-exchange.
Yeah, exactly. And you know, the whole terminology thing about geothermal heat pump has been a sensitive topic at DOE as well as other places. You know, there's a lot of people on both sides of things. I don't have a particular stance. I like ground source heat pumps as the term.
I always thought that, you know, the requirement of burying your water line below the frost line was prime evidence. All right, I guess we ought to go for a beer then.
Where are we going? We will go to the South Street Brewery, and it's on the map that you have. And what we can do is have a caravan. There's several of us here. We don't know where we're going. Who are you?
Can you park in the train station? We'll have a meeting next
Yeah. So I noticed.
One guy that reviewed
Excuse me, let me ask you another question. Who, as far as the trip to the brewery, how many folks want to plan to drive? And are there any that are staying at the Boar's Head that plan to go to the Boar's Head before you go there? Just need to get a.
If somebody wanted to carpool, I could be. I mean, I've got a car. We can meet at the Boar's Head.
Okay.
I'd like to find a driver so I can have more than one beer.
I'm planning to drive, but I'm heading back north after.
So if anybody wants to meet at the Boar's Head.
Okay.
We can just
So,
go straight.
so there's no one here who wants to go to the Boar's Head first? Anybody?
I'm not going, but I have an SUV, and if anybody needs picked up, I can leave my cell phone, and I can pick people up if you've had maybe more than one drink.
Wow, well, that's
Oh.
No, I know, okay, so my girlfriend's
So the best scenario here would be for people to carpool as much as possible to reduce the number of vehicles, to optimize our capabilities of parking. So join with your friendly friends as much as you can.
well, there is a luxury car.
I have space.
And the one thing I've seen is I would leave the house here. Can you
route has to be unless we take it back to the it should not do that because double check delete.
I've never done that many times. I've never done a multi-day workshop.
There's also
And if you want this type of thing, I go to South Street, so I'll tell you how to get there and how to set up. I watched my together on